All over YouTube, there are thousands and thousands of React tutorials, but very rarely do you see a genuine modern React app built completely from scratch. So in this video, we're going to start from absolutely nothing, meaning a completely empty terminal to a production-ready React app. We'll use technologies like React Query, Tailwind, Skeleton Suspense loaders, API fetching, interactive maps, light mode and dark mode, responsive design so it looks great on this device, and this device, and basically everything you need in order to build a modern React app that looks and works great. I'm going to have very minimal editing of this video. It'll pretty much be a raw cut of me building out the entire project. It'll be split up into segments, so if there's certain parts you don't care about, or certain parts where you want to see exactly what I do, please feel free to skip around. You're not going to offend me. In the description, I'll link the GitHub to the project so you can clone the repo and check the whole thing out for yourself. Without wasting any more time, let's get right into it. Here's a quick snippet of the project that we're going to be building. It's a real-time weather dashboard where you can access the weather data at any latitude and longitude coordinates across the entire planet. We'll be using the OpenWeather API to get all of this data and combine everything we know about React to make this a buttery smooth and highly functional React app. Let's get it. To create a new React app, go into your terminal, making sure you're in whichever folder you want this project to be in, and run npm create vite at latest. Vite is a build tool that takes all of your React files and builds them into the actual app that you see on a web page. This create vite at latest command will create a Vite project that gives us a great starting point. Once we've run this command, it'll ask us a couple of things. First, okay to proceed. We'll say Y for yes. It'll do that, ask for a project name. We'll just call this weather-project, something super simple. It'll ask for a framework. We'll say, of course, React. And for variants, we're going to choose TypeScript. Roll down Vite, for now, we'll say no. We don't really need that. And then with npm, we'll go ahead and say yes. And there we go. It just created our Vite app, and it actually just launched it. If we control-click the link that it gave us, it'll take us to this page here, and this is our web app. At least, it's the starting point. To actually get into your code, go to open folder and open the folder that you just created. So whatever project name you gave it, go ahead and open that folder. And this will actually open up your code. Let's zoom this out so we can see a little better, and also just collapse this agent window on the right. This extremely simple process of running npm create vite at latest is my preferred way of getting your React app up and running super quickly, so it's always what I recommend to anyone watching. Vite is pretty much the industry standard now, as it's a fast and super efficient build tool, so setting up this Vite project with this boilerplate code is a perfect way to start a React app. All projects that you create with Vite are going to look something like this. I'll zoom in so you can see a little better. If we look in our file explorer over here to the left, you'll see we have a couple of files and folders. Most of these config files down here you don't have to worry about too much right now. They're just settings for the overall project. What we really care about overall is this source folder, which is where we have all of our React code. React apps built with Vite will always have main.tsx as the entry point to the React code, so it all starts here in this file. We render out this app component, which if we go into it, is the code that we actually see on this page over here on the right. So main.tsx is the entry point for our React app, but app.tsx is the primary component that we're going to be working in. Vite has hot module reloading, meaning if I change anything in the JSX here, I add a bunch of characters and I save the file, it'll update in real time on the page. We've got a couple other random things on here like some anchors, images, divs, whatever, but as promised, we're going to start from a completely clean slate. So let's actually take all of this, completely wipe it out, Control S, and we'll start completely from scratch with nothing but a blank page over here on the right, which also means I don't really care about this count and set count state, so I'll get rid of that as well. If we look, we have this app.css file, which if we go ahead and open it, you can see we have some boilerplate CSS, but honestly, I really don't care about it. So let's go in here, app.css, and let's just completely delete it. So we'll also remove this import so there's no weird import errors. Go ahead and save it, and we've completely obliterated the app.css file. Lastly, we have this index.css, which again just has some more boilerplate. There's a bunch of random anchor, body, button, and some animation stuff here at the bottom in this CSS file that again, we don't really care about. So let's actually delete everything from here up to here. I don't want to completely get rid of root just yet because we might use some of this, but let's get rid of all that and go ahead and save it. And now we've also wiped out that CSS file. We'll still use some of this basic stuff like this background color for now and some of this font stuff because this index CSS file is imported directly into main.tsx, meaning anywhere we have any React components in our code, we'll use the CSS file. So this is fine for now. Let's go ahead and leave it alone. We'll close it, and let's go back to app.tsx, which again is the component that we actually care about. Right now, our app on the right is running out this app component, which obviously is nothing because this app component is nothing. And we have really no CSS besides a few things that I just saved from index CSS. So we're starting completely from a blank slate. We don't have a template, no weird style sheet stuff going on, not a bunch of stuff we're copying, just a completely blank page. Now is where the fun begins. Let's start by talking about some of the infrastructure for this app. There are two technologies or packages aside from React itself that are going to make up the core of this project. One for styling and the other one for data fetching. For styling, we're going to use Tailwind, and for data fetching, we're going to use TanStack query, which is the same thing as React query. So before we get too far into our coding, I want to get the infrastructure for these two things set up right now so that we don't have to worry about it later. So let's start with Tailwind. If we navigate to Tailwind's website and go to the installation tab, the default installation is for Vite, so we can easily just follow this guide. We've already created our project using the npm create v-latest command, so we can go ahead and skip this first step. Next, it tells us to install Tailwind CSS and @Tailwind CSS/Vite. We'll go ahead and take this command, copy it, paste it over into our terminal, and run that. Next, it tells us to add this Tailwind CSS to our Vite plugins. So if we go to our files, we go over to our vite.config.ts, we go ahead and look in here. We already have React as a plugin, so let's just add Tailwind CSS as a plugin, just like this, and go ahead and save this file. Next, it'll tell us to import Tailwind CSS into our index.css file. So we'll take this import here, go back to index.css right here, and go ahead and just add this import at the very top of the file, and go ahead and save this file. And then all we have to do is restart our build server just in case. So we'll terminate this, make sure to run npm run dev again, which again is the run command. That restarts our build server, and now we are actually free to use Tailwind in our app. So we can go ahead and close these, and that is all we need to install Tailwind. It's a super simple setup process. To test this and make sure it works, if we go into app here, let's just make this a div. I'm going to give it a class name of size 32, and then bgred500. This is the whole point of Tailwind. You can write styles in line like this instead of having to have dedicated CSS files. If I go ahead and save it, you can see we have this red square up here on our screen, so Tailwind is working perfectly. I can change these in Tailwind, start messing with it, and everything I do will be Tailwind valid because we set it up really easily. Cool, so we know Tailwind works exactly like it should. If you're not super familiar with Tailwind, just know it's a way of writing super nice and convenient styles inside the class name of your JSX elements, instead of just spamming CSS files and random classes everywhere and getting messy. We'll be using it throughout this entire video. Now that we have Tailwind added for the data fetching part, we're going to add TanStack query, which some people still call React query, into our project. I have 2 whole videos on TanStack query. If you don't know how it works, that I'd suggest checking out. But otherwise, I'll assume you have at least a foundational understanding of it as we work through this video. This library is also very, very easy to add, just like Tailwind. If we go to the installation docs for tanstackquery.com, we can look at the npmi command to install it. So let's go ahead and copy this, go into our terminal, and install TanStack query into our project. With that done, there's only one more thing that we need to do. If we go back to main.tsx, which again is the entry point for our app, we need to set up our query client in this file because TanStack needs that in order to have context to the queries that we're going to be making. So in main.tsx, we'll first want to make a new query client. To do that, we'll just say const query client equals new query client, just like this. That is from TanStack, and we're intentionally doing this outside of any sort of React component because we only want it to be created once. We don't want it to have any sort of re-rendering or nothing involving the React lifecycle. And then what we'll do is highlight our app here, Control-Shift-P, type wrap, and then we're going to wrap this right here with a query client provider, just like this. We'll import this also from TanStack like this, and this component takes in a single prop, which is just called client, where we can pass in our query client. This query client provider right here works just like any other provider you would use with context in React. It is just what TanStack query requires to have a functional query client. Now that's done, we can close out of this file, and we've just got 2 huge foundational steps out of the way. We have our styling component installed and our data fetching component installed. So we're ready to go and use both. Speaking of data fetching, how are we actually going to do that? I mean, I know how to fetch with TanStack query, but what data are we actually fetching? We want this weather dashboard to show real-time, up-to-date factual data on our page, not just some mumbo-jumbo, hard-coded garbage. This is where OpenWeather comes in. This whole entire project is not possible without them. OpenWeather is a giant API that allows us to get all sorts of accurate, real-time, and historical weather information. OpenWeatherMap.org is where we can find all the information about them, including their API docs. If we open the menu over here and go to the API page, I can start scrolling and see all sorts of different types of information that we can get that's from weather. So current weather, hourly, daily. You can see there's bulk downloads for stuff, solar irradiance, history, weather maps, air pollution, and all sorts of other APIs that we can use from this site. Some of these APIs are locked behind paywalls, but the ones that we're going to be using are completely free. The primary one that we're going to be looking at is this one call API 3.0, which is their main one. Basically what it will do is it will give us the current weather at any location, the hourly forecast, daily forecast, minutely forecast, and a bunch of other stuff. We're not going to worry about minutely in this video, but we will be using the current, daily, and hourly weather information to populate stuff on our page. If we click into the API docs right here, I can show you exactly how it works. If we scroll down, it'll tell us exactly how to make an API call with this link right here. I can zoom in so it's a bit easier to see, but it's just this URL that it gives us. All we need to do is call this, pass in latitude and longitude coordinates, and give them our API key. But basically, how we'll be able to click on different areas of the globe and get the weather information for anywhere on the entire planet Earth is through these latitude and longitude arguments that you can pass into this URL. And we'll have some other customization options like exclude or whatnot that we'll also take a look at. But for right now, let's focus on this API key right here. If you try to hit this whole URL right here, this API, with no API key, we're going to get an error 400 telling us that we're forbidden from accessing it. If you've worked with APIs in the past and you're familiar with them, you know this is pretty much how all APIs work. If you want to use the service, you have to get a key through the service first that you can pass through to each API call. To get an API key for OpenWeather, all you have to do is click on this API key tab right here. If you have not made an account with OpenWeather or you've never used them before, go ahead and create an account right now because you can't get to this page without an account. Before you create an API key, it'll most likely ask for payment information as well, but don't worry, you don't have to pay a single dime. Everything that I'm doing in this video is completely on the free tier, up to 2,000 calls per day. So as long as you're not spamming 2,000 plus calls every single day, which you definitely shouldn't be, it's completely free. They just want the payment information in case you go over. Once you've gotten through all the logistics like creating your account and you get to this API keys tab, you should be able to generate an API key. My API key is right here. So what I'll do is go ahead and copy this entire key because we'll be needing it in just a second. What I will usually do for storing API keys or other sensitive information is go to my file explorer and at the root level, create a new file that I usually call .env.local, just like this, where I'm going to be storing my private environment variables. You don't want API keys leaking out to the public because then people could spam with your key and end up running up your credit card. So it's usually something that you want to hide. And before anybody tries to get funny and run up my credit card with this key, I will be destroying it before I post the video, so don't think about it. If we take a quick look at our gitignore file, you can see that any file that has this .local on it is going to be hidden from Git. So this .env.local is not going to be pushed up, so we don't have to worry about it being public. Luckily for us, Vite has a very simple way of doing environment variables. We just have to start the name with Vite and then Vite will recognize it. So for this, we'll just say Vite underscore API underscore key equals quotes, and then we'll paste in the API key that we copied from OpenWeather, and then go ahead and save this file. Now anywhere we need to access our API key, we can use Vite's environment variable system to use this value in a safe and protected way. Okay, now that we have that, let's take a second to think about what we should do next. We've created the basis of our React app, installing Tailwind and TanStack query in the process, so we've got a blank app page that we can start working on. We also got an API key from OpenWeather, which permits us to call their weather API to get the information that we'll be populating our page with. In my opinion, the next logical step here would be to set up some functions that we can easily call in our React components that will fetch us the API data from this link right here from OpenWeather. So let's go ahead and do that. We'll start with this API call here. We'll write a function that will take in latitude and longitude as arguments, and then what it will return will be the actual weather data. If we want to see what the return value is going to look like, we can scroll down to here where it gives us the example of an API response, and we know that this function that we call is going to return something of this format. So again, it'll have stuff like the latitude, longitude, time zone, current weather data, minutely, hourly, and a bunch of other stuff. So just to reiterate, this function will take in latitude and longitude as arguments, and it will spit back out the weather data for whatever we pass into it. Let's go ahead and do that. Now, normally I would want to split up API functions into different files and folders, but since we'll only use a handful of different OpenWeather API calls, I'm just going to make a single file inside of source here that I will just call api.ts. And in here is where we'll make our functions that interact with OpenWeather. The first one will be the one that we just talked about. So let's just say it's going to be a function. We'll say export async function, and I will call it getWeather. Let's look back over at our page over here and take this exact link right here. So I'll go ahead and copy this. Then we'll go back over to our code. Let's say const results, and we're going to say equals await fetch quotes, and we'll pass in this link. And actually, instead of using quotes, we're going to use template quotes so we can inject some stuff in there, just like this, and this will be our basic setup. If you've interacted with any API or backend before, you know that fetch is the standard way in JavaScript of interacting with HTTP to get responses like that. If you want to, you can also use something like Axios, but for this video, we're going to keep things simple and just use fetch. So we're going to fetch, and we're going to give it the OpenWeather API link right here. Like most fetch requests, we'll want to parse this into JSON format. So let's go up here, and let's just say const data equals await res.json to parse it into JSON format. Again, our API response, if we look over here, is going to be an object with a bunch of stuff. And if you look closely, this actually is in JSON format, which makes our life a lot easier. Last thing we'll do is return data. And this function is essentially done for the most part. Very, very simple. All we're doing is fetching the OpenWeather link, parsing that as JSON, and then returning it. What this means is if all goes well, I took this exact link right here and pasted it in here. So if I ran this in my app, I should get this exact response object. Obviously the numbers would be a bit different because it's probably a different point of time that I'm doing this, but you get the picture. There's a few things we need to make our getWeather function actually work properly. The first obvious problem is that this is just a hard-coded link with hard-coded latitude and longitude. In our case, we want to be able to pass in latitude and longitude, not just hard-code the value. So let's give this function some arguments to take these in. You can do this in two separate arguments if you want, but I'm just going to put them inside of a single object, so I only need to pass in one thing. So I'll just say an object expecting latitude and longitude. And to make TypeScript happy, we'll say its type is going to be latitude, which is a number, and longitude, which is also a number. All that we're saying here is for getWeather, we're expecting a single argument, an object, where we are destructuring latitude and longitude. If we want to use it in our API call, because we use the template quotes here, we can inject JavaScript directly into the string. So right here where it says latitude, let's take this, replace it with $, brackets, and we can put in latitude like this. And for longitude, we will do the exact same thing. Now, the latitude and longitude that this API calls will be directly decided by whatever latitude and longitude we pass into this function. For the last thing, we need to do this exact same thing for our API key. And this is where the environment variable that we just made comes into play. At the very top of this file, but outside of this function, let's make a variable for our environment variable. So all I will do is say const API key equals. To properly use Vite's environment variable system, all we have to do is import .meta.env. And then whatever the name of our environment variable is. We named ours v_API_key just like this. So now this variable has our API key. If we go back real quick to our env.local, you can see this is v_API key. So we'll just want to make sure this matches 1-to-1 right here. So now anywhere where we want to use our API key, we can just use this const right here. What that means is in our fetch over here, instead of doing this random app ID thing, all we have to do is get rid of this, make this also $curly brackets, and pass in API key just like this. Now we're not only passing through latitude and longitude from our function arguments, but we're also passing in our API key that we're storing in our environment variables. And now this function is good to go. Now that we have the essentials, this function getWeather will actually work now and return to us weather data from OpenWeather, assuming we pass in valid latitude and longitude coordinates. However, there's one more quick thing I want to change. First of all, I prefer to have my weather units in Fahrenheit. So after longitude here, I'm actually going to make another argument. I'm going to say %units equals imperial, just like this. If we scroll up in the API, it mentions this. If you look here in units, you can pass in standard, metric, or imperial. So I'm going to use imperial. But for your own app, feel free to use whatever you like. There's also this exclude right here. I mentioned that we're not going to be using the minutely data, so we might as well exclude that. So in addition to doing the units imperial, I'm gonna add another one. I'll say ampersand exclude equals minutely, just like this. And we're also not going to use alerts, so let's do comma separated and go ahead and exclude that as well. So now we've customized this function to do what we want and have all the essential things like passing in latitude and longitude and returning the data that OpenWeather gives us back. And now that that's done, we should actually be good to go for this function. We can take in latitude and longitude. We fetch the OpenWeather using those coordinates by passing those in to the fetch call, while also passing in our API key. We parse that data as JSON, and then we return it so that we can use it in our React components. Let's make sure this file is saved, and now close it and head back over to our app and take this function for a test drive. In our app component, we're going to make a useQuery for this API call to see if it's actually working. So up here at the top, how we normally do useQueries with TanStack query is we'll say const, we'll extract data out, equals useQuery, and then we need to pass in a query key and a query function. We'll make sure this is imported from TanStack. So for our query key, we don't really care for right now. I'm just going to say weather. And then for our query function, this is just going to be the function that we just wrote. So we'll say parentheses like this, call get weather. And like we just did with get weather, we'll import it. Remember that it is expecting a single argument that's an object that contains a lat property and a lon property. So right here, we'll just say lat, 50. And also lon 50, just like this. We're just hard coding them for right now to make sure it works as expected. And then in our JSX, to make this super simple, let's get rid of this div right here. And let's just go in here and let's just json.stringify data. That way we can at least see it on the page. Let's go ahead and save this now and head over to our page. And we can see, boom, we have this huge wall of text that now has a bunch of weather data. I'm not going to individually parse through everything in this massive text wall, but if you look at the very top right here, you can see the response that OpenWeather gives us at least says lat 50 and lon 50, so we know it's the right coordinates, which gives us a time zone and an area of somewhere in Asia. If we go back into our code here, and instead of doing 50-50, let's do 10-25, for example. Go ahead and save it, refresh this page, and you can see now we have lat 10 and lon 25, which is somewhere in Africa. This stringified data is obviously super hard to read because this is not really, the intended way of printing all this out. But if we go over here, right click inspect, and at least open up our network tab, at least open up the network tab here, go ahead and refresh this and look at this. You can see we get it all in a nice JSON format, so it's a bit easier to read if you want to see what's going on. If I just zoom this in a little bit, you can see we have, again, the lat lon, the time zone. We have the current weather data, so stuff like the sunrise time, sunset time. We have the temperature, we have the dew point, visibility, all this other stuff that pertains to the current weather information. Then we have hourly, which is an array of all the hourly forecast data. So this would be the forecast for the first hour, forecast for the second hour. You get the picture. And then if we actually, let's say, collapse this here, you can see next we have our daily data, which is pretty much the same thing. It's an array where each object represents one day. So this is day 1 of our forecast. Here is the second day, same thing. And I think you kind of get the picture on what all this data is. This is a hugely important part of our app that we just got out of the way. Our React app is now interfacing with an external API, grabbing the appropriate weather data depending on what we pass into the getWeather function. So this is super cool. It's a huge part of a React app that we just dealt with. Before we go any farther, however, we should fix something. If we go over to data here and we hover it, it's going to say the type is of type any. And this, for one, is completely expected. Whenever you make an API call and then you parse it as JSON and then just return it, because you're parsing just pretty much a raw response string as JSON and returning it, TypeScript really has zero way of inferring what the actual data type looks like. Working with data that has type any is generally a big no-no with modern TypeScript apps, primarily because it makes it so easy to try and access things that don't actually exist, and it just leads to a lot of potential errors. If you've used quite a bit of TypeScript, you know that having smart types where you can get IntelliSense and you can know what properties exist and what you can and can't do is super helpful as a developer, and lacking it makes developing 10 times harder. So let's fix this type any and make sure data is the actual response type that matches what we're seeing over here in the network tab. The way that I prefer to do this is by using Zod. If you don't know about Zod, it's basically a type validation library that will ensure all of your API calls are typed properly, so you don't have to work with type any everywhere in your code. It'll also throw errors if your API response doesn't match the type that you give it to ensure 100% type safety. This isn't hard to set up at all. If we go to the Zod docs, it tells us to install it. All we have to do is run npm install Zod. So if we go into our terminal, let's just run that here and install Zod into our project. And then what I will typically do is in our source folder, I will create another folder that I will call schemas. And in here, I can put all of my Zod schemas. If you want to know how Zod works, let me show you real quick. In this file, I'll make a new schema. I will just say weather schema.ts, just like this. Basically, to make a Zod schema, all you have to do, if you want to make an object, is say something like z.object. If you want to make an array, z.array, string, z.string, you get the picture. Basically, what we'll have to do with Zod is go to our API and find what the response is going to look like. So for OpenWeather, it's going to look something like this. And then we'll have to make a schema that matches all the types. So it'll be an object that has, for example, latitude, which is a number, so z.number in Zod. Longitude is also a number. America/Chicago is a string, so z.string, and you get the picture. Basically, we're just building out a Zod schema to match the exact shape of the OpenWeather response. I'll be honest, I'm super lazy, so instead of going hand by hand and going every single one of these properties and then making a schema thing for it, what would be easier is just to use something like ChatGPT to generate a schema real quick. What I'm going to do is actually copy this entire example response here. So we'll go ahead and just copy this entire sample response object, go to ChatGPT, paste that in here. I'm going to say, please make me a Zod schema that matches this exact shape minus, I don't want minutely and alerts. So I'll do this and it should spit out a schema that pretty much matches the exact shape. So we're going to take this actually exactly at face value. Let's see, we got all this. Yeah, so we'll take this, copy it, and in weather schema, let's just paste that entire thing in. So it's 100 lines, a lot of stuff, but again, doing this by hand is super tedious and I don't recommend doing it. I'd rather just use something like ChatGPT to do it for me. So if we go ahead and save this, now we have a weather schema that is hopefully valid. If it's not valid, this will throw errors. So a good test would be to just plug it in and see if it works. Again, like I said, just quickly going over Zod. For each field, we'll just want to map to the Z type or the Zod type. So like z.string for time zone, z.number for the offset, dt is the time, so it's z.number, and you get the picture. Almost all of these are just numbers, so having z.number is super simple. So this actually isn't a crazy Zod schema, even though it looks a little bit complicated. So how to actually use a Zod schema is once we have our schema defined, we can go back to our API function, which is getWeather, and instead of just returning data like we are here, what we can actually do is we can return the weather schema. So we'll say weather schema, make sure we import that from the schema we just made, .parse, and then we pass in our data just like this. Now, if we go ahead and save this, we're going to parse through our schema, and we're assuming that data is going to match this schema shape. So if we go over to app now, and we hover over data, now data should be the exact correct type. If we go ahead and head over to our page here and just refresh this, it looks like we're not getting any breaking errors. So I think it's safe to assume for right now that this schema is right. Hopefully ChatGPT didn't just sell us short and it gave us a correct schema. If it's wrong for whatever reason, we'll have to correct it going forward. We're not going to get any sort of weird type any, and by doing this, we're likely going to avoid a bunch of future type issues. Anywhere now in React land that we want to use this data variable, we can use IntelliSense to know what properties we can and can't access. For example, if I want to access the current weather data, I try and do something like data.whatever. IntelliSense now knows that I can access current, daily, hourly, or any of these things because data is typed properly. That's something that's going to be really helpful going forward. Sweet. Now that that's out of the way, what do we do next? Now that we have the current, hourly, and daily weather information fetched in the way that we want it to, I think the next logical step would be to create and style the components that are going to be holding this information. We could handle all the data fetching at once and then save all the styling till the very end. But sometimes doing that creates a monstrous amount of styling if you save it all to the end that I tend to not like very much. So we'll break down each section of the page with functionality and styling before before moving on to the next section. Here's what I kind of figured and envisioned for our end product. We want to have a dashboard that has multiple cards on it, each of which holds weather information like hourly forecast, daily forecast, current weather, and you get the picture. It would make sense logically if we made this a single card component, and then the inner content of each card would just be the card's children. That way we have a shareable and reusable component that we can use for all of our stuff on our dashboard instead of having to rewrite a bunch of code. With that being said, let's go over to our file explorer, and in our source folder, let's create a new folder called components where we're going to make all of our primary React components. And because we'll end up having different types of components, I'll make yet another folder inside of components that I will just call cards, just like this. And inside of cards, let's make a component called card.tsx. If you have the React Shortcuts extension in VS Code, you can just type tsrfc, which stands for TypeScript React Functional Component, press enter, and it actually makes a skeleton for the component to avoid you having to write some of the boilerplate. Because we want each card on the dashboard to have the same outer styling, but be able to change the inner contents of it, we'll give this card a children prop, just like this. And instead of rendering our card right here, we will just render out children. And to make TypeScript happy, let's make sure we add it to our props. So we'll say children, which is of type React node. Just in case we need to add more customizable styling later, I want to make this div that holds the children different from the outermost div of this whole component. So if I highlight this whole div right here, Control-Shift-P, and type in wrap, I'm going to wrap it in a second div. And before we get any farther styling this component, let's see what these cards look like if we pass in some data that we already have. So let's go ahead and save this card right here. Let's go into app.tsx. Instead of rendering out data just being stringified, let's actually do something else. For now, what we're going to do is wrap this all in parentheses to make sure it is valid. And let's actually break this into 3 separate chunks here. So we'll render out card just like this. And then let's copy and paste this twice. So we have 3 cards on our page. And then for each one of these cards, I'll pass in data that we're already getting from OpenWeather. So for this first one, what I'll do, I'll just pass in json.stringify, and I will pass in the current weather data, which if we hover data, is just data.current. So we'll do data.current. And then for these next 2 cards, I want to pass in hourly and daily. So I'll take this, copy and paste it. This will be data.hourly, because again, if we hover data here, we can see hourly is this array, and daily is the exact same thing, so we'll do data.daily. TypeScript will say this can possibly be undefined, so let's just add a question mark here to each of these to make TypeScript happy. And if we go ahead and save our page, now we'll have 3 cards for each type of data, both the current, hourly, and daily weather. Nothing really looks different right now since we haven't added any styles, obviously, but at least now our data is broken out into cards. So let's now go back to the card component we're working on and get some styling for this. So using Tailwind on this outermost div, let's give it a class name. And generally the first thing I like to add to new components, especially ones that have a background color and some borders, is padding. So we'll add a class name. We'll have P4 for padding, just to create some separation between the content and the outer edges. And then we'll also give it rounded XL to make it a little bit rounded. And we'll say BG Zinc 900. Go ahead and save it. And it still looks pretty horrible because you still can't really see any sort of separation, but we're at least getting somewhere. It still looks pretty horrible because there's just this massive text wall. So let's go to app, and instead of stringifying the entire thing like this, let's actually take that string and let's just take the first 100 characters for each one of these. So I'll add this .slice 0 to 100 for each one of our cards. And now it's a lot easier to see. We can at least see where each card begins and ends. This makes it a bit better, but let's actually make this fragment right here into a div and also give this a class name. And let's give each of the cards some separation. So we'll say flex call to put it in a column layout, and we'll give gap 8 to create even more separation between the cards. Go ahead and save it, and now that's even better. If we now go back to our card component, let's add a couple of more things. First and foremost, the majority of the time you have an element that is kind of close to the color of its background, like these cards here. Adding shadow can generally be good because it helps create a layered look. It makes the cards pop out against the background. So on these cards, we'll also just throw a shadow. We'll try MD for now, save it, and that creates just a slight separation against the background. Next up, let's think for a second about how we want these cards to actually be used. We know each of these cards is going to represent one portion of our data. So we'll have one card for current weather, one for hourly, and one for daily. How do we know which card is which just by looking at it? Well, the most clear way to show which card is which would be to give each card a title. That way the user knows which card they are actually looking at. If all the cards are going to have a title, it would make sense just to put that title in this card component here and have each render of this card pass down a title prop. That way we know what to display. So what I mean by that is inside card above the children here, let's make a header. We'll say header 2 for right now. And let's say is going to display title. Title will come from props. So we'll add title to our props here. And to make TypeScript happy, we'll say that title is going to be a string. To make this title actually stand out like a header, let's go on to this, give it a class name, and let's give it text 2XL, and then font semi-bold to give it a sort of title-ish look. And go ahead and save this card. If we now navigate back to our app, TypeScript is going to complain because we said title is a required prop, but we're not passing it in here. So for each one of these cards, let's actually pass in the title. For the current weather card, let's give it a title prop. And we'll just make these all strings. This will just say current weather. And then for our other two, let's do a similar thing. For the hourly card, instead of saying current weather, this will just say hourly forecast, and we'll specify that it is 48 hours. And then for our daily information, we will just put this as daily forecast. Go ahead and save it. And now our cards have a title on them, which we've just done through this title prop. Super simple. We need a bit more separation between the title and the actual information of the card. So let's go back to our card component here. And on this class name here, let's give it flex call, and gap 4. That'll make sure the title always appears above the children with a decent gap between them. Save it, and it looks a little bit better, some more separation. We may come back to this shared card component in a bit to change or add some things to it. But for now, let's actually work on getting the specific cards set up. So the daily card, hourly card, and the current card. So we'll go ahead and close out of these files, go back to our app, and let's ask ourselves, starting from daily forecast, what do we actually want this card to look like? Well, before we figure that out, preferably I wouldn't have to build out the entirely daily card within this app component, because then that would get a bit bloated. So let's actually make a new component for this card specifically. So inside of this cards folder that we already made, let's make a new file. We're just going to call it dailyforecast.tsx like this. We will tsrfc, the same shortcut we used before, to make the component like this. And now we have our daily forecast card. Let's go in here, take what we already have for this card like this. Let's cut it, paste it into this component. Make sure to import card. Go ahead and save it. And instead of rendering out that, we will render out this component we just made in app, daily forecast, just like this. So we just componentize the card. We'll do the same for the other two, but for right now, let's stay focused on daily forecast. However, having this in a separate component only introduces one problem. In this component, I have zero context to any of the weather information that I'm fetching in the app component up here in the useQuery. So I'm trying to access this data right here, but I haven't fetched data in this component, so I have no idea what data even is. To fix this, I'm going to do something that might seem a little bit strange at first. I'm going to take this entire useQuery that we already have in app, and I'm going to copy and paste it verbatim into this component right here, making sure to import useQuery and also to import getWeather. And now if we save it, it should at least fix the error, so now we can see our page again. The reason I took the same exact useQuery and just copy and pasted it into this component is that as long as these two useQueries have the exact same query key, which they both do, they're both weather, then it should only query once because these app and daily forecast components will mount at the exact same time. Even though it's two separate useQuery calls, it's smart enough to still only fetch the data once. Here in a little bit, we'll be refactoring it and taking this useQuery out of the app completely, but still, it's not a problem for right now. Like I said, we're not going to be double querying because we have the exact same query key in both of them. And actually, instead of using useQuery, I'm actually going to change this to a use suspense query instead. Later on in this video, we're going to add skeleton loaders, so I want suspense boundaries around each one. You'll see what I mean later by this, but in order to do that, we'll need to have this be a use suspense query rather than a regular use query. More on this later. Alright, now let's put our creative caps on for a second. From a very rough standpoint, what do we want this card to look like? Keep in mind before you roast me, I'm not a graphic designer, so this drawing is not going to be super pretty. What I was thinking is we would have our card here in this rough little box like this, and OpenWeather in its doc says that the daily forecast is an 8-day forecast. So in my mind, this card would be broken out into rows like this, one row for each day. For each row, we'd have a couple of things from left to right. The first thing we'd have on the very left side for each row is the day of the week, like this. So Monday, Tuesday, Wednesday, whatever. Then next to it, we could have an icon, like for whatever the weather's going to be for the day, whether that's sunny, cloudy, rainy, whatever. Here, I'll draw a little sun in here. It's not super amazing, but you get the idea. And then we would have 3 more numbers for the rest of the row. We would have the average temp, so for example, like 73 degrees. We would have the min temp, so something like 61. And then the max temp, so something like, I don't know, 77. And each row would roughly, for the most part, look like this. So we have the day of the week, followed by an icon, followed by the average, then the min, then the max. And this would be 8 times because there are 8 items in our daily forecast. Again, show me a bit of mercy. I'm not a graphic designer, so I know this, doesn't look fantastic, but I think you kind of get the idea. So let's take that very rough draft design and translate it into JSX using Tailwind. So the first thing I'll do is just wipe out our data here entirely. We don't care about it for right now because we're going to format it. Let's make a div inside of here first. And let's give this div a class name of flex, flex call, and gap4. That will create each of our individual rows. Now inside of here is where we want to map over each row. So we create a new item in the flex box for each day. But basically for each day, we want to render something out. The way we normally do that, if we have an array, for example, when we hover over data, we want to look at daily information. You can see daily right here is going to be an array of objects. So what we can do is we can say data.daily.map just like this. And then for each day, we're going to map something. For right now, we'll say each day is just mapping over a div. Just so we don't forget, let's throw a key on this div. And something that will be unique with each day is actually the timestamp, which is just this DT. We can say that the key is just day.dt, just like this. Now the question is, how do we want to style each row? Because this div right here is representing each row for each day that we have. Well, we want to space everything out evenly. So let's give it a class name of flex, justify between. That'll make it in a flex row layout and space everything out evenly. Now, what do we want to have inside each row? If we look back at our design, remember that we wanted 5 things. First, we want the day, then the icon, and then the 3 numbers, the average, the min, and the max. So let's make an element for each one of these 5 inside this div right here. For the first one, the day of the week, let's just make it a p tag for right now, and we're just going to say date. For the icon, let's make an image tag just like this, and let's give it a source. Now, how we can find the icon for each day is if we go to our weather schema here, and we look at our daily information, you can see that we have this weather array at the very bottom that has an object that has this icon on it. So this icon is what we can actually use to display an image. If we head back to the OpenWeather API and we Control F on this page just for icon, and we go down a little bit, you can see we have this weather.icon field, which matches exactly what we're looking at in our schema. Right here, it says how to get icons. If we just click on it, it takes us to this page. And it tells us to get icons, we just need to use basically this URL right here. Here's a quick look at all the different icons we can get. So obviously this would be something like sunny or clear sky, daytime versus night. We have cloudy, we have rainy, stormy, snowing, you get the idea. So let's actually take this exact link that it gives us and go ahead and copy it. And if we go back to our code here, let's go to the source, make this a string with backtick quotes, and go ahead and paste it in. However, if we just keep it hard-coded to be this 10d at 2x, it's going to be this image right here, this 10d.png, so this little rainy icon, and that's not ideal. Obviously, it shouldn't be hard-coded. We want this to be dynamic. So let's actually replace this entire 10d at 2x with $ quotes to inject our own expression into here, and let's pass in the actual icon that we're getting from the response. Like I just showed you a second ago, if we look at the daily information and we look at weather, we have this array and then an object inside the array that has icon. So it's pretty deeply nested in here. Now, one thing I will point out is that weather, like I said, is an array because technically over the course of the day, there can be multiple weather conditions. We're not going to worry about this for right now. Let's just assume we'll take whatever the first weather condition is. In other words, index 0 in the array of weather. So what that means is that day that we have right here represents this z.object. So to access the icon, we need to do day dot weather at the 0 index dot icon. So let's do that. So for the source here, we will say day dot weather. And it's nice that we have this type with Zod because now we have IntelliSense. We'll say weather, take the 0 index, and we'll do dot icon just like I said. And just to be safe, we'll give this an alt here that will just say weather icon. Go ahead and go back to our app and now save this. You can see we have date, 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 all this, and we actually have the weather icons already on this card. I want these icons to be just a little bit smaller, so I'm going to give it a class name for the image, and let's just say size 8. Go ahead and save it, and now they're a bit smaller, which makes our card not so huge. Now let's get the average temp, the min temp, and the max temp. If we look back at our schema here, and we look at this temp object, you can see we have day, min, and max. So we're going to use these 3 numbers right here. So let's actually make p tags for all 3 of these. So after the image here, let's make a p tag for right here. And the way we can access that is we can say day.temp.day for the average for the whole day. Day.temp.day, just like this. We'll go ahead and copy this, paste it twice. This will be day.temp.min, and this will be day.temp.max. Now if we go ahead and save it, for each day, we have the average for the day, the min, and the max in that exact order. I think it might look better if the min and max fields are slightly less visible and pop out less than the actual average for the day, because the average for the day is what's more important. So for the min and max, let's actually give these a class name. And for each of them, let's just say text gray 500/75 to make it slightly transparent. And we'll give this actually to both of them. Go ahead and save it. And that just grays them out a little bit. With this pretty simple component that we just made in this daily forecast, our daily weather information is now actually looking pretty nice and presentable. With the obvious problem right now being that we're just putting this date string here instead of the actual day of the week. So let's address that. So let's replace this date here with a JavaScript expression. And again, inside of here, if we hover day, the actual date will be given to us by this DT. Now DT is going to be in Unix time, which is why it's a number and not a date object. So what we can do to actually make this a date is inside this expression, we can say new date, just like this. And inside of here, we want to pass in day.dt times 1000. And that's because this date constructor that we're using in JavaScript expects dates to be in milliseconds, not seconds. But the DT that we get from OpenWeather is in seconds. Once we've done this, we can say to locale date string, just like this. If we go ahead and save this now, this will convert each one to a date string. So we can see right now, 1023, 1024, 1025, you get the picture. Each row has its own respective day now. However, I don't want this to be day of the month. I'd prefer for it to be the actual day of the week. So like Monday, Tuesday, Wednesday. So how can we get that? Well, all we have to do is change the arguments here that we have in this toLocalDateString function. We can pass in undefined for this first argument because we don't want to pass in any local time zone information. But for the second argument, we'll make it an object. And one of the first things we'll do is just give it weekday short, just like this. For date strings, this second argument that we're making this object right here has a couple of different customization options. One of them is weekday, which can either be long or short. Long means something like Monday, Tuesday, Wednesday, and short is just the abbreviation. So MON, TUE, and so forth. So if I save it now, instead of having the day of the month, we just have the day of the week, but abbreviated. The day I'm filming this on is Wednesday, so it makes sense the first day in the forecast would be Thursday because that's tomorrow. And again, we have 8 days, so it's Thursday going all the way to the next Thursday. Let's now clean this component up just a little bit more. First things first, I don't really want fractional temperatures, so I don't want 96.24. I'd rather just have it say 96. To do that, what we can do is for each of these temperatures, we can just wrap each of them in math.round, just like this. Go ahead and copy this for each one. Wrap them all. And now if we save it, we have integers for temperatures and no more decimals. I also want to put the units for each one. And I actually just learned that if you're on Windows, something cool that you can do is you can actually do Alt and then 0176 on your numpad to actually do the degree symbol. So that's pretty cool. And then I'm using Fahrenheit, so we'll do degrees Fahrenheit. We'll take this and we'll add this to the other temperatures as well. That way for each one, we are saying degrees Fahrenheit. Now, if we look at our rows, you can see that not everything is aligned perfectly. For example, the start of this 98 degrees Fahrenheit is not left aligned with this 91 degrees Fahrenheit. They're a little bit off. You can see that even more so with this 94 right here, it's jutting out to the right when compared to 91 and 96. This most likely stems from the fact that our weekday names on the left side are not all the same length. For example, Wednesday, or WED, is longer in width than Tuesday is. So we create this weird kind of offset look. One quick workaround to this is that all the entries in the left column here, like Thursday, Friday, Saturday, are all a fixed width. So to fix that, let's go to our p tag for our day of the week, throw a class name on it, and give it width 9. Now, if we save it, everything should now be aligned because we're ensuring that each of these has a fixed width, so the other ones are starting all at the same point. Nice, so everything is aligned great now. And that's actually going to be it for our daily weather card. Just to do a quick recap so we're all on the same page and understand what's going on. In this daily weather card, we're first just inheriting from the shared card component that we're going to use for all of our cards. Again, this is pretty basic, just has a title plus children and some stuff like roundedness and padding. But the daily forecast card specifically just has one div that is flex call, so we map out each one of our rows like this in a flex column layout. To get each day, all we have to do is data.daily.map. That actually gives us each day. And then for each day, we can just map out the information. Flex justify between is to make each row in an actual row layout, making sure that everything is spaced evenly apart. And then we just have elements for each of our items, like the day of the week, the icon, and then our 3 temperatures, the average, min, and the max. However, one thing I'm actually seeing real quick that can be a super fast optimization thing is getting rid of this div right here because it's a little bit redundant. I'm a pretty big hater of having divs that are unnecessary because I think it makes the code a bit harder to decipher and fix later on. When I say this div is redundant, I mean that if we look at our card component here, we already have this div right here that is wrapping the children. And then when we inherit it like this, we're wrapping another div around children as well. So it's like we're essentially double wrapping it, which doesn't really cause problems, but also it's not the best way of doing it. The easiest way to fix this and a way that I like to handle this is go into our card component here, and let's give it another prop here. It'll be an optional prop though. We are gonna call children class name, just like this, capitalize the N, and it'll be an optional string. We'll also destructure it out of here. And then on this div, let's give it a class name. And this class name is going to be, you guessed it, children class name. Now, if we go ahead and save this file, instead of having this redundant div, we can actually take the style exactly, which is just this flex call gap4. Let's paste it up here so we don't lose it. And we can actually wipe this div out completely. And instead, we can give it another prop, the children class name, where we just paste this in. Now, if we save it, it'll behave the exact same. We did just add a prop to the card component, but we completely removed a redundant div, which in my opinion makes it easier to read in the future. Now that we have the daily forecast done, let's move on to the hourly forecast. Like the daily forecast, let's go over to our file explorer, and inside cars, we'll make a new file, call it hourlyforecast.tsx. We'll do tsrfc to create the component, and just like daily, we'll make this be a card that inherits from our shared card component. If we go back to the drawing board, here's what I was thinking for our hourly card. We'll have a card that is quite a bit longer than it is tall, just because for hourly, we're gonna have 48 hours, so there's gonna be a lot of stuff, so it's gonna have to be able to scroll side to side. I was thinking for each hour, we could have something like the actual hour number, so like, I don't know, might not do military time, but let's say we do a military time. We'll have the number. We'll have the icon for what it's going to be during the hour. So whether that's, sunny, cloudy, whatever. And at the bottom, we'll just put the actual temperature we expect it to be. So for example, 74 degrees Fahrenheit. And this will be for every single hour. So basically it's the opposite of what we're doing for daily weather. Instead of having a bunch of rows that kind of go in a vertical format, we're going to have a bunch of different columns that go in a horizontal format. So we'll have hour 1 right here, hour 2 right here, 3, 4, and you get the picture, and it's going to scroll side to side. That should be honestly super easy to do, so let's go ahead and get started. We will do the exact same thing we did for daily forecast by taking the same query from app. So let's take this exact same suspense query from daily forecast, and let's copy and paste it in here, making sure to import the suspense query and importing our API function. Again, I want to emphasize that because all of these components are mounting at the same time and share the same query key, we're not actually going to make multiple network requests. It's only going to make one, even though we have multiple use queries. I mentioned just a second ago that we want this hourly card to be in a horizontal format, meaning we want it to be in a flex row layout. So to do that, we can kind of copy this similar thing we did for our daily forecast with the children class name, but instead of doing flex call, we'll just do flex row. If we go back here, let's give it a children class name, and we will just say flex, and let's do gap 6. I could add flex row here, but flex row is the default, so technically it's the same as just not having it at all. inside this card now, just like we mapped over the daily data using this data.daily.map, let's do the exact same for the hourly. Again, if we look at data, you can see it's an object, and we have this hourly, that's an array, kind of in the same vein as daily. So what we can do is we can say in our card here, we're going to do data.hourly.map, and then for each hour, we're going to map out a div here. Card is going to complain because we're missing the title prop. So let's actually go to app, take the title that we already had for the hourly forecast, take this, and we will just put it back into here. So now we can make card happy again. Now let's ask ourselves, for each hour that we're mapping over, what do we want to display? Well, in the little rough draft design that I just drew out, each hour just had the time, the icon, and then the actual temperature all stacked on top of each other, so in a vertical layout. To get this vertical layout, we can give this div a class name. Let's give it flex call, and we'll give it a gap of 2. The gap isn't going to be huge, just enough to create separation. But this should at least set up a reasonable column layout for each individual hour. Just like the daily forecast, we'll first display the date, except instead of being an actual date like Monday, Tuesday, Wednesday, it will be the time of day. It only makes sense if we're doing hourly forecast to have this be the actual hour in question. So we'll make this a p tag right here. And similar to daily, we will make this new date, calling the date constructor. And just like day, the hour also has a dt. So we can say hour.dt times 1000 to get the actual date. And then to get the time, all that we have to do is call toLocal time string, just like this. Before we go any farther, just so you can see how this looks, let's actually save this file real quick. And in our app, instead of rendering out this card, just like we're rendering out daily forecast, we're also going to render out hourly forecast. And now if we look at it, we can see right here on this hourly forecast card, we have a bunch of times. We have 8 p.m., 9 p.m., 10 p.m., and you get the idea. Back to our hourly forecast component. Right underneath this timer here, we want to have an icon for the weather, just like we have for daily. So if we go to daily, you can see we have this image right here. And I think because we're going to reuse this, it might be a good idea to actually make this its own component. So to do that, it'll be super easy. Let's just take this image tag. I'm going to copy it exactly. Go into our file explorer, and in the components folder, let's make a new file just called weathericon.tsx. tsrfc again to make this component. And then in here, let's just return what I just copied, the image element. And now what we can actually do is instead of hard coding this day.weather.icon that we're doing, we can just pass in source, which we will just make a prop to this component. So we'll say source, and source is going to be a string. So essentially now we have a shareable component that we can use between both our hourly forecast and our daily forecast. We can implement it in both. If we go to daily forecast, let's get that real quick. We'll just take this source right here, which is the day.weather0 icon. Let's copy this. Let's actually get rid of this whole thing and just render out weather icon in its place, giving it a source of this right here. Now, if we save it, it should behave in the exact same way, with just being a reusable component. So now that we have it in the daily forecast, let's copy it and let's paste it verbatim inside of the hourly forecast right here, right underneath our date. Go ahead and import it. And the only major difference is that instead of being data.weather.icon, it'll actually be hour because the format is going to be similar. We have this hour object. Inside of that, we have this weather array. We're going to take the first index of it and then grab icon. So now if we save it, boom, now each of our hours in our forecast has its own icon. And that, my friends, is how you speed run shared components in React. Anyways, let's get back to the hourly forecast. The last thing we're missing in here is our actual temperature, which should just go right underneath the weather icon. So let's make another p tag right here. And for the temperature, all we have to do for each hour, we can access it with this temp right here. So it's super simple. All we have to do is say hour.temp. However, just like the daily information, I want to have a unit on it. So I'll take this degrees Fahrenheit right here, add it to the end. And I also want this to be rounded. So I'll do math.round just to make sure it's an integer and not a decimal. Now, if I go ahead and save it, we also have the temperature for each item. The next obvious problem you might notice is that now our page has a huge scroll bar because, shocker, our content is just way overflowing all this. We don't actually have a proper scrolling container set up, so all the hours are literally just overflowing the side. Clearly, this is not something that we want. A super easy fix for that is on this children class name here. All we have to add is overflow x scroll, just like this. Now, if we save it, this is going to scroll within the container. So now the actual container itself is scrolling. The page itself will still actually scroll because this top card is still messing us up. However, this component itself, the hourly forecast, is no longer causing the entire window to scroll. It's going to be a super long list because, like I said, there's 48 hours of forecast, which means there's 48 of these objects. So yeah, we got a lot of horizontal space here. Let's quickly improve some of the styling to make it look a little bit sharper. First of all, I don't love that the time right here is overflowing or wrapping down. I wouldn't want the 8 o'clock to be on a different line than the PM. Doesn't really look very good. So what we can do is go to the P tag where we're doing our time. Let's put a class name on here. And all we have to do is give it a white space, no wrap, just like this. And now it's not going to wrap anymore. For each hour, I want all the items to be centered, not left aligned. As you can see here, obviously this weather icon is not centered directly under the time. So that's something we can super quickly fix if we just go onto this outer div right here, flex call, and we give it item center. That'll make sure everything is centered within the column. And each of the hours feels a little bit cramped right now, so I'm actually going to add P2 to create a little bit more spacing for each hour. And this is already looking quite a bit better. The very last thing is I honestly don't like this time format right here. I think having the 80000 just seems super redundant. These are just extra zeros right here. We don't need them. So to format our time, we could do something pretty similar to how we handled the dates on daily forecast. Inside of our toLocalTime string, we'll again make the first argument undefined so that this stays relative to your local time zone. And for the second argument, we'll again pass in an object. And for this one, all we have to do for the options is give it our numeric, just like this. We'll also give it minute 2-digit, and then we'll give our 12 true. If we save our file now we can see our times are just formatted like this without the 2 extra zeros. And that, ladies and gentlemen, is our hourly forecast card done. There's a chance we could come back to it later to make some improvements or changes, but with what we have right now, this is working great. We can see the forecast for all the next hours. So we have 8 p.m., 9 p.m., 10 p.m., and I can scroll if I'm curious about any hour in the next 48 hours. Super crisp, super smooth. Now on our page, or other words in the app component, we're displaying both the hourly forecast and the daily forecast in the exact way that we want it to. Theoretically, given any latitude and longitude coordinates, I can now see the hourly forecast for that exact area and what the next 8 days are going to look like. So we've already made tons and tons of progress from where we started. But let's keep going. The last big chunk for this dashboard is getting the current weather information. We already have hourly and data. So let's get the current weather component set up. Just like the other two, same process we're getting familiar with. If we go to our cards, we'll make a new file. Let's call this one currentweather.tsx, tsrfc to generate the component. And same pattern as before, we're going to take the exact same suspense query and add it to current weather. I know I keep saying this and reiterating it, don't mean to beat a dead horse, but as long as they have the same query key, it's not going to be making multiple network requests. They're going to share the exact same query. Let's go ahead and just save this component now, and let's render out current weather. And here, we finally have individual card components for all three. And just to make sure actually we have the same title, let's not forget this real quick. Let's do title. And for here, make sure before we forget to render out the card, the same shared card you've been using this whole time. And we will pass in this title. Oops. Pass in this title right here, just like this. Now if we go ahead and save it, go back here, and we can just make this current weather, and now it's happy, and we have it on our page. The main question is now, what do we want this current weather card to actually look like? Let's once again go back to the drawing board. For this current weather card, here's kind of what I was thinking. This card, unlike the hourly forecast, but similar to the daily forecast, is probably going to be a bit taller than it is wide. What we could do for this card is right at the top center of the card, have the temperature in big, bold letters. So for example, something like this, right in the middle, just so it's very obvious and sticks out to the user. Immediately under that, we could put the current weather condition, so something like, I don't know, this can say cloudy, and then we'll have the icon that corresponds to that exact condition, either to the side of it or directly under it. So for cloudy, it'll be some cloud like this and an icon. And then right under this, to fill up more space, we'll probably put what the time it is at the actual location that we're looking at. Again, with their app, we're going to be able to see the weather for anywhere in the entire world. So it's probably nice to know what the actual local time is there. So let's say, I don't know, it's 14:52 o'clock. That can be a time under it. And it won't be quite as big as the temperature. This should be a little bit smaller. So this is not quite to scale. And then at the bottom, maybe we just have a few stats kind of in a row. So we could say like right here, maybe what the temperature feels like. We could say, maybe humidity is in this box. And then we could say, I don't know, something like wind speed or wind degrees or something like that. And this could be just a very rough outline. So we'll have all this in a flex call starting from the top because it's all kind of in a vertical layout. Since we want all this to be in that vertical layout, let's go into our code here. Make sure we have our card. It's annoying sometimes how Prettier formats these. And we'll give it a children class name of flex call, again, just to make it all vertical. I also want to make sure that all this stuff is centered. So I'm going to give it item center, just like this. Now that we have this, let's get the rest out of the way. For the first section, like I just mentioned, we'll have the temperature in big bold letters. So let's replace this current weather right here with an H2, not H1 because I'm going to reserve that for bigger headers later down the road. And here we need the current temperature. So how do we get that? Well, if we look at data, we can see in the current object here, we have this temp number. That is the current temperature. So to get it, all we have to do is say data.current.temp, just like that. Same as all the other ones, I also want to use degrees Fahrenheit. So we'll take this exact same unit, and just to keep things consistent, we'll also do math.round, just like this. So now if we save it, we'll have the current temperature of wherever we are. Right now it says 74 degrees. So wherever in the world is 10 latitude, 25 longitude, it's apparently 74 degrees Fahrenheit. This temperature right now looks way too tiny and out of place. So on this H2, let's give it a class name. Let's give it some pretty fat text. We'll say text 6XL because we want it to be quite big. And I'll also give it font semi-bold just to make it pop out a little more. And text center just to make sure it's centered. So now that looks quite a bit better, way easier to see. Next up, let's get the weather description and the weather icon. I'm going to want the big bold temperature and the weather icon and description all in the same div just for organization purposes. So let's actually wrap this H2 here, wrap it in a div. And for this div, just to create some separation between them, let's make sure this is all vertical. So we'll say flex call, and we'll also give it gap 2 for just a little bit of separation. So if we go ahead and save it, it now has its own div that we can also put the icon and the description inside of. We already made a share component for the weather icon, which again is called weather icon. So let's take this, copy it, and just paste it right here, making sure to import it. And then for the actual icon, if we go into data, look at the current information, it's pretty much the exact same thing as the other two. We have this weather weather array of objects. We'll just take the first index, the icon. So instead of doing day.weather, all we have to do is data.current.weather, just like this, and now we're good to go. If I go ahead and save it, boom, now we have a weather icon. I want this weather icon to be centered, so I'm going to actually add item center on this div right here, and that'll make sure it's centered directly below the temperature. However, right now this icon honestly looks really tiny compared to the actual temperature with how big the text is. So let's make it a bit bigger. One problem we're going to run into with that though is if we try to modify the size of the weather icon directly, we're going to modify it every single place that it's used. And I don't want to change the size of how it is in the hourly and daily forecast. So what I can easily do to make this more customizable is add a class name prop that can be optional. That will just be a string. And we'll also pull class name out of the props here, meaning destructure them, that we can use to pass in our own custom styles. The way I typically handle custom class names like this is with a tiny package called CLSX, which is a super tiny utility function that just resolves conditional class names like this, instead of having to do some ugly string interpolation. Because let's be honest, string interpolation looks super scuffed. To get CLSX, all you have to do is go into your terminal, make sure you have a new one open, and just run npm I CLSX just like this, and it'll get it added to your project. Again, it's a super tiny utility. It's not a big package we're installing. Once you've done that, literally all you have to do is just make your class name an expression like this, and you're going to wrap it in CLSX as if you're calling it like a function. You just want to make sure you import it from CLSX. Now what we can do, in addition to having size 8, which will be our default style, is any custom class name we pass in, we can just put on top of it. And this CLSX function will actually resolve this. So if we pass in a class name, it'll just get appended to the same class name. And if we try to override the size, it will override it. Meaning it's size 8 by default, but if I want to pass in something bigger or smaller, I can. So now if I go ahead and save this file, and I go back to current weather, I can give this weather icon our own custom class name. And instead of defaulting to size 8, let's actually say, I don't know, size 14. Go ahead and save it. And now our icon is quite a bit bigger without impacting the size of the icon on hourly forecast and daily forecast. So that's a quick sneak peek into how I handle conditional styles, or when I need to do my own custom class names, where it's maybe the same in a lot of spots, but has slight variations in other spots. Now if we go back to our current weather component, right underneath the icon, I want to put the actual weather condition that we're in, like cloudy, sunny, rainy, you get the picture. To do that, all we need to do is add, we'll do an H3 for this one because it should be slightly smaller than the temperature. And to get the description for the current weather, it's actually pretty similar to how we get the icon. We hover over data, look at current, and go to weather. You can see we have this description right here. What we can do, we can actually, let's just take this exact thing right here, and we'll say data.current.weather at index 0.description, just like this. Now if we save it, we have the weather description. This one in particular says scattered clouds. Let's make this look a little bit nicer by adding a class name here. Let's add capitalized, so it capitalizes the first letter of each word. Then we'll also make it text XL. So it's still relatively big, but not nearly as big as the actual temperature. Save it, and I think that looks quite a bit better. Underneath the temperature, the icon, and the actual weather description, let's get the time figured out. When I say I want to put a time on this card, I think it would be good to put the actual local time of wherever we are, because to me that would make sense in the context of the current weather information. So if I want to look at somewhere in Germany, the time it gives me for this card would be German time zone, not an American time zone like my own. I like to have it so that we have in big letters saying local time, and then right underneath it have the actual time itself. So to do that, we can actually go under this main div we have right now, and let's actually make another div just like this, and we will give it a class name of flex call, and gap2 to create this sort of layout. We'll make the first thing in here a p tag, and this is just going to say local time. Right underneath it, let's make another header. So it's going to be similar size to our description. So we'll say h3, and this is going to have the local time. There's a couple of different ways that we could do this. However, the way I'm going to do it using the time zone that is actually returned from data. So if we hover over data, you can see we have this time zone string right here. This is actually very useful if we want to get the local time. A way we can do that is by inside of here, making a JavaScript expression, and we can say new int L, just like this, dot date time format. For the first argument, we're going to pass in a string that is en-us, since this is my preferred format. And then for the second argument here, just like all the other dates that we've worked with, we'll make an object that we can customize. In here, we'll say hour is going to be 2-digit. We'll also say that minute is the same thing. We also want it to be 2-digit. And just like hourly, we'll make hour 12 true. And then to get the actual local time zone of wherever we are and not my time zone, what we can do is give it a final option that is just time zone, just like this. And that will just be data.timezone. Because again, we hover data, we have the time zone right here. So we pass that in as another option to our date. And this will actually create our date for us, completely using the local time of whatever the time zone is that comes back from our call. You'll notice this whole thing right now is going to be highlighted red because the date itself can't be a React node. We need it to be a string. So to actually format it as a string, what we can do is after this big chunk right here, we can just say .format, and inside here, you can say new date, and you want to pass in the actual time of the date. So we'll say for the time, it is stored in data.current.dt. That is the current time. So we'll do that. Data.current.dt times 1000, like always. And now if we go ahead and save it, you can see the local time of the coordinates 1025 or whatever we have in our query right here is 4:26 a.m. It looks a little bad right now like this, like a bunch of just kind of jumbled text. So let's style it up. We go down here for our local time for this p tag. Let's go ahead and give it a class name. We'll say text XL. And then for the actual time itself in this H3, we'll also give it a class name. And we will say text 4XL and also give it font semi-bold just so it sticks out quite a bit. Now if we go ahead and save it, the text is quite a bit more readable. However, now this time just got way bigger. This local time is off center. It looks kind of weird. So all we have to do is just add text center to this, just like this. And now it's back to looking good. The only last thing now to do on this current weather card would be to add the 3 quick sections at the very bottom, getting the feels like temperature, the humidity, and the wind speed. These will all share the same style, so this will be super simple. We'll go down here below this div and make yet another div. we will give it a class name of flex justify between so that each of these three little sections spaces evenly from each other. And then for each little section, we'll have another div. For each of these, we'll give it a class name of flex call gap2. All we're going to do for each one of these divs is just give it a p tag that will say, for example, for the feels like temperature, we'll just say feels like. And then for what it actually feels like, meaning the temperature, all we have to do is data.current. Oops, crap as an expression here. Data.current. You can see we have feels like right here, so we can just use that. We'll want to keep the same consistency with the units, so we'll do degrees Fahrenheit. And we will also math.round this whole thing. Now, if we do this for our first thing, we'll see feels like 72 degrees. Clearly, it doesn't look very good yet, especially because there's only one element. So let's make some styling to fix this. In this flex call div right here, let's make sure we also throw item center to make sure they are vertically aligned with each other. Still does not look very good because there's only still one item there. So let's actually take this div chunk here. I'm going to copy it and we're going to paste it twice, because each section is going to look very similar to each other. The second one, instead of saying feels like, is going to just be humidity. And instead of doing the data.current.feelsLike, what we can do instead is just replace this with data.current.humidity. This is not going to be degrees Fahrenheit. This is going to be a percentage. So we'll use the percent symbol. And then for this one, this also is not going to be feels like. This is going to be the wind speed, which we will just call wind. And then we can replace this whole thing with just data.current.wind speed, just like this. Wind speed in imperial units is going to be miles per hour, so we will just say mph. Now if we go ahead and save it, we have three different things: the feels like temperature, the humidity, and the wind speed. Obviously still looks pretty horrible, but at least we have all of our data here. To fix this weird styling, let's make sure that this flex justify between div right here is width full to make sure it takes up the entire space of the card. We save this now, it spaces it out, so it takes up the whole card. Next, I want these numbers in the bottom section, like the feels like number, the humidity percentage, and whatnot, to stand out against their labels. So on each label, to make it slightly darker and less in your face, I'm going to throw a class name on it, and I'm just going to give it text gray 500, just like this. And we'll actually copy and paste this class name on the other labels as well. Go ahead and save it, and now they don't stand out against the numbers so much. Makes the numbers pop a little bit more. And lastly, it's pretty clear that each of these items, so like this whole item at the bottom, next to this time, next to the stuff right here, is not separated out with any space at all. So all is kind of just cluttered. So if we go back up here to our card, where we have the children class name, let's actually throw a gap on here. Let's just give it, I don't know, gap 4 for right now, just to make everything a bit more spaced out and a little bit nicer. Actually, maybe let's do gap 6. Honestly, now our card is looking pretty good. It doesn't look perfect yet, so we may also revisit this in a bit with the rest of our cards. It looks a little bit awkward right now because these cards are so wide, but for the actual finished dashboard, these cards aren't going to be taking up the whole width of the page, so it's not going to look so stretched out. It'll look quite a bit better. So for now, let's move on. The only last card that I want to make for this dashboard that's going to be consuming information from the API is just a card that displays some of the extra information that we're getting back that we're not currently using. If we go to the weather schema and we look at it, we obviously have the daily and the current and the hourly. However, there's a lot of things here that we're not actually going to be using. So for example, we have like the sunrise and sunset time. We have, I don't know, the clouds. We have the wind degrees. Basically just a bunch of fields that aren't being used at all. We've got plenty of real estate to work with on this dashboard. So let's actually use these other pieces of information on a final card that we'll just call additional info. So going back to our cards folder, we'll make a final component in here that we're just going to call additional info.tsx, tsrfc to make the component, and we'll go ahead and save this file, close this, and just like the other ones, we'll make it inherit from the same card. And for this title, we're going to give it a title of additional weather info, just like this. This card is just going to have some additional weather information, so it's not going to be anything crazy. We're not going to go really weird with the styles. We'll keep it pretty basic. So let's actually wrap this back in parentheses here, fix this annoying formatting that Prettier always does. And then in here, what do we want to do? Well, in terms of design, I was thinking about just making it something super simple. We'll just have all of our additional fields laid out into columns. So we'll have the card like this, and we'll have some columns that are just going vertical like this. For each individual column, what we can do is we can just have the label. So I don't know, like, wind speed here on the left, wind speed, and then on the right would be the actual number. So this is not anything crazy, just super simple. For like cloudiness, we could do cloudiness, whatever, and then have some number here. And we would do that for each of the different pieces of information that we have. Super, super basic layout. So to create this vertical layout here, let's give our card some children class name. And we're just going to say flex call. Let's make the gap a little bit bigger this time. We'll say gap 8. Now the question is, how do we actually want to render out the information inside of our component right here? I could write each field individually since they're all going to be a bit different, but then I'd have to spam a bunch of the same JSX and this component would look a little bit messy. I prefer being able to map over something, that way we only have to write the core JSX in one spot. What I mean by that is at the bottom of this file, I'll make a new variable. I'm just going to say const rows, and it'll be an array. And in here, for each of these rows, I think we should make an object with 2 properties. We'll have label, and then we will also have value. Label will be what the user actually sees, and value will be what it's actually called from the API. So for example, let me show you what I'm talking about. If we take the same exact suspense query, let's go ahead and get it into this card as well, making sure to import our stuff. And if we now hover data, we can see that current has something, for example, like clouds. In this case, the label will say something like cloudiness, and value would be clouds, so it maps it as property. So what I can say for this is for label, I will say cloudiness, and we'll do percentage just so we know the unit. And then the actual value itself is just going to be clouds. We just want to make sure this value matches exactly how it's going to look like in the response. And we basically just want to do this for all of our fields. So let's pick out a few important fields that we want aside from cloudiness. If we look at data here, we can see that in addition to clouds, we have UVI. So I think we can include UVI. Let's take the wind degrees because that'll be the wind direction. We'll also take, let's take pressure up here. And then we'll also get sunrise and sunset. So that would make 6 total properties that we're getting, which I think should be plenty. I'm lazy and don't feel like writing these out individually, so I'll ask ChatGPT to do it for me. And here is what it cooked up. So for each of these, we'd have the same thing, where we just have the label, which is what the user sees, and then what it actually is on the endpoint. So this should be good. I pretty much just gave it the response structure and asked it to just take those 6 fields into account. And now we have a label and value for each thing. Now that we have this rows array, what we can do is we can go back to our car component here. We can make an expression and we can say rows.map. And then for each row, we want to, for each row, like everything else, just map out a div here. For each row, what do we want it to look like? Well, I mentioned we wanted to have it be flex, justify between. So let's go ahead and do that. And all it's going to be is something super basic. We'll have 2 spans inside of here. Span 1 is just going to be the actual label that the user sees. So row.label. And then the second span that we have is going to be the actual value from the endpoint. If we make sure that our values match up 1-to-1 with how we have them declared in our schema, and we look at it, I can just access data.current.clouds, for example, to get that particular number. So the way that we can do this in our map, we can say data.current@value. And it's really that simple. Actually, it's not that simple. It needs to be row.value, not just value. However, we're going to get a TypeScript error here saying that it has any type, and it's going to complain with the prolong thing that is basically just caused by the fact that this array is not declared as const. So if we just say as const, it'll actually just get rid of that error completely. We're just telling TypeScript that this array is never going to have anything pushed or popped from it. It'll always be this, so it can safely assume the type is never going to be anything different. And just to clean things up a little bit, I like to destructure things wherever I can. So instead of doing row just like this, let's actually destructure both label and value out of here. And instead of doing row.label and row.value, we can just use them directly after destructuring. And then before we forget, like all mapping, we need to make sure we throw a key on this. So let's throw a key, and we'll say our key is just equal to, I don't know, the value, because that's always going to be unique. So let's go ahead and save it. And now let's actually render out this card on our dashboard so we can actually see what we're working with. So let's go back to our app here. And right under daily forecast, let's render out additional info just like this. Now if we save it, scroll down, we have this additional weather info card, which is the component that we just made. So this is nothing crazy. It's actually a pretty basic component. Let's style it up just a little bit. For the label, let's give the label a class name, and I'm just going to give it a class name of textgray500 just to make it a little bit less obvious than the value itself. We'll also want to convert this sunrise and sunset numbers you see down here into actual dates. Having them as Unix time doesn't really do anything for us. So basically, we need to format these as actual dates and the other ones as numbers. So that's going to be a little bit of an issue with the way that we currently have it. What I like to do when it comes to something like this is I make a separate component that just formats the values instead of doing a nasty ternary or conditional inside of this expression. Right below this component, I'll actually just make a super simple new one. We'll say function format component, just like this. This is just going to be another React component. To format each thing properly, we'll need to know the value and the actual number that we have for that value. So we'll make two props. We'll say value and number. And to make TypeScript happy, we'll say value is going to be a string. And then number is obviously just going to be a number. For most of these fields, we just want the raw number. So by default, we can just say return number like this. However, above this return, specifically if it's a date, we want to do something different. So what we can do is we can say if the value is equal to sunrise or the value is equal to sunset, then we want to return a formatted date. So we'll say return new date. And we will do number times 1000. Again, just converting the actual date time to a real date object. And then just like before, we will call to local time string. We go ahead and save it, just get a little bit of formatting here, makes it a bit nicer to read. We'll do the same thing as before, undefined for the initial options, pass in the customization for the second argument here. Oops. Sometimes this formatting gets a little bit funky. I want to map exactly what we have for our hourly forecast, so it's the exact same. So if we go in here, see what the options are for this. Let's actually just take everything we have inside of here, copy it, and we will actually just put it exactly verbatim inside of here. Now if we go ahead and save this component should be good to go. If I was using this customization options right here in a bunch of different spots, I'd probably extract it out into its own utility. But because we're only using it in two spots, I don't really think it's that big of a deal to just copy and paste it. Again, essentially all this component is doing is normally we're just going to return the number to format that number directly. However, if it's a date, meaning if it's sunrise or sunset, then we're going to actually format it as a date. So now what we can do is we can go up here and inside of this span right here, we can actually just completely replace this by rendering out format component just like this. For our props, we obviously need value and number. For value, it's going to be just a direct one-to-one. It's going to be the actual value. And then number is going to be what we had before, which was data.current at value, just like this. That's the actual corresponding number from the endpoint. Now, if we save it, boom, we have the rest of them formatted as numbers, but the sunrise and sunset are now formatted as dates, just the way that we wanted it. Before we call this card good, there's one more thing that I want to add to it. All of our other cards have some sort of icons in some capacity, like the weather icons. It makes them look a lot less bland and a bit more, I don't know, sophisticated or styled. But this card right here is just displaying text, so it looks a little bit boring, at least when compared to the other cards. What we can do is we can actually add some quick SVGs to make these look a little bit cooler. If I head over to svgrepo.com, I can see all sorts of SVGs that I can just get completely for free. For example, for cloudiness, I can search, cloud in here, and I can take any one of these icons and use them as a cloud SVG in my app. So real quick, off screen to not waste your time, I'm going to find an SVG for each one of our 6 categories and get them added to our repo. All right, so I found an icon for each one of our things. We have this cloud for cloudiness, pressure for pressure, sunrise and sunset. We have UV, and then we have wind. These will be super easy to add to our project. So basically all that I'm wanting to do is in this additional info card, for each little field that we have, I'm wanting to have an icon next to the label. So for cloudiness, we'll have a little cloud. For UV index, we'll have a little UV symbol, and you get the idea. Just a little icon for each one to make it look a little cooler. How do we render out SVGs as React components? There's a couple of different ways we can do it, but by far the simplest way, and the way that I like the most with Vite, is using a super tiny package called svgr. If you look up svgr, you can find this page called Vite plugin svgr. Let's get this added to our project real quick by taking this command right here. Go ahead and copy it, open up our terminal, paste it in, run it, and now we have svgr and we're ready to use it in a super simple way. all we have to do is do exactly what it says right here. Basically, just add it to our plugins, like how we have React and Tailwind. If we go to our vconfig here, we already have React and Tailwind. Let's now just add svgr like this. This will be imported from the plugin. Looks like TypeScript isn't recognizing it for the import, but it should be imported just like this. What this tiny little package allows us to do now is actually import SVGs as React components, like it says over here right in the docs. You basically just import it and you add $React, and it'll actually import it as a React component that is already ready to use. So what I mean by that is if we close out of these, go back to additional info, I can now import these SVGs as components by doing something like for sunrise, for example, I can say import sunrise from, I'll say file path is /source/assets sunrise.svg, just like this, and then add $React, and this will make the sunrise actually a React component. And I can actually do this for all 6 of our icons. So I'll take this here, make it 6 times. We'll make this sunset. We'll make this cloud, UV, do lowercase v there. And then what were the other 2 that we had? We had, wind. And then we also have pressure, just like this. And then we'll change each of these. This one's going to be pressure SVG. This is wind SVG. UV, cloud, and then sunrise and sunset. Now we can use each of these. Let's plug each of these icons into our rows array. What we can do is, like how we have label and value for each one, is also add an icon field. And this will just be a component. So the icon for clouds is just going to be the cloud component. And then we'll take this, actually copy and paste it for each one, just as such. And then this will be UV. This will be wind, pressure, and then we have sunrise and sunset. So these right here are actually all React components. By default, TypeScript is actually not going to recognize these as React components because the way it's importing it is a little bit unconventional. So it actually gives us this super nice thing we can use right here, this line. If we just copy it, it says to add it to our venv.d.ts. So let's take this. Let's go to that exact file, which we don't actually have. So let's create it. We'll just make a new file in here. We'll say v-env.d.ts, just like this. And let's paste this line in here. And now we go back to additional info and we save it. It should resolve all of these correctly. Oh, and also this venv.ts file should, I don't think be at this level. I think it should actually be inside of source, which may be the issue. Remove that. Yeah, okay, if we remove that, it looks like it resolves those imports. So no more annoying TypeScript errors. Looks like, oops, we forgot the slash on this. So now it should import all of these icons correctly. Now that we have them in here, let's actually get them displaying on our card. We already have each of the icons in the rows now. So what we can do is we're mapping over our rows here. We can also destructure the icon out of here. And actually we'll make sure it's capital I because it is a React component. So we'll make sure icon here, select all of them. Capital I for component, just so we have proper conventions here. And then we want to render out this as a component. So let's take our label span here. Let's wrap it in another div. So we'll wrap div here, create some more spacing, and we'll just give it a simple class name of flex gap4. And then right after our label, let's just render out icon as a component just like this. What's really cool about svgr is that you can actually pass in custom class names to give your icon certain sizes. So we can say, let's give this one size, I don't know, let's do size 8 for now and see how that looks. We go ahead and save it. Now we scroll down and look at our card. We have SVG icons for each label. I definitely think that having these SVGs adds some more personality to this card. Only thing we need to fix real quick is that all of these are black against a dark background, so it looks kind of bad. So let's actually throw the invert class on this too, and that will make sure they appear white instead of black. And the very last thing I want to do for this card is really quickly just adjust this wind direction. This number right here doesn't really make a whole lot of sense. The other numbers kind of do because we have the units next to them, but having just a raw number for the wind direction doesn't really mean anything. Now, technically it's in degrees, but I think one cool way to show this would just be to show an arrow pointing which direction the wind is going. I found another SVG on SVG repo called up arrow that just looks like this that we can use to point the proper direction. The way we can super easily do that is just how we have the formatting for sunrise and sunset, we can do a similar thing for the wind degree. So instead of having this return as a raw number, you can say if the value is equal to wind degree, just like this, then what do we want to return? Well, all we want to return is just the up arrow SVG. So we can actually import that like our other components. We can say, take this line, we can call this the up arrow component, and it'll be from up arrow to SVG, just like this. And now for right here, all we want to do is if we're on wind degree, we want to return up arrow. And to get it pointing the proper direction, we just want to rotate it by whatever the wind direction is. An easy way that we can do that is to actually just give this up arrow a style tag, which again is a nice thing about svgr. We can give custom class names, styles, everything like that. And inside of here, what we're going to do is just say transform, and you want to transform and a rotate. So we'll say this, we'll do the back to quotes here. We'll say rotate, and the amount of degrees we want to rotate it is going to be just whatever the number is. So we'll say $, curly brackets to inject something in here, say number, and you want it to be exactly that many degrees. Because the arrow is an up arrow, that means its starting point is at 0 degrees. So if our wind direction is, for example, 180, that'll make it go to a down arrow. I hope you see what I'm getting at here. If I go ahead and save this now, you can see it's actually just this massive icon. So we need to fix the sizing on it real quick. So let's go to the class name. Actually, we'll make a class name for it because there's not already one on here. Let's just give it a class name of size 8, just to be consistent with the other icons. And we'll also invert it to make it white. Now, if we save it, you can see we have a cool little arrow right here that points in the direction of the wind. So our arrow is pointing not quite perfectly downwards, but a little bit to the left of that. So it's probably around the 180 or 190 degree mark. If we quickly just go into our network tab, we can verify this. We just refresh the page, look at this call. Let's go to the current weather information, and we can see the wind degree is 184. So yeah, 184. So that's why it looks like it's almost straight down, but not quite. It's a little bit past. So it's actually really cool. Now we have the arrow that points in the direction of the wind. Having this arrow point to 184 degrees is way cooler than just putting 184. With that done, let's take a step back for a second. We've just successfully gotten API information from OpenWeather fetched through TanStack in 4 separate card components that each have their own unique styling and each subscribe to the exact same query that grabs this data. We've still got quite a ways to go before this app is finished, but we've made great progress so far, and arguably we've just knocked the 4 most important portions of our app out of the way, that being these 4 cards. So what's next? Now that we have our cards out of the way, I think it would be a great time to get the interactive map added to our app. All we really have on our page right now is just these 4 cards, which is cool, but by themselves they don't really do anything, and we don't actually have a way to change the latitude and longitude coordinates that we're getting our data from. Like this 10 and 25 here is just hard-coded, so it doesn't really mean anything if we can't change this and have it be dynamic. So what I'll go ahead and do is go into our components folder here, and let's make a new component, and we will just call it map.tsx here, and then as usual, tsrfc to create the component. And for this map, we've got quite a few different options for actually creating it. The library that I think is probably the easiest, at least for our use case, to implement is Leaflet. It's one of the most, if not the most widely used library in JavaScript for creating maps. And there is actually a nice package called React Leaflet that essentially wraps this entire Leaflet library and gives us super easy to use React components. So we'll use this for our app. If we're on the React Leaflet site and we go over to this menu, you can go to getting started, and there should be a step for installation, and it tells us how to get it added to our app. If we scroll down here, it should give us an npm command right here. So we'll go ahead and install this. The first command it tells us to run is this command right here. And we actually already have React and React DOM, so we don't need to run those again. What we will do is open up our terminal, a new one here, and we will just say npm install Leaflet, so we can get Leaflet added to our project because Leaflet is a dependency of React Leaflet since it uses it under the hood. And then next it says to install React Leaflet add next. So we'll go ahead and install this, copy that, paste into our terminal. And now we should have both Leaflet and React Leaflet. The last thing I'll do just for convenience is to install the types. So TypeScript can be happy with some of this. So we'll take the Leaflet types and get that. And once we've run those 3 commands, we should be good to go. And then at the very bottom of this page, there should be this next setup button here. So we'll go to this page, and it actually gives us an example of what a basic map looks like. For the sake of just showing you what it looks like and how it works, I'm going to take this entire example actually. I'm going to copy it, and I'm going to paste it into our map component so we just have it in here. Then I'll make sure to import these components from React Leaflet, get map container, tile layer, let's get a marker, and then pop-up. We will go ahead and save this file. I also think for right now, we actually don't need this pop-up on second thought, so I'm actually going to get rid of this pop-up, and I'm just going to make marker a self-closing tag here. So I'll just make it a standalone marker with no children. Right now, going back to our app real quick, the coordinates that we've been fetching for different components are just latitude 10 and longitude 25. So if we go to our map here, that's actually what these are right here, the center, this array right here that we use for both center and position. So I'm actually, instead of having these hard-coded numbers, just going to put in our 10 and 25 coordinates. So this position of the map matches exactly what we're already hard-coding. 13 zoom is a lot, so I'm going to change this down to something like 5, something way less zoomed in. And I also don't care about this scroll wheel zoom prop, so we're going to go ahead and get rid of it and save this file again. And until we actually get proper setup for our dashboard styling, the map that we have on the page is not going to have any actual width or height. So let's just give it something hard-coded for now just so we can see it. So I'll give this a, give this a width of 500 pixels. And I'll also give it a height of 500 pixels as well. Just hard code it. And now let's take this map component and let's go over to our app here. And let's put it above the current weather card. It's going to render out map just like this. Looks like the import isn't quite recognized. So I'm going to take this here. Copy it. This will be import map. And it should be export default, so it can be whatever name you want it. And then it should just be /components/map, just like this. And now it should be happy. And if we go ahead and save it, yeah, it's going to look pretty horrible. And this is likely because we haven't actually imported any of the CSS from Leaflet. So to import the CSS and make it actually look not like whatever the heck this is right here, let's go into the map component. And at the very top here, we're importing everything else. We're just going to add import leaflet/dist/leaflet.css, just like this. Go ahead and save it. And now this map should actually be somewhat functional and not whatever the heck we were just looking at. And this 500 pixel width is actually a bit small, so let's change this to be, I don't know, just 1000 pixels, just so it's a bit wider. Go ahead and save it. And now we have a little bit more real estate to work with. So yeah, here's really what the map is. And this is, again, powered through Leaflet, the very popular library. The map doesn't really do anything crazy by itself, but what it does allow for is you can drag it, you can look around the map, you can zoom in, zoom out, see different city names. And it's actually supports a very high level of zoom, so I can go on individual streets here, and I can go out to the whole global level. It's actually a really, really cool mapping library. I've used it in a few things before, and I've never really had any problems with it, so I think it's quite a nice library to use. By default, it honestly looks and behaves very similarly to Google Maps, minus obviously a bunch of the complex Google functionality. So it's pretty cool though, actually with super minimal setup and just pasting in a command and changing some stuff around, that we're able to actually get a functional map like this. It's nice when these libraries and packages can do a lot of the heavy lifting. Something that is actually pretty cool now is this marker is positioned at latitude 10, longitude 25. So now when we're looking at our weather information and we see like the current weather and the forecast, we at least actually have a reference now to where in the world we're actually looking at, which is part of the point of even having this map in the first place. Here's the point in the video where we need to step up our game and start connecting everything together. Because right now, aside from being kind of cool, this map doesn't actually do anything. Nothing happens when you click it. It has no connection to any of our data or anything, aside from the hard-coded coordinates we're giving it. So a big piece that we're missing is connecting this map somehow to the cards, so that when we click on the map, it'll update the latitude and longitude to update the information on our cards. What I think we need to do next is hook into the actual click event of the map, somehow set some latitude and longitude state, and then connect that state to the query that we're making to actually get weather information for those coordinates. Because all we've done so far, every time we use this useQuery and call the getWeather function, we're just hard coding 1025 in there, which, you know, is cool for testing, but it's not functional. So if we actually found a way to hook into the click event of this map, update some state, and get our query to reflect that actual weather information, that's the next big step that we're missing. So without wasting any more time, let's go ahead and build out that functionality. React Leaflet has a hook called useMap that allows us to get access to whatever map container that we're referencing. Once we have the map from useMap, we can hook into all sorts of events, control camera panning and zooming, and all sorts of other stuff. This useMap is what we'll use to hook into the click event. However, the main problem we're going to run into right away is that useMap can only be called if we're inside a map container. Otherwise, it's not going to work. The reason why we can't do that in this map component is because this map component, if we were to call, useMap up here, this map component is not wrapped inside a map container. Only the things that are actually inside of it would be. So the way I've typically handled this in the past is just creating a brand new component beneath this that I would just usually call map click, just like this. And then this component right here is where we would actually use the use map hook. So we'd call it down here. We would get this imported from React Leaflet. And then because this component is purely for functionality for getting this map, we actually don't care about returning anything. So we're going to return null for this. And then inside of here, we're just going to render map click just like any other regular React component. Now, because we're calling the useMap hook inside of a map container, this object that we're going to get back here, this map object, will directly reference the map container that it is inside. And basically, all we have to do now to actually hook into the click event to do what we want it to do is go down here, and we would just say map.on, and we can hook into the click event just like this. And then our event handler would be the second argument, which is a function. So we'll take an E and make it a function like this that will get called whenever we click the map. In other words, if I go in here in the map and I start clicking around, whatever function we have right here is going to get invoked on each click. Before we worry about the actual click functionality and setting any sort of latitude or longitude state, it would be cool if we added a pan effect. Meaning if I click somewhere on the map, we should make that click point the new map center. That way if I click somewhere on the edge of the map, like over here in France, the map will actually move over and shift to center the area that I just clicked. And there's actually a super simple way we can do that in this onClick. All we have to do inside of this function is type map.pan2, just like this. And the first argument that this pan2 takes in is an array that is just the latitude and longitude. That way the map knows which coordinates to actually pan to. How do we actually get the latitude and longitude out of our click event? All we have to do directly above this pan2 is we can actually get it from this E event here. It exposes the coordinates that we clicked on. If, just to show you, I go ahead and console log out E here, I'm going to comment out this pan2. We'll go ahead and save this. I'll open up our console right here. And the map's super tiny, but I'll go ahead and click somewhere. And if I click, here is the event. And you'll notice we have this property right here called lat longitude, or lat LNG. And it has the latitude and longitude coordinates that we just clicked on right here. So basically what that means is what we can do in the code is to get the latitude and longitude, we can actually destructure them. We can say const lat and then also LNG equals E dot lat LNG, just like this. And it's really that simple. Now this will be the latitude and this will be the longitude. So we can uncomment our pan2 and we can say lat longitude, just like this. And now it'll pan to wherever we click. If I go ahead and save this file, go ahead and refresh just in case. Now if I zoom out and I click somewhere, notice how when I click, it is panning to where I'm clicking. And it doesn't quite look centered actually because this map is way too huge. It's kind of overflowing the bounds here. So let's take it from 1,000 pixels and let's do 700 pixels, just slightly wider than it was before at 500. And that's a little better. So now if I click, it's a bit easier to see that it's centering where I click. So when I want to jump around the map, say I'm in Africa and I want to go to Italy, I can click here and it'll pan everywhere I click. And it's really just that simple to create a pan effect. Obviously, this marker that we have right here isn't changing yet because this marker is still hard-coded to this 1025, but we'll fix that in just a second. But now that we have this pan effect working, what's next? Let's get down to what we really came here to do. Inside of this click event on the map, we don't just want to pan to wherever we clicked. What we really want to do is set some latitude and longitude state of wherever we clicked. That way the other cards on the page can update their information to reflect those actual coordinates. The question is now, how do we even start by going about doing something like that? Well, the simplest way I can think of is by keeping track of latitude and longitude in the app component, so the most parent component, because it happens to be the direct parent of the map, but also all of our cards. Basically, what I'm saying is that if we're getting the latitude and longitude in the parent, and every component that needs it is just a direct child, it's actually super easy to do because we can just store it in app and then we can pass it down as props to each of the children. If you don't fully understand where I'm going with this yet, let me just show you firsthand and we'll work through it. First things first, we're not using this useQuery up here anymore, so let's just completely get rid of it. Then what we're going to do is make a new state for our coordinates. We'll say const coords, just short for coordinates, and set coords equals use state, just like this. And in terms of the type for these coordinates, we'll just make it an object. We'll just give it a lat property, which, you know, we've been using this 1025 number, so we'll keep using that. So we'll say lat and lon, just like this, making sure to import use state. So basically we have this coordinate state and the setter function for coordinates. We're making a state in React, and we're just defaulting it to an object with default values 10 and 25. If we go to any of our cards, like current weather, for example, we still have this hard-coded 1025 number. But now that we have this chord state up here, let's use that instead so they can at least all share the same state. So what I'm saying with this is we should take coordinates and pass it down as props to all of our cards down here. Now, if I had a ton of components and the complexity was a bit more in-depth than it's gonna be here, I would most likely use a provider and pass the coordinates down with a context. That way we're not drilling props everywhere. However, because these cards are the direct children of the app component and we're not doing huge amounts of nesting and, you know, huge component complexity, I think it's best for simplicity if we just do them as props. Because we're going to be seeing this type structure right here a lot of the object that has the lat and longitude property, what I'm actually going to do real quick is just go into source here. I'm going to make just a new file in here. I'm just going to call it types, and it'll just be like a helper function that we can export types from. I'm going to say export type chords, and we'll make it match the structure that we were just talking about. We'll have lat be a number, and lon, and longitude also be a number. And we don't really have to do this right now, but let's just go into app, and just to make sure, let's make sure the state is typed with type chords, just so we're being explicit. Now that we have this chords type, let's pass down chords to each of our cards. All we have to do for that for each one is we'll say chords equals chords, just like this. And because they're all going to be the same, let's take this, copy it, and paste it in all four of them. Again, like I said, if we were dealing with more complexity, I'd probably do this in a provider to prevent these props just being passed on everywhere, but I think this keeps it pretty simple for our use case. Now each of these will have a type error because they don't expect any actual props. They don't expect this chords yet. So let's go into current weather, for example. Let's go into the props here. And we'll just make sure to add chords as type chords, just like this. And we can destructure chords from the props, just like this. Now for our suspense query, instead of hard coding 10 and 25, what we can do now is just say chords.lat and chords.lon. So we can be assured that the coordinates that we're getting down in this component, this current weather card, are the same coordinates that are set in the parent. And we'll have to make the same changes to our other components to make TypeScript happy and to make sure this all works the way that we want it to. So let's actually take the suspense query. I'm going to go each of our cards here. Let's replace these suspense queries through an hourly. We'll do it in daily, and we will also do it in additional info. And then these will need the exact same prop structure as current weather. So we'll just take props here, also doing the same thing. Make sure these are all typed the exact same, because again, they're only all just taking in the coordinates. So we'll have this, and for each one, make sure we import chords here and destructure chords. So there should be additional info good to go. We'll make sure we import chords here in the daily forecast. Also destructure from here. Save this. Now this is good to go. Get chords out of here. Import the type. Hourly forecast should be good to go. And now that should be all four of them taken care of. Now all four of our cards are using a shared state from the parent. So we can actually go ahead and just, close out of these cards here. Let's go back to our app real quick, and we can see we've suppressed all of the type errors. Now, just to see what happens, if I go ahead and refresh this page here with our 1025 coordinates, actually here real quick, let me save this, refresh it, you can see it says we're at 76 degrees, 1246, whatever. So let's change this 1025 to something else. Let's make it 4055 instead. And now if we do this, go ahead and save it, all of these cards just changed. I can do it again, let me just show you. I'll do this 5045, and now every single card just shifted because now they're all using the exact same coordinate state. They're not just a bunch of hard-coded numbers coming from nowhere. Now that we did this, step one is complete for connecting the map and these cards. The next step would actually be, logically, to get this same coordinate state passed down to our actual map. Because right now we have this marker that's on the map, but the marker doesn't mean anything. It's not really coming from anywhere. So ideally, the map actually needs the same coordinate state because it needs to know where to place this little blue marker at. So what we can do in map is the same thing as the other ones. We can give it a type chords, and here in our props, destructure it. And instead of using center 1025 and position 1025, I'm gonna actually destructure here to make it a bit easier. We'll say lat lon equals coordinates. Get these out of here. The 10 will just be latitude. The 25 will be the longitude. So now the map is also using our shared state, and we'll just be sure to actually pass this down in the same way we're passing it down for our other cards. We'll go ahead and save both of these now. And now if we look over at our map, it looks like our marker has moved over here to somewhere in Russia. Now that that's taken care of, and the map also has respect to the same latitude and longitude coordinates, let's take care of the important part. And that's setting up the latitude and longitude coordinates once we actually click the map. So basically, utilizing this set coordinates function. So what we'll do in our app here is let's make a new function. We're going to say const on map click, make it a function, and we'll just make it accept 2 arguments, latitude, which is a number, and longitude, which is also, of course, a number. What we're going to do is we're going to define this on map click function up here in the parent. We're going to pass it down to the map, and then we're going to call it in the map whenever we do the click event. The reason for that is the state that we want to update is up here on the app level. But whenever we call it, we can just pass in the appropriate latitude and longitude from the map click event. So that's where these arguments will get passed in. So inside of this on map click, all we need to do for right now is just say set chords, calling the setter function, and we're going to set it to lat and lon, just like this. So basically, whatever we pass in for our latitude and longitude will be what the new coordinate state gets set to. Now the question is, how do we actually get this on map click function to get called in the click event of the map? Well, like all the other things, we're going to use props. So we're going to go to our map here. We're going to add an on map click prop, and we will just pass in this on map click function. Go ahead and go to the map here, and let's add on map click. We know it takes in 2 things. It's just latitude and longitude, both numbers. Doesn't return anything, so we'll just say void. Now if we save both of these, we're passing on map click down, and now in map, we have the ability to access it from our props. So let's go ahead and destructure it just like this. And then we'll also have to drill this on map click down to our map click component so we can actually use it in the click event. Normally, I would say prop drilling is a bad thing, but if it's only 2 layers and it's only for a single thing that you're doing, it's really not that big of a deal. If I was going deeper than 2 layers, definitely I'd use a provider and pass it down through context. But for now, we'll just make things simple, and we'll also give the same exact prop to our on map click. So we'll drill it down to this component here and make sure that our map click expects on map click, which is just of type. It's actually the exact same type up here. So I'll just go ahead and copy this. It'll be on map click, just like this. And now we've finally done it. We've actually arrived at the click event with our on map click function. So now all we need to do is actually just call it in here, right below our pan2. All we'll do is call on map click. And again, we know the signature is taking in a lat and a longitude number as 2 separate arguments. So easy enough. We already have those 2. We'll just pass in lat, comma, lon to get latitude and longitude passed in. And now we've actually done it. Our map is fully connected to the click event where we will propagate this data back up to the parent, which will update the coordinates. So let's test it out. If I actually save it, refresh this to be sure, and click it, we're going to notice something. It looks like nothing is actually happening for our cards. The state actually is getting set properly, but nothing seems to really be happening in terms of the state update. So let's test something really quick. Let's go into app here, and let's just add a console log, and let's log out our coordinates here. Go ahead and open up our console. Close out of all this. Oops, not the console itself. I just wanted to shrink this down. So let's close this. Let's just click somewhere on the map. You can see we have our latitude and longitude coordinates right here. If I just, scroll in this little tiny window over here, expand it a tiny bit so it's easier to see. I click here. You can see if you look in our console, it actually is updating the coordinates. So it looks like the state update is going through, but for whatever reason, our cards don't actually seem to be updating. And there's actually a very simple reason for this and super easy fix. Right now, all of our cards, like current weather, hourly forecast, whatever, all have the same query key. It's just this string weather. However, generally a huge no-no with TanStack query is that whenever you're passing in dynamic values to your query function, like we are, for example, with the coordinates, because, these can change, you want to make sure these coordinate values are included as part of your query key. Because what's happening right now, since these all just have this hard-coded weather query key, is when we click somewhere on the map, it adds that weather key to our cache, and then we click somewhere else, and it sees the exact same key, even though our coordinates change. So it just uses the data that is already there, meaning we're always going to be stuck on whatever the first cached value is. That's why you usually add these dynamic values like coordinates to our query key. That way it knows to update with each one. In other words, if the query key is always static, the cached value in the TanStack cache is going to be treated as static as well. When I say this fix is super simple, it is. All we have to do is in our query key, add coordinates to it like this, a fresh query key for each time we click somewhere. So we'll go ahead and take this, we'll actually save it, and we'll go into each of our cards and make sure that all of them expect that exact same query key. That way, they're all not static anymore. Go ahead and get this one, and we will get additional info for the final one right here. And now, if we go ahead and just close out of all these cards, and we go back to our map, and I click somewhere, boom, all these cards are going to update now. I can kind of scroll to the bottom here so you can see a bit of the current and the hourly. You can see if I'm clicking somewhere on the map here, these cards are updating in real time. So that's super sick because honestly, in a really short amount of time, we just got our map hooked up to all of the cards. So now all of the components that we're seeing on this entire page all share the same value context. No matter where I click on the map, every time I go somewhere, looks like it lags a little bit sometimes, but every time I click somewhere, these cards are going to update completely. So we actually already have a huge chunk of functionality of this app knocked out of the way. If I want to know the weather information for, I don't know, somewhere in Japan, let's say Tokyo, I can go here, and I actually, forgive my geography here, I don't know, I think this is Tokyo here. Can select this, and you can see this is the weather information for that particular city. If I want to go, I don't know, I'm curious to see what the weather looks like in London, and scroll over here. Go to London, click here. Like it's in a bit of lag there, but we have 44 degrees, and we can see the hourly forecast, the daily forecast for the next week, and all sorts of additional weather information. So that's super neat. Now that this functionality is out of the way, what do we want to tackle next? The next thing that I like to do is add a location picker dropdown. It's super nice being able to use this map and click anywhere you want to get the exact weather. But as you saw, sometimes I want to know the weather for a particular location or city like London or Tokyo. So what I think would be neat is above this map here, having a drop down that we could click that would have a list of pre-populated popular cities. So instead of having to zoom in the map and find it, I can just open the drop down, click wherever, and it'll get the weather information for that particular city. However, creating a fully functional select component that is styled great and works exactly like we want it to may take quite a bit of time building from scratch. Which is why right now, instead of building our own custom select, we're instead going to use Shadcn for some of their pre-built components. If you're not familiar with Shadcn, essentially it's just a component library that allows you to install components as needed. Not some library where we install 10 gigabytes of packages or anything crazy. We can just import some pre-made components like these ones into our app. If you want to build your own custom components just for the sake of learning, that's completely fine, more power to you. But for this video, to save time, we're going to use these pre-built Shadcn components. For example, if I go to the view components here, I can find the select component, and if I look at this, it's a drop down just like this. Pretty much already coded for us. Obviously we can put our own data in there, but the component is already essentially made. This is going to save us a lot of time, as opposed to trying to code all this logic in-house. While there obviously can be unique use cases where you need to do your own thing, I think it's important to not reinvent the wheel, especially if you want to keep things consistent. So in our use case, we'd have a drop down like this, we would click it, and there'd be a list of cities here that we can click, and when we click, it would update our map and all of our cards. The way that Shadcn works is for each component that you want to add to your app, basically all you have to do is just run this command right here, this npx shadcn at latest, and you just add whatever component you want to add. And then from there, you can actually just render out the component like this. They have a bunch of examples, but essentially you just import the stuff from the component, and you can put your own content inside of it. However, before we do that, we need to make sure our project is set up to add Shadcn components, because there is some setup required before we can actually run this command. If we go back to the menu up here, and we go to the installation page, go to Vite, should be the default there, and there's already some commands here, create the Vite project, which you've already done, Tailwind CSS, we already have it, so let's move on to this step down here. First things first, it tells us to edit our tsconfig.json file, so let's go into our file explorer here, go to tsconfig.json, and it wants us to add these compiler options right here, right underneath the references array. So we'll take this compiler options, take it like this, and add it right underneath references. Go ahead and save it. And next it says to also edit the tsconfig.app.json, so we'll go to that file as well. And we already have the compiler options here. We just need to add this base URL and paths here. Let's copy this. Let's actually go to the very bottom here. Actually, let's see, compiler options ends here. Okay, so let's go inside here. and just add it right here. Make sure to have a comma so it doesn't get mad. And now we have this added, so we'll go ahead and save this file here. And next, all we got to do is get these types installed so we can actually resolve our file paths whenever we try to import the components. So we'll take this command, open up our terminal, copy paste it in there, go ahead and run that. And then the very last thing I think that we need to do before we can start adding components and we can initialize the project is just to add some stuff here to our vite config. So if we go to our vite config file, it says that in addition to having the plugins here that we have, so we already have, React, Tailwind, and svgr, we need to add this resolve object right here. So let's just copy that, go here, paste it, and then this path should just be imported directly from path, just like this. And now if we save it, we should be all good to go in terms of our own files. Now that we have all these, to actually get Shadcn in our project here, all we need to do is run this command right here, this npx shadcn latest init. So what we'll do is we'll take this command here, copy it, go into our terminal, and we'll go ahead and paste it in here. Didn't quite copy and paste, right? So let's make sure it just runs this. And it'll ask if we're okay to proceed to install Shadcn. We'll say yes, of course. It's going to ask for a color palette. For this one, we'll say zinc. I like zinc quite a bit, so we'll go ahead and select that. And then it should install the dependencies and get the rest of it set up. And now we should be good to go. Now let's actually go back to our page here. Let's go ahead and refresh it. And just to make sure everything is actually fresh here, let's restart our Vite server. So I'm going to go Control-C this, npm run dev again. And now if we save it, go back to our page here, notice how all the styling suddenly looks pretty bad. These cards have a bunch of dark text now, and now the background of our app is white for some reason. And that's because if we go to our index.css file, when we initialize Shadcn in our repo, Shadcn added a bunch of different variables to support the zinc color palette. So we have things like background, foreground, cards, popovers, all this stuff, that it added some of this predetermined styling to our page, so that's why it looks a little funky. Let's fix this real quick before we add the select. In our index.css here, notice how we have this card variable. This card variable is actually exactly what you think it is. If we have cards on a dashboard, we want them to use this color instead of just some random other hard-coded color. So what I mean by that is if we, let's just close out of all these tabs here, more room, we open up card.tsx, go to here. Right now it is just background zinc 900, but if I instead change this to bg card and save it, now this is actually going to match this card variable that we defined in here. Now, however, what we've just kind of done is switch from working in an app that was pretty much in a dark mode configuration to a super bright and just white app that's, essentially just light mode. We're going to add a toggle later in the video to go back and forth between light mode and dark mode, but for right now, let's go back to the dark scheme that we had before. All we have to do is to go into our index.html, and if we go to this body tag right here, all we have to do is add class equals dark, just like this. And if we go ahead and save it, now we're back to the dark theme. And this is something that's actually really cool about Shadcn that I'll explain in way more detail when we actually do the light mode and dark mode switcher. But basically what Shadcn does is we have this variant here for dark, which checks the body for having this class dark on it. And if that's the case, what it will actually do is instead of using all these variables, which these variables are defined for light mode, it will actually use variables defined down here specifically if we have dark mode. So now instead of using this card right here, which this card right here is just white, it'll actually use the dark card right here, which is more of a zinc color, which is why we see this color over here of the dark color, not the light color. Because this dark selector is a dark class selector, and on the index.html, we do have the dark class. Again, I'll explain this more once we get into our light mode and dark mode switcher, but for now, we're just going to have it hard-coded to dark mode because I think it's easier to work in. I just prefer it. I don't want to get too sidetracked from adding the Shadcn components to our app, but real quick, something that I think would be super cool to add is to make these cards look a little bit more reflective. So right now, they're just this solid color, but one thing you can do that can kind of make stuff pop out a little more, in my opinion, is instead of just doing a solid color background, if you instead do a gradient, so I'll do bg gradient to br, meaning a gradient going from the top left to the bottom right. And then a neat little trick I like to do is when you do gradients, to start it from the card color and actually have it go to the same card color, but with slightly less opacity. So we'll say, I don't know, /60 for this. And it looks like if you hover this, it's giving us a warning. I'm curious what this says. Can be rewritten as bg linear to br. So, okay, let's try that. Must be a new Tailwind thing. So I'll go ahead and save that. And now our cards, I think, look a little bit nicer. It's a very, very subtle change, but it makes the cards, in my opinion, look a bit cooler. It just looks a little bit brighter at the top left than it does in the bottom right. Now that we've got these colors looking good, let's get back to the whole reason why we added Shadcn to our app in the first place, to add the select box for particular locations on the map. So if we go back to Shadcn and we go to the component menu, which you can go here, go components, we can find select again. Let's scroll down to where the command is to add the select. Looks like it's this command right here. What we're going to do is we're going to take this, we're going to copy it, open up our terminal, and just run that exact command. Not sure why for some reason this copy and paste seems to be acting up, but do that. And once we run this command, it'll actually install the select component and just the select component from Shadcn into our repo. What it does that's actually pretty cool is it will go into your repo and it'll look for a folder called components, which we already have. And if you have that already existing, it'll make a new folder called UI, and this is where all the Shadcn components go. So now you can see we have this component, select.tsx in here. That is just the Shadcn select component. Now that we have this, we're free to use it however we please. And if we look over here at Shadcn, it gives us a perfect example of how to actually use the select, just like this. What we're going to do is we're actually going to take this right here. We're going to copy this to our clipboard. I'm going to go over to our file explorer, and inside of our components folder, I'm going to make a new folder, and I'm going to call it dropdowns, because we're going to have, I think, 2 dropdowns in this app, not just one, which I'll explain in a second. But I'll make a new file in here that I'm just going to call location dropdown.tsx. This is going to be for our map. tsrfc as usual to create this component. And now that we have this example over here from Shadcn, we have it copied. So let's now paste it into this component and get all these imported from UI/select. Now it's kind of annoying because you'll see the add import from Radix UI, but all these are going to be imported directly from our own UI folder. So we'll do here, select content, import select content here, and then just import select item. And now this component should be good to go to at least test. Now, what this is this select trigger component right here is essentially just the button that triggers the dropdown to open and close. And select content is the dropdown itself. So for example, over here, if we go to this button you're seeing that says select a fruit over here is the select trigger. Now the select content is what actually gets dropped down right here. And we have all this just wrapped in the select component. Now that we have this file saved and we have this component, let's go back to app.tsx here. And directly above our map, let's actually render out location dropdown over to our page. And let's go ahead and save it and give it a good old refresh. And now you can see up here at the very top left is our dropdown, and in its raw form, it looks something like this. And it actually looks like it's getting cut off quite a bit by the map because the map's just covering it. One thing I've noticed for some reason with Leaflet is that sometimes the maps that you use have a z-index of around 1,000 for whatever reason. So to have the dropdown to show over the map for right now like we would expect, let's just go onto the select content here, and let's just give this a class name, and we'll just say Z1001. I generally like to stay away from spamming Z indexes everywhere, but sometimes you gotta do what you gotta do. So let's save this, go back, and now you can see it's opening up over the map, and this is what it looks like in its raw form. Now let's get some real content into this dropdown. Obviously, we don't want light, dark, and system because that has nothing to do with what our dropdown actually is. So let's get some cities added to this. I just went over to ChatGPT real quick and asked it to give me an array of really popular and well-known cities, and this is what it gave me back. So instead of just having some random values in here, let's actually use these cities to put inside of our dropdown. The way that we can do that is just to wipe out what we already have here for the select items. Let's make a JavaScript expression in here, and we're just going to say locations.map, and then for each location, actually let's call it a city. For each city, we want to map over something, and you want to return the same select items we were using before. We'll just do it like this. And you want to make sure, because we're mapping, that we have a key here. So we'll say key. Key will just be the city name because these should always be unique. And then all these need a value as well. And the value will also be the city, which also will be what we're putting inside the select item here. So that's what the user sees. Now if we go ahead and save this, go back to our page, click on this. Now our drop down is full of our cities instead of whatever random stuff we had before. So I can click on Tokyo, Dubai, London, whatever I want to click on, and our dropdown is actually looking pretty cool. Now what's next? Well, unfortunately, when we're making these calls to OpenWeather to get the weather information, it only accepts coordinates in latitude and longitude. So if I select Tokyo, for example, how do I have any idea what the latitude and longitude coordinates of Tokyo actually are? I need to have some way to convert city names directly into latitude and longitude coordinates. Luckily, that's exactly something that OpenWeather has support for. It's called the Geocoding API, which you can just get to at /API-Geocoding API. Basically, what this endpoint does is it takes in the names of countries, cities, states, or whatever, and can return latitude and longitude coordinates that match. If you look at the way to call the API, it's actually pretty simple. All it really needs is for us to pass this Q parameter right here that can be the city or state name. If we go to the actual API response fields, you can see here once we pass in, for example, a city name, here's what we'll get in return. We'll get a name for the local name, in those particular languages, and then what we actually want, the latitude and longitude. So we just spit in the city name and we get out the coordinates. So what this implies is, much like how we're doing the fetching from the one-call API for the weather information, we'll do the exact same for a function that calls this geocoding API. Where we did that originally was in the api.ts file. So let's go back to this, and all we'll have to do here is make another function, just like getWeather, that calls this particular geocoding endpoint instead of the one-call endpoint. So what it will call, if we scroll up past this, let me actually minimize this here. What it will actually call is this URL right here. What we'll do here is we'll go into api.ts, we'll make a new function, we'll say export async function, we're going to call it getGeocode, just keep our naming conventions pretty similar. And inside of here, just like the other one up here, let's actually take this, let's copy and paste it in here, but instead of using this link, the same one we're using for getWeather, let's take this exact link right here. So we'll go ahead and copy it, and let's paste this in to our string instead of that. We'll do this, paste it in here, and now let's modify this to be what we want. As you can see here in the docs, it says this Q can be a city name, state code, country code, whatever. We don't really care about all that. All that we're going to do is a city name. So that's all we really need. So basically, in this call here, where we have that, we're going to replace this whole chunk here, this whole Q equals chunk. We're just going to replace this with $, brackets like this, so we can inject something. And we're just going to say location, which will be an argument that we pass into this function that will just be a string. So for example, if I go into our dropdown and I click something like Tokyo, that will pass Tokyo as a location into this function, which will then get the latitude and longitude for Tokyo by passing it in here. For this limit right here, let's just hard code it to 1. Reason being is you can get multiple in the form of an array. I don't really want that. I just want one match because I think it's sensible enough to assume there'll only be one source of information for any given city. And then just like the other one where we have this app ID, we're just going to plug in our API key just like this. So we'll add the $ here and we'll do API underscore key. And now we're passing our API key through to this API. The only last thing to do is we're already converting it to JSON, but what we're not doing is parsing it through a correct schema. We're still using the same schema as the weather information, which obviously we don't want because the response structure is different. So let's make a new schema. Luckily, the schema that we're going to have for this is actually super simple and easy. I mean, there's only a couple of fields here to actually take into account. So what we'll do is we'll go back to our File Explorer here. We have the schemas folder. Let's make a new one. We're just going to call it, geocode schema.ts, just like this. And then we'll need a Zod schema that matches this return shape from OpenWeather. I'm again trusting my good friend ChatGPT here to generate me the schemas. Basically, all I did is just took this exact response shape from OpenWeather and asked it to make me a Zod schema, and this is what is spit out. And if we just quickly look at this, it looks like it's correct. I mean, we have name, which is a string. Lat and lon are both numbers, obviously. Country is going to be a string, and state's also going to be an optional string. And then local names we're not really going to use, so it doesn't really matter, but this does look to be correct. Now that we have this schema, much like we did for our weather information, we'll parse that schema. So if we go here, all we have to do is say geocode schema.parse the data, and we actually should be good to go now. If we save this, this function should be ready to take for a test drive. If we hover over get geocode, you can see the response type is a promise because the function's async, and it just has this structure. So we know we're going in the right direction. All right, now let's hook up this API function into TanStack query and get this ball rolling. If we just close out a few of these files real quick, just to free up some space here, we head back into app. We already have a use state that stores our coordinates. Let's make another use state that stores the location that we've selected in the dropdown. So if I go here and I select Dubai, we should have a state that now holds Dubai. So what I'll do is I'll say const location, set location equals useState, and it'll just be a string. Let's just default it to Tokyo. We'll assume Tokyo is always the default starting point. And then to geocode using that function we just wrote, all we have to do is write a useQuery in here. So we'll say const get data out of here equals useQuery. And like any other useQuery, we need a query key and a query function. For the query key, let's say it is an array. We'll just say it's the string geocode, and we'll also pass in the location. Because again, like I showed you with the weather information, we want to make sure if our query function is going to consume location, which it will, we need to have that be part of our query key. Now we just need the query function, which is the function that we just wrote, which we called, I believe it was get geocode. So we will call it like this so we can pass in arguments. And if we go back to this, remember this just expects one argument, a location string. So we'll go here, pass in the location because it is the string. Just like this. Now this query should be good to go. Now if I go ahead and save this, we can actually see what's going to happen. If I go over to our console here, let's go to our network tab so we can see the request. Let's just go ahead and refresh this. You should see that we have this one call, which is from the actual, the weather information we've been working with. But we also have this other call right here, direct. And this is the response that we're getting from the geocoding. So we can see if we look at the headers, it is the geocoding one. We're passing Tokyo in the request URL here. So if we go to response, we go down to latitude and longitude, boom, there they are. Jackpot. So now we know that we can pass in any city name, at least any city name that OpenWeather recognizes, which it definitely should recognize all the major ones. And we know the response from this geocoding API will give us the coordinates of wherever we want. And that is going to be huge because as we know, our weather information requires numerical coordinates, not just names. So now we can use these coordinates that we're getting back from the geocoding. Now that we have the latitude and longitude from the geocoding, that means there's two possible spots these coordinates can now come from. Either they come from the geocode API, if we click on a city from the dropdown, or they're coming from the map click if we're looking for our own custom location. What that means is that this coord state right here needs to accommodate for both. How do we know whether we should use the coordinates from the geocoding, so from the dropdown, or whether we should use it from the map click? An easy way to do this would be to check and see if this location string right here is actually a city name. My thought is what we can do is in the on map click, we can set location just to custom like this. Because every time we click on the map, we know we're not finding the information for a city from the dropdown. So let's just set it to custom each time we click it. What this will allow us to do is define which coordinates we want to pick. If it's custom, use the map coordinates. If it's not custom, use the geocoded coordinates. And that's how we're going to differentiate them. So down here, what we can do is let's actually rename this coords to just be coordinates instead. Because we're going to redefine coords down here as a derived value. So we're going to say const coords, and we're going to make this a ternary. We're going to check the location, and we're going to say, okay, if the location is equal to custom, then what? If it's custom, we know that we're coming from a map click and not the dropdown. Therefore, we should just use this coordinates value up here. So let's say if we're on custom, use coordinates just like this. Otherwise, if we're not on custom, that means we click somewhere on the dropdown. So let's use those instead. And I just showed you if we go to the network request, again, just so we can double check this. If I just, let's close out of this real quick, refresh, and I look at one of the geocoding calls, we have the object, and then we have the latitude and longitude. So if we click somewhere from the dropdown, instead of using coordinates, which is for the map, we can actually do is set this equal to an object and just say we want this to be latitude, and a lat comes from data. It's an array, so it'll be the 0 index there, and then lat and lon. So lat's going to be data at the 0 index dot latitude, and then the longitude is going to be data at the 0 index dot longitude, just like this. And because data can be undefined, we'll technically have a type error here saying possibly undefined. Let's just add a question mark dot to this, just so we suppress that error. And now what we're saying with this coordinates, the coordinates that we're passing down to our components, is that we're either going to use the coordinates from the map, or we're going to use the coordinates from the geocoding, which is from the dropdown. However, now because we added this question mark dot here, it's going to say that our coordinates can possibly be undefined, so it's going to throw a little type error here. What we can do in that case is we can say if these are for whatever reason undefined, let's just make them both fall back to 0. This way, they're at least always going to be a number. And that should make everything happy. So if we save it and refresh, that should make our map return. And it looks like we keep getting this error kind of crashing our page here, and it's a Zod error saying that for the weather information, it's expecting wind gusts to be a number, but it's undefined. Let's go to that schema real quick. We go to weather schema, look at wind gusts. It looks like this can maybe be optional because we're getting undefined for some of them. So let's just add optional to this. Go ahead and save it, and hopefully that should fix our page crashing issue. Just make sure it won't freak out for a second. Hopefully it shouldn't. And there we go, seems to be fixed. And before we do anything else, just so this code's a little bit more clear on what we're doing, let's not just have this be data. Let's actually rename this to, we'll say geocode data, just so it's obvious that whenever we're getting this latitude and longitude, it's coming from the geocode in case you're reading it over. Now we have just one more thing to add. We're setting location to Tokyo by default, and we're setting it to custom whenever we click anywhere on the map. But one thing we're not doing, which is arguably the most important part of this dropdown, is actually setting any state when we click one of these. So if, for example, I go in here and click London, nothing actually happens on any of our cards or anything because, well, I'm not setting any state on the clicks. To give context to our dropdown on what the current location is and how to set it, let's actually pass down both the state itself and the setter function as props, meaning the location and set location into the location dropdown. So what we'll do is we'll say location equals location, and then set location equals set location, just like this. Our location dropdown doesn't expect those props right now, so let's go into that component and we will go ahead and add them. So we'll say location is going to be a string, and then set location is just going to be a type of dispatch set state action. This is how setter functions are normally typed in React, and it is setting a type of string. Import dispatch from React. And then these should be good. Now we can pull both the location and set location out of here as props. To make sure our select knows what value it should be displaying is, we can just go into the select, we can give it a value, and make sure the value is just set to whatever our current location is. So it's either going to be a city name or it's going to be custom. And then we can take a step farther, and on this same select, we can give it another prop that is just on value change, meaning each time we click one of the options, what we can do is we can get the value out of here. So basically whatever we clicked on, and this value right here is going to be the value of whatever's clicked. So for example, if we click London, because we have the value equals city here, this value will be London. So what we can do now is use the set location prop we just passed down, and we can say set location with whatever value we just clicked on. Meaning if I set, for example, Dubai in this dropdown, now that will set the location state in app to Dubai. If I now go ahead and save it, we can actually see this directly in action. You can see, first of all, now we're actually hovering right over Tokyo. If let's just zoom out a little bit, I want to go to Dubai, boom, our information updates. If I want to go to Rome, again, our information updates. So each time I'm doing it, you can see the data changes. And that's because we're switching which city we're fetching data for by clicking an item in this dropdown, since we're now setting the state. However, there's immediately one problem that I'm noticing. The main problem being that whenever I select a new city from this dropdown, nothing happens with the map. It looks like the data updates right away down here, but the map just stays exactly where it was. It never changes. And I think the way we can fix this is actually super easy. We can just do it in a one-liner. We know that whenever we click a location from the dropdown, the coordinates are changing no matter what. So if I have Dubai selected and I click London, we know the coordinates are going to change. And we know that when the coordinates change, the map component is going to re-render to reflect the coordinate changes. So why isn't this map updating? Well, what I would presume is that if we go into the map component, I would guess that because this map container is kind of just a generic wrapper around the vanilla JavaScript library of Leaflet, it might not consider this center right here changing to be a valid enough reason to trigger a re-render. So we can actually do it manually. A little hack I like to use to force component re-renders is to throw a key on it. If the key of a component changes, React is 100% going to re-render the component. What we can do is on this map container, we can actually throw a key on it, and let's just make this a string. Let's just do, I don't know, chords.lat, comma, chords.lon, just like this, just so it's a string. This way, we can be 100% confident that whenever coordinates change, this string right here, this key string is going to change. Therefore, the map should re-render. So if I save that now and I refresh just to start clean here, and I click on one of these items, now our map should go to wherever we're wanting to go to. And it looks like now it's working, our map is re-rendering. However, I'm sure you're noticing this little problem here, this flickering thing. Anytime we go somewhere, it flickers to, looks like, the middle of the ocean first, before it goes to wherever we're actually wanting to go to. I'm noticing a potential problem actually now with this key approach, because if I click a location on the map, it's always going to re-render the entire component no matter what, which is going to force that little flickering that we're seeing. And this happens really no matter where we go, because this key that we have is actually forcing the re-render. So now we're always just going to be flickering, which is honestly super annoying, and we don't want that. So let's rethink this key approach. I think I've got an idea. Let's remove this key from here. And instead of re-rendering the entire component, let's just call the map.panto function that we have right here directly in the component body of mapclick. After all, we know the only way that mapclick can re-render itself is if coordinates change, because coordinates would be a prop. So what I'm saying is, what we can instead do to fix this little issue that we're having is we are already getting the coordinates passed down here. What we can do is we can actually also pass coordinates down to the mapclick. So let's pass chords like this. Let's make sure we get chords out of this component. And we'll say the chords are of type chords here. And let's actually take this map.panto out of the click. So we'll move it up here. And instead of using this lat and longitude, we don't have those anymore. Let's just use the coordinates directly. So we'll do chords.lat, and we'll also do chords.longitude. And actually, it's not longitude. It should be, I believe it's just LON. Now, what I've just done with this is I have made it so that whenever the coordinates change, now mapclick is actually going to re-render itself because coordinates are a prop. And we know in React, whenever props change, a component re-renders. And the reason why it's fine to have this map.panto in just the component body and not actually in the click event or in like a use effect or anything is because this map should only ever re-render when the coordinates change. And if that's the case, mapclick will also only ever re-render when coordinates change. Therefore, we assume that anytime that coordinates change, we need to pan to a new location anyways, so it's fine to just run this code in the component body. In fact, that makes more sense and makes it less complicated than having to do something like a use effect, which I generally caution against. Now I can show you because I just saved it. If I refresh this, we start in Tokyo, let's go to somewhere on the map, click, and boom, now we get the exact behavior you want. No more weird flickering thing happening on this page. If I go here, select something like, I don't know, Manila, notice how this case, we actually are still having a bit of a flicker. Only when we select something from the dropdown, but not when we select a custom location. The reason this is actually happening and we're getting this weird flicker effect is that because when I click on one of these locations, it is immediately setting the location to the new string. So when I click somewhere, it's immediately setting location and this updates right away. However, the problem is this getGeocode function is asynchronous, meaning it takes some time to actually resolve it. So basically for a split second after we set location, this is still running, it's still in flight. So the actual geocode data that has latitude and longitude is undefined. So basically for a split second, we fall back to 0, 0 for our coordinates because we have this fallback here. And then it becomes defined. So that's why it's causing the flicker. So if I click somewhere here, let's refresh it. I go here like London, it's going to flash for a second because it falls back to 0, 0. And then it resolves and then goes to London. So it's kind of this really weird flashing issue, but it makes sense why it's happening. However, we're not going to fix this quite yet. We're going to address this once we take a look at the skeleton loaders. Once we set up proper suspense boundaries and skeleton loaders, this shouldn't be a problem anymore. Let's move on to the next thing. There's one more thing I want to add to this map real quick to allow it to give us way more information than it currently is. If we go back to OpenWeather, one of the APIs that they have that you can access for free is called weather maps. If we go into the doc for weather maps here, there's something actually really cool that we can do. So over here, you have the map of the world, and they have different types of map you can layer on top of your existing map. So for example, a cloud layer would look something like this. Precipitation layer, sea level, wind speed. And there's a few different layers I think that if we added to our app could make it really cool. And this actually is not nearly as hard as it might look. This is super, super easy and we can get added to our app very quickly. Basically all we have to do is in here, it gives us a URL that we can use. It's this URL right here. We can actually just copy this URL directly. And what we can do is if we go to our map here, we can add a new component in here. So we have this tile layer here that's doing our actual map. We can actually just make another one of those. We can say tile layer, just like this. And in the same way this has a URL, let's take same thing, URL equals this. we'll use backtick characters and go ahead and paste this in. All we need to do now is to pass something in here for our actual layer and then pass in our API key. And it's really that simple. So if we go to the api.ts file, we have this up here. That's how we got our API key. Let's actually take this exact thing and add it to the top of this file. So we'll say API key. And in this tile layer, we'll use that same API key just like we have for everything else. The API key, just like this. And now we just need to look at this layer right here. If we go back to the docs, it says that layer is the layer name. By layer name, what that is this. So for example, the cloud layer is just clouds_new. Precipitation layer is precipitation_new. So those are the layer names we need to pass in to this layer right here to get the actual layer that we want. So now the question is, how do we know what to actually pass in for this layer here? After all, we're inside of our map component, but we have no context of knowing what layer the user wants to see, especially if we want to support all these different layers. Well, what I was thinking is, we already have a dropdown to select the city for different cities across the world. What if we just use the exact same component and do the same for map type? What I'll actually do for this is I'll go to our dropdowns folder. And when I said there'd be another dropdown, this is what I was meaning. We'll make a new dropdown. We will just call this map type dropdown.tsx. And I'm actually going to take all the code pretty much verbatim from location dropdown. I'm just going to copy it. I'm going to paste it in here. And we'll just make sure to rename this one to map type dropdown. And then instead of taking in location and set location, we'll just say map type. And then this one here is just going to be set map type as such. And we'll make sure these just get those out directly. Let's make sure this is also map type here. Rename everything. This is set map type. Then we can actually get rid of these. These are now redundant. And now we essentially have functionally the same dropdown as we have for the cities, but now just for map types. If I go and save this right now, I'm going to go and add it to our app here. We'll just go pass in map type dropdown. Now let's go down here and we have locations, but obviously in here we're not calling them locations anymore. Let's just call this new array types. Instead of having a bunch of city names here, let's just put the types that we're getting from OpenWeather. So again, I think there should be 5 types in here. Let's just copy each of these down. So we have clouds new. Actually, we'll just, this whole thing here, copy it, paste it. So we have clouds new. We have precipitation new. We have pressure new. Wind new. And I think this is the last one, temp new. So now here's the types that we are mapping over. And it's as easy as that. Now we have a functional dropdown that can set a map type state on each click, just like we're doing for the map location. What I'm going to do here is I'm going to go ahead and save this file. Let's go back to our app here. And just so we can render out both the map type and the location dropdown, we're going to Control-Shift-P around this div here, around this dropdown, wrap it in a div, and we're going to give it a class name of, let's say, flex gap 8. That way we can render out both the location dropdown and the map type dropdown side by side. The only thing left to do now is to create a state to hold our map type, just like we're doing to hold our location. So what we'll do is actually we'll take kind of this same format here, copy it, paste it. We're going to call this map type right here. Be map type, and then this will be set map type as such. Because the very first map type that we see in here, I believe, is clouds, or should be clouds new. Let's make that our default state. So let's say, instead of Tokyo, we'll make this clouds new. And then because we made our dropdown the very same format as we did our location dropdown, we can just pass in map type like this. That will be map type. And then set map type is the exact same thing. And now our dropdown is happy. Let's go ahead and save this file here and look over. And now we should have both the location dropdown and the map type dropdown. What's nice about using these reusable Shadcn components is that once you get the component set up for one use case, getting it set up for the next is super simple. As you can see, getting this map type thing was pretty self-explanatory. So because we copied the exact same format, now we know that whenever we click one of these items in the dropdown, we are setting this map type. And this map type is what we need to pass down to our map to plug into this layer right here. So let's go into map here, and we'll actually add that to our props. We'll say we want to pass in the map type, which is going to be of type string. And then we will destructure that from our props like everything else. And then instead of passing in layer right here, we can add a $sign and inject the map type directly. And now we're all set. It's really that simple. So I'll go ahead and save it. And I'll just be sure to now pass in the map type to our map. Oops. Auto formatting's a little weird. Pass in map type like this. Save it. And look at this. We just got a layering over our actual map that has, for right now, the precipitation. If I want to do it as the clouds, boom, here's what the clouds look like. We can do pressure. This is what pressure looks like. And we have super easily just created another layer on our map to show some more information. Super, super cool. Every single one of these gives me a new unique map. And what's really cool is you'll notice, because both the tile layers that we have in map, so meaning the actual map itself that's right here, and the layer for the clouds or precipitation, pressure, whatever, because they share the exact same parent and the way they're positioned, if I zoom in, notice how everything still stays in the correct spot. It's not like when I zoom in or zoom out, the actual, layering of the wind is going to change and shift around. They all stay relative to each other. So whether I'm grabbing and moving around or I'm scrolling in and out, they should always stay in the same spot, which is exactly what we want, because that's how map layering should work. One thing, however, we should fix real quick is the names in this dropdown. The OpenWeather API needs the names in this format right here, but if I were a user and this is the format of the strings I saw, I definitely think it's a bit weird design, right? Because if I want to see, a wind map, I don't want to just click on wind new. It doesn't really make a whole lot of sense. To make these say their actual names and not this whole, API format of names with an S underscore new, whatever, we can actually, let's close out of these tabs here. And let's go back to our map type dropdown. We can actually do a little bit of a trick here. First of all, we can throw a class name on select item here. We'll throw a class name and we'll add capitalize. That way we just capitalize the first letter of each thing here. So now if we go into this dropdown, the first letter should be capitalized of each one. And now for this trick I was talking about, the names we want to display to the user should ideally just be the part of the strings that come before the underscore. For example, precipitation underscore new should just say precipitation. Pressure underscore new should just say pressure. Basically on each one, just get rid of the underscore new. So for what we're actually displaying to the user here, which is this value right here, we can do something super, super simple. We can say .split, and we want to split the string on the underscore character. That way it will split it into an array. So for each thing, if we have, for example, clouds underscore new, this city.split at the underscore will make it an array with the first string being clouds and the second one being new. And since we only want the first part of that string, we can just take it at index 0. Meaning if clouds new is what the city is, this will split it and will only take clouds. So now if we go ahead and save it, look at here, it just says clouds, precipitation, pressure, wind, and temp, just the way that we want it. What's cool with this method of doing it is that the user is going to see the actual names here. But whenever we click one of these, the value is still just the city. We're not doing any sort of split on this. So the API still has the correct value for it. The user just sees something that's a little bit more formatted. And now what this means is that we have a fully functional map layer dropdown that allows us to stack different map layers on top of the existing map. I can see where any clouds in the entire world are, what the pressure is like, what the precipitation is like, and you get the picture. The last thing I want to do with these dropdowns before we go hands off is just a slight modification to the location dropdown. I noticed a second ago that whenever we click a custom location on the map, that it just blanks out the location dropdown up here. And that's because whenever you do a custom location, this doesn't match any city name. Because whenever we set custom location, we're setting it like this. And because we're plugging location into our location dropdown, just like this, as the value, it's going to see custom, and custom doesn't match any of these, so therefore it just goes blank. A super quick fix for this is inside the location dropdown here, outside of where we're mapping over locations, we can just make a one-off select item. So we'll make a one-off just specifically for custom. So we'll say select item just like this. And actually, no, it can't be self-closing. It'll have to be like this. It'll say custom. And then the value itself will actually be custom. And this doesn't need to be an expression. We can just have it be a raw string. And basically, we'll only render this out if we're on custom. So we'll say if location equals custom, then we render this. Otherwise, don't show it at all because we don't want it in there. So now, if I go ahead and save it, now it should say custom in here. If I select an actual name like London, there's no custom in here. But as soon as I click somewhere on the map now, boom, it shows custom in the dropdown. I think that's a bit more helpful to the user than it just blanking out because it looks like an error happened or something. Lastly, just so the user knows which dropdown is which, let's put a label by each one. So let's go close out of these, go into our app component here, and we have this div surrounding both dropdowns. What we can do is take each one of these dropdowns and let's wrap each of them in their own div. So we'll say wrap, we'll do div here. And for this one, we will say the class name is going to be flexgap4. And right above the dropdown, let's just make an H1 for the actual label itself. And this will just say location. And we'll do the exact same thing for the map type dropdown. So we'll go here, Control-Shift-P, wrap it a div, give it the exact same class name as such, and we'll take this same header, and instead of saying location, it'll just say map type, just like this. Now if you go ahead and save it, boom, we have some labels for each one. Let's do a bit more styling on these headers. Let's say for these, we'll give it a class name of, I don't know, say text 2XL, and then font semi-bold. That looks quite a bit better. Let's just copy that and put the exact same thing on the other one. So we'll take this class name, put it on here, and boom, now we have this for both. And I'm actually zoomed in a bit on my browser right now, so let's zoom out so it doesn't do that weird wrapping thing. Let's zoom out so it looks more like this, which puts other cards a bit more in perspective here. And then now that we zoomed out a little bit, actually, I want to change my map to be a bit bigger than it was. So let's go back to our map. And now let's see if we change it back to 1000 and see if it looks good again. Go ahead and refresh this. And yeah, there we go. This looks quite a bit better. We're going to get to some more detailed styling later on, but until then, we're going to leave these dropdowns alone because they're actually working great right now. I can select any city I want, get the location and everything for that city and all the weather information. And on top of that, I can see it for map types you want for any sort of map layering. So I have the freedom to do quite a bit, which means we've honestly come a super long way since the beginning, but we're not quite done yet. The next thing I want to address also involves the map. And for right now, it's pretty clear that this default looking map, like this kind of Google Maps looking thing, I don't think looks very good considering the color scheme of our site. Like this is all kind of a dark mode, you know, the zinc color palette that Shadcn selected. And having this like Google Maps, like greenish blue, just does not blend in with the rest of our app at all. This map right here is just the default map from OpenStreetMap, but if you want to get a fancier looking one or one that matches our theme a little bit more, we can use a service called MapTiler. If we head over to openmaptiles.org and then we scroll down, there's this dark mode map we can use right here that I think would look really cool in our app. It looks something like this. So it's this dark mode theme that I think definitely matches kind of this color scheme way more than this, you know, this default looking one does. So let's get this added to our app. To add a map like this, we'll first have to install the SDK for MapTiler. We can actually do that pretty simply by going into our terminal here and running the command mpmi, and it's going to be at MapTiler / leaflet, that's a leaflet extension, MapTiler SDK, just like this. If we install this, oops, looks like we forgot the in on npm. Let's run that back. Add the in here, and now it should actually install the MapTiler SDK. Now we can close this and go back to our map component. To add this custom cooler looking map to our map component, it's going to be made easier if we have access to the use map hook, just like we do within the map click component. So instead of rendering out this tile layer right here that's just doing the default tile layer, let's make a new component down here that we're just going to call, say, function map tile layer, just like this. It won't take in any props or anything. This component will be super simple. Just like map click, we're going to make it return null because it's purely for functionality, not for actually rendering JSX. We'll do the same thing that we're doing up here by using the use map hook. We'll say const map equals use map. And to mount this tile layer properly, we can use a use effect. So we'll say use effect just like this. Make sure we import use effect into our code. And I generally caution against using use effects, but when interfacing with straight JavaScript, like in the case of this tile layer here, or interfacing with external libraries, it's generally okay to have a use effect. The way we can display this new cooler looking map is if we make a variable inside of this use effect, say const tile layer equals new map tile layer, just like this. And that's going to be from the SDK that we just installed. This will be a function that we can call. Inside, we pass in an options argument, and it needs two options on here. The first one is style, so the actual type of map that we have. And an easy one that actually looks really similar to this map you're seeing right here, but is actually quite a bit more lightweight than it and will be a little bit faster, is just one called basic dark, just like this. So we'll see what it looks like in a second, but we'll use this for our style. And the second argument it needs is an API key. Just like OpenWeather, MapTiler wants you to use an API key if you're accessing its custom maps. And don't worry, you don't need to enter in any payment information or anything. It's completely free. You just need an account to get an API key. On MapTiler's website, so over here, all you need to do is log in, which I will just do now with one of my Google accounts. Once you're logged in, you can just go to this menu here, go to API keys, and you can generate an API key. Once you have this key here, just go ahead and copy it. And then we go back to our options here for MapTiler layer. All we have to do is say API key, just like this, and pass in the string you just copied. Now that we have this, all we need to do is use this new tile layer component. We'll just say tile layer and call this method called add2. And this is where we pass in our map. So I'll just pass in map, just like this. It'll just add this layer on top of our map, making it look like this basic dark style. So let's save this, get a little bit of formatting here. And when working with use effects, especially that involve external libraries, it's almost always a smart idea to have a cleanup. So what we'll do at the very bottom of this use effect is we'll just say return. And on return, you're going to say map.remove layer. And you want to remove the tile layer as such. That way, we're just being safe with how we're adding this tile layer to the map. That also means that dependencies of this use effect would simply be map. Now that we have this, let's go ahead and save this. And instead of rendering out tile layer up here, like I said before, like this is the default tile layer that we're seeing that's getting the Google Maps kind of look. We're going to replace it now with map tile layer, which, like I just said, will now supplant this map tile on top of it to give it that new look. So if I go back here, save it, boom, now our map is dark. As you can see, this matches our actual theme a lot better. I am noticing though on this particular layering, so the clouds layering, these pretty bright white clouds are looking kind of harsh against the map. It's kind of covering up a lot of space here. Like I can't really see anywhere in Europe right now. So what I'll do is actually go to this tile layer that we have here that we're doing for the map type, and we can actually add an opacity on it, one of the props it supports. And let's just do 0.7 maybe. That makes it a bit better just so it's easier to see, not quite so bright. And just for the sake of experimentation, if we click through some of our other map types, this is what they now look like against this dark backdrop. So it still looks really, really clean. And like I said, I think it just looks way better and way more kind of in place than the other map that we had was. Okay, now right now at this point, this is pretty much, for the most part, a fully functioning app on its own. We have map interaction that's hooked up with data queries. We've got map layering with different weather types, the ability to see all sorts of different information, and a few other things. A lot of the hard work is done. There's just a few more things I think we can add to this app to make it even better, along with polishing up what we've already got. With that being said, what's the next thing I think we should do? I think we should do one final thing with this map before we just stop touching it forever. To finish it out, I think one thing that would be good is adding a legend, showing what each of these colors mean. Because for example, if I go in here and I go to the pressure map, I really have no idea what this pressure map even means. I mean, I can assume that the darker colors probably mean higher pressure and the lighter colors mean, lower pressure, but I really don't have context as to any sort of units or what I'm actually looking at. Most maps that look like this with some layering generally have a legend to show what numbers each color represents. If we go back to the documentation for the Weather Maps 1.0 that we're using, up here there's this map styles legend, and it says we have default styles for weather layers. So if we click on it, it'll actually take us to this page here that I can zoom out a little bit. But basically, it gives us the actual legend values for each different map type. So for rain, snow, clouds, whatever, these are the actual numbers you could use for the colors. What this does is gives us an actual quantitative way to make a legitimate legend. It's essentially just giving us the color spectrums that we can use for each different map type. Not gonna lie, I'm too lazy to do this on my own, so I'm gonna take all of these numbers here, each of these objects, plug them into ChatGPT, and ask it to make me one big record that has all of this data in it that we can use to make our legend. So let's go ahead, open up our file explorer here, go to components, and let's make a new one. We will just call it maplegend.tsx for our legend, tsrfc to make the component, and I'm going to paste in what ChatGPT actually generated, which is this kind of massive object right here. This might look like a ton of complicated data at first, but it's really not too bad. It's basically just one big object here, or a record, where the key for each thing is just a string, which is the map type, and then the value is just another object that has some more information, like the title of whatever we're looking at, the unit, and what the stopping points are for the colors. And we have this for each map type. So we have one for precipitation, we got one for temperature, clouds, and you get the idea. The title we'll use to just display something for each legend, the units so we can actually have a unit number, and then the stops are how we're going to generate the gradient for what the legend actually shows. And of course, I could have done this by hand, but I promise you that ChatGPT can make this map type data record way faster than I ever could, so I'm happy with it. The first important thing that we'll need in this new map legend component is the actual map type. Since we have this big record of map type data, we need to know which map type we're actually looking at for our legend. So just like we're doing for the map itself, let's pass the map type down as props. So we'll go in here, we'll say map type just like this, and that will of course be a string, and then we will extract map type out of the props. And now to get the corresponding data for the legend, because we have this big record already, all we have to do is say const data equals map type data at any given map type. So for example, if we pass down a map type of precipitation new, then this data is going to be equal to this whole object here because we're referencing this map type data at that key, so we get the value. Now we just need to build out our gradient for the legend. One of the ways that we can do this is to map each stop point to its color and also exactly where it should be on the legend. So to do that, what I mean by that is down here below data, let's make a new variable. Let's say const gradient stops. It's going to be equal to data.stops. So we're just grabbing this array here. And for each one we want to map. So we're going to say .map. And then we'll say for each stop, what we want to do is we want to make a template string since we're plugging this into CSS. And we're going to say stop.color just like this. However, for gradients to work right in CSS, when we have a bunch of them together, we need to give each gradient a position that is percentage based, meaning the bottom value should be at 0% positioning in the gradient, and the top value, for example, 140 for precipitation, should be at 100%. And that goes for all these different types. This first entry here will always be the 0% point for the gradient, and the last one will always be the 100% point for the gradient. Setting the percentage position for each stop is how CSS knows where each color is actually going to go. The way that we can do that in here where we're mapping is right after we're doing our stop.color, we can actually separate this by a space, and we'll do another expression here. And the way that we can actually get the percentage is by doing the current value divided by the max value. That will give us exactly where we are. Let's first find the max value. We know the max value for any given set of stop data is always the value of the very last array item. For example, for this stops here, we know the highest value is always going to be 140. For temp new, we know the highest value is always going to be 30. Luckily, the way ChatGPT generated it and the way it was in the OpenWeather docs goes from lowest value to highest value, so that makes our job quite a bit easier. What that implies then is that the max data, we can say const, we'll call it const max value, equals data.stops, and it's going to be data.stops.length -1 to get the very last one, and it's going to be that value. So exactly what I was just saying. And now what we can do in this expression is in here, we can simply say stop.value divided by max value. We're going to multiply that by 100, and that whole thing is going to be a percent. So this might look a little bit wackier, this whole gradient stop thing we're doing, but basically all it is for each stop, we're just generating valid CSS that we can use for the gradient, which is this whole string here. This first expression, this first point, is the actual color of the gradient, which we have here with each of the stops. And the second value is at what point in the gradient it should actually be, which is this. And that's always going to be a percentage. So if we take, let's say, for example, we go down here to clouds. This is easy because they're all, 0 to 100 here. Let's say we take this 50 value. Well, for this particular gradient, we're going to say the color is this because we're just mapping over stop.color. And then we're going to take, going back to 50 here, we're going to take that value, which is 50 divided by 100. So we do 50 divided by 100, which is 0.5 times 100, so that's 50%. So essentially, that particular value is this RGB code here, this 247, 247, 255, and it's going to be at position 50%. That's what this thing is doing here for every single gradient. You'll see how we can use this whole string in just a second. The only last thing that I need is to convert this entire thing to a comma-separated string. I can't give CSS just a JavaScript array of strings. It won't do anything. It needs to be comma-separated. So to turn this whole mapping thing, this whole array that I just made essentially, into a string that is comma-separated, all we have to do is do .join, and we're going to join it at the commas. And now we should be good to go. Let's finally use this and get it implemented in our JSX. Let's scroll down here till we have our JSX, and right now, actually, it's up here. Right now, we don't have anything. It's just this div. So let's wrap this in parentheses here. And for this outermost class name, let's give it just a couple of things. First, we'll make it be position absolute, and then we're going to say top for and right for. The point of having this positioning is that when we render this out, it'll be in the top right corner of the map. We'll also give it the same z-index of our map, so we'll say z1000, and also just width 48 to make sure it has a quantitative defined width. Let's now render this out and just see how it looks. So we'll go ahead and save this file here, go to our app, and what we'll do is we'll take our map here, and let's wrap this whole map in a div. That way the map and the map legend can actually share the exact same parent. We'll map this in a div here, the space for the formatting, and then let's give this div a class name of relative. That way whenever we position our map legend absolutely, it positions itself relative to the parent. And now right below our map, we'll just render out map legend as well, just like this. Make sure we get it imported. And we still need to pass in the map type. So we'll do the same thing there. We'll say map type equals map type, just like this. And now if we save it, you can see obviously our map legend doesn't really have a whole lot going on because there's, no styling here besides saying map legend. But we do see it say map legend here at the top right of the map. So it is there. Now that we know it's showing, let's get this JSX in order. So again, I'll wrap this in a parentheses. It's kind of annoying that Prettier seems to want to reduce this to one line when you do a save, which is a bit of a complaint I have with it, but is what it is. So what we'll do first on this div here is we'll throw a couple of things on it. First, let's do rounded XL. Let's also give it a shadow and some padding, and let's give it a background color. Luckily with Shadcn, when it exposed some of those CSS variables, one of the ones it uses is background. So let's actually do BG background. And I don't want it to be 100% opaque because I don't want it to necessarily block the map behind it. So we're going to do /50, so it's 50% transparent. Go ahead and save this now. You can see now we have this little view. Lastly, let's give it a tiny bit of a border for even more separation. So we're going to say border, and then for the actual border color, there's also another variable that Shadcn created called accent that I think will be good for this. So we'll say border accent. We'll also make this not fully opaque. We'll make it slightly transparent. So we'll say /70. Now save it. And it sticks out a bit more. This will be more noticeable when you get to light mode, but that creates just a tiny bit more of a separation from the actual map itself. And now instead of doing width 48, I actually want to change this to width 96. And now that we have that, I think this will be good to go for this outer div. Now in terms of what we want to put in the JSX here, it should actually be pretty simple. First thing we'll do is we'll put a title at the top, then the gradient bar below it, and then the values at the very bottom. Just 3 simple things. We want this in a column layout, so for this outer div, we'll make this flex call, gap 3 to give it that vertical layout. First things first, we'll do the title. We'll make this in H3 here, and this will just be the title, so we'll say class name. We want it to stick out. We'll say text SM, font semi-bold, and then let's do text foreground, which should just be the opposite of background. So if the background is black, the foreground should be white. And for the title, for each stop, we have this title right here, which makes everything super simple. So all we have to do is in here, we have already data. We're going to say data.title. Now that we have the title, we'll make the div for the gradient bar. So we'll say div, and actually, this div is not going to be an open and closing tag. It'll just be a self-closing element. This div is where we're going to use the gradients that we just calculated up here. To do that, all we have to do is say style, just like this, double brackets, make some space for it. And we're going to say background, and we want this background to be the actual gradient. To do that in raw CSS, we can say something like linear-gradient, parentheses. We'll make it go from left to right. So we'll say to right. And then here, we can actually pass in our gradient stops. All this is saying is make the background color of this div a linear gradient that goes from left to right. And here we give it the calculated gradients. And for some more styling here, let's throw a class name on this div. And we will just give it, let's say width full, so it takes up the entire width of the legend. Rounded XL. Give it a bit of a border. We'll do the same border that we're doing for the actual outer. So we'll do a border and border accent 70. And now this should be good to go. If I go ahead and save it, it looks like it's not quite showing up. Let's give it a defined height first. So let's say, I don't know, height 6. And now if we save it, we should see the gradient up here. It's a bit hard to see it on this white on black here. So let's change it to something like pressure. And here you can see the gradient much more obviously. If I go to precipitation, same thing. Temperature, this one's probably the best looking gradient in my opinion, but this is essentially what it will look like. The very last thing is just to get the values at the very bottom here underneath this gradient div. For the sake of simplicity, we'll just use the first and last values. So underneath the gradient here, for example, for precipitation, we would just show 0 on the far left side and then 140 on the far right side. To do that, all we have to do is make a new div here. Let's give it a class name of flex, justify between to space them out between the left and the right sides. And then for the text of these, let's just make it text SS. We want it to be pretty small. And then we'll say text foreground. Same thing. If it's against a black background, the text right here will be this white foreground color. And inside of here, for both our first and our last, we'll make each one a span. So we'll say span for the first one, span for the last one. First one is obviously just going to be data.stops at 0. That's the very first one. And we'll get that value. And then the other one will just be a very similar thing, but we'll get the very last one. So it's data at data.stops.length -1. And now this span should have the very first value, and this span should have the very last value. And after each one, we'll just also have another expression here that just does data.unit separated by a space here. We'll add that to both of these. Oops. Add that to both. And if we go ahead and save it here, now we have the units on the legend. So we can see the far left is -65 and the far right is 30. And now our legend is good to go. We're completely done with this component. A little bit of calculation up here, a little bit of styling, but nothing too bad. And now we got a nice looking legend that applies to each different map type that we can use, not only to make our map look a little cooler, but also to make it make a bit more sense. Now that we have this nice looking map and the nice looking layers for the different map types, and we have the map legend, let's finally put this map away for a second. I think we're done working on it for now. Let's move on to something else. I think at this point in the video and at this point in the app building process, the next thing we should probably take care of is the skeleton loaders. Right now, when we go to anywhere on a map and we just click, notice how the data kind of sits at what it is already before it just flashes to the new data. So if I'm, somewhere in India and I go and click somewhere in Saudi Arabia here, the data stays still for a second and then just shifts. There's not really any sort of visual indication that we're fetching new data. If you're not familiar with what a skeleton loader is, they're basically just some indication that your data is loading or fetching from some API or backend instead of using a loading spinner. If I go to the Shadcn documentation here, they actually have a skeleton component and it looks something like this. And I'm sure you've seen this before on other websites. This dimming and flashing behavior that we're seeing is what we actually call the skeleton loader. And it should generally match the shape that your data will be in, and it looks way cleaner than doing a loading spinner. Because if, for example, on our app, we went somewhere here, and we clicked on some area of the map, and then we had a loading spinner on each card, and then the data suddenly flashed in, that still doesn't look very clean. However, having skeleton loaders and transitioning from a skeleton loader to the actual data should look way smoother. With that being said, there's a reason why in all of our cards on the dashboard, like for example, the current weather, hourly forecast, whenever, I made these all suspense queries instead of regular use queries. If you have a component that uses use suspense query, you can wrap that entire component in the built-in suspense component in React, which will allow you to have a fallback component, meaning the component that is rendered while we're waiting on the data to fetch. If we do our skeleton loaders the correct way, our skeleton components would be our fallback, and then once the data is loaded in, it uses the actual component. What this means is that the skeleton component should effectively match exactly the actual component in terms of shape and the way it looks. But wherever there should be information, we would just have that pulse animation going to show that it is loading, like how we have here. For example, if we go to our current weather card, the skeleton loader for this card would probably still say current weather here, but where we actually have text for the actual card like this that comes from the API, we would replace it with a skeleton loader until the data is actually there. The easiest way to do this, in my opinion, without completely muddying the components that we already have, would be to create brand new skeleton components that mimic the real ones in the way that I just mentioned. So we'll go inside of our file explorer here, and inside of components, I'm going to make a new folder that I would just call skeletons. And then in here, we want to make a component for each card. So for example, for the current weather, we'll make a new component that we'll just call it current skeleton.tsx, just like this. And we'll do the same for the daily forecast, the hourly forecast, and the additional info. So I'll go ahead and make those. We'll say this one is hourly skeleton.tsx. This one is daily skeleton.tsx. And then this one will be additional info skeleton.tsx. And then for each of these, we're just going to run tsrfc to get the base component out. Do that for all 4 of these. And what we'll do here is actually pretty simple. So for each of these cards, how we're going to make the skeleton is we're going to go into whatever card you want to make. So we'll start with the current weather. So we'll go current weather card. And we basically want to take literally all of this JSX exactly, because we want these components to look pretty much the same. We're going to take it exactly, copy it, and we're going to paste that in here to our skeleton. We'll make sure to import the card and then also the weather icon. And now we should have an exact copy of the current weather. However, we know that in the skeleton, we're not going to have access to this data yet. So what we're going to do to create these skeleton loaders is everywhere in this component now where we see data, we're going to replace that with a skeleton loader. For the skeleton loader, just like the dropdown, we're going to get that component from Shadcn instead of having to write our own custom version. So it'll be this component exactly. So to add it to our project, we can run this command right here, same as the select. We'll take it, go ahead and add it to our terminal here. And now, once this runs, we should, now if we close this, look in our file explorer in the UI folder, now we have this skeleton.tsx component. So we can use that in each of our skeleton loaders. Now we'll use this component and go through every single spot in this component that has data and replace it with a skeleton loader. So for example, this first header 2, we're going to replace this, just delete it, and replace it with a skeleton component. And we'll want to make sure that it's an accurate size as to what our temperature text would be normally. So we'll try adding a class name on it, and let's throw width 50, height 4 on here. And we'll just rinse and repeat this for each thing that has data. So for example, this weather icon also has data. So let's take this, let's copy and replace the weather icon here. The weather icon was already hard coded to be size 14. So we'll say size 14 for this. And then we'll also give it rounded full to make it appear circular. This header 3 also consumes data. So let's replace this with a skeleton. We'll make this one slightly smaller in width than the top one. We'll do with 30 here instead of 50. We'll take this skeleton right here, we'll replace this H3 with that, and then we'll do the same for each of our P tags down here. We'll just replace all of them as such. And now we're not consuming data anymore in this component. Everywhere where we had data, we replaced it with a skeleton loader. Now what we'll do so we can see this is go back to our app over here. Let's go ahead and save this file. And now we'll go back to app. And before we wrap this in a Suspense and get the actual fallback stuff working correctly, let's render them out side by side just so we can see a visual comparison. And you can kind of get an idea of what I'm doing. So I'm going to render it out right under here. We're just going to call it current skeleton like this. And again, it's a dumb component. It doesn't need any sort of data. So if we go ahead and save this now and look down, this is roughly what our skeleton loader would look like. And if you notice, looking between the two of them, that this actual weather card that has the real information looks to be a bit taller than the skeleton card just because some of the stuff that's filled in just appears to be bigger. So let's actually go through each of these fields here and get the correct height and width so that we can go into our skeleton and adjust the width and height of each one. We can do that super easily if we just go into our DevTools here. Let's inspect and let's look through each thing here. So no matter what, even if we're kind of shrunk down like this, they should all still be the same width and height. So let's look at, for example, this header 2. It says that it's about 120 pixels in width and about 60 pixels in height. So the general rule of thumb with setting up widths and height in Tailwind is that if we take any sort of given pixel size, like 60, we can divide it by 4, and that's whatever the actual number should be for here. We want this to be 60 pixels tall. So for our skeleton, we would say height 15 because we divide by 4. For the width, it's about, let's just say it's 120. So 120 divided by 4 is 30. So we can say width 30. And then we'll just go through real quick and do this for each one. So it looks like that's fine. We know the weather icon is the correct size. For the scattered clouds here, looks like we have 28. So divided by 4 is 7. So we'll say this is height 7. And the width here is 150. So we'll say that's roughly something like 36. Now if we go ahead and save this, these should look a bit more accurate to what the actual size of them should be. If we go down and look at where the time is, let's open this up. You can see that the time here is about 150 in width and 40 in height. So that means we can give that a height of 10. And we said, what was the width there? 150. We'll do the same thing. We'll say width 36 there. Get that looking a bit more accurate. And now these look way closer in their actual size. The last thing would be these few fields down here at the bottom. So let's look at these real quick. We can see that each of these ones has 24 pixels in height, which that means 24 divided by 4 is 6. So each of these should be height 6. So we'll adjust all those to be 6 there. And then each of these will not make super wide. Let's just say We'll say 64 for them, makes it kind of easy. So we'll say width 16 for all these. And now I think this should be good to go. If we go ahead and save it, close this now our skeleton card approximates the actual card much closer. In fact, if we look in our dev tools and hover over this actual card here, it says that the height of it is 420. If we hover over this card, it is also 420, so they're the exact same height, so I think we've got these sizes looking perfect. Now that we know this looks good, what we can do is we can go back to our app here, and instead of rendering out current skeleton like this, obviously we don't want to actually do this for the real thing. Let's get rid of this. And the way we do this is because current weather uses a suspense query, what we can actually do is highlight this whole thing, Control-Shift-P wrap. We're going to wrap this in a suspense component, and suspense is a component that is built in React. What this suspense component allows us to do is give it a prop called fallback, and what it means is that while this query is in flight, so whatever is using the suspense query, while it's in flight, meaning we don't have the data yet, we'll render whatever component we put inside fallback. So we can say for this one, we will just render out current skeleton. Essentially meaning while this useSuspense query is running, we're gonna render current skeleton. Once it's done running, we'll render the actual current weather card. If you're not super familiar with this suspense paradigm, that's understandable. I didn't start using it until more recently, but I think it is a really nice way of avoiding loading spinners without having to do like an is loading or is fetching state, and simply relying on the suspense query built in from TanStack. It makes it really convenient to do. Because without using suspense, what you'd probably have to do if you had your query inside of it like this, is you would go in here, you would pull out something like is pending or is loading or whatever, and then in your JSX, you would conditionally say, okay, if we're pending or loading or whatever, then render a loading spinner, otherwise render the actual content. And that's fine, that works, but I do just think this suspense paradigm is pretty neat. It's a nice way of avoiding that, and it makes the code cleaner. So we'll go ahead and now save this file. And now one thing you're gonna notice is that whenever I go somewhere on our page, like let's say I jump around on over here, notice how we still don't render out the skeleton yet. It's still just having the current weather, and then it's flashing to the new card. The reason for that is because each of these cards that we're using right now, like the current weather, hourly forecast, etc., are all subscribed to the exact same query. And if one of them is wrapped in a suspense, but the others aren't, this suspense boundary is actually never going to trigger, because it'll see the other ones that already have a query, and it uses their cache data instead. So basically, before this is able to work like this, we actually need all of these cards to also be wrapped in suspense. So it's an all or nothing kind of thing, at least in this particular use case. What I can do to at least show you this though, is if I wrap all of these components in a suspense as well, like we have for the current weather. Let's go here, wrap all of these. Say wrap, suspense, and then do the exact same here. Obviously, these ones right now need their own skeleton fallback, but for right now, let's just all render the exact same card, just so I can kind of show you what I'm talking about here. But if I now go ahead and save this, let's just refresh the page here, and I now go somewhere, notice how now it goes to the skeleton loaders. If I kind of scroll down here so I can make you see this more, click somewhere on the map, boom, that's what it would look like. So each time the query is in flight, it would go to the skeleton loader. Once it's done, it would load the actual card. Now, obviously, this looks kind of bad right now because they're all using the exact same skeleton loader, and they shouldn't be, but I think you get the idea. We have data on the page, then we click somewhere on the map to trigger a query again. While it's in flight, we render the skeleton loader. Once the data's in, we render the actual card. Skeleton loaders are becoming more and more common in apps I've seen recently, instead of just displaying a loading spinner. And in my opinion, they look really clean if they're done properly. The reason I made sure the skeleton loaders are the exact same size and layout and everything in the current weather card is because I think the instance where skeleton loaders don't look all that good is if the sizes are way off. If the sizes are way off between the actual card and the skeleton card, then every time I go and query for something, you're going to see a weird readjusting of sizes and a weird flickering on the page, which makes it look way less smooth. That's why it's important, if you're going to use skeleton loaders, you need to make sure that your sizes for your skeleton components are all pretty similar to what the real thing is going to be. That way it's just a better UI experience. Now that we have the proper skeleton loader for the current weather card, let's do the exact same thing, but for the other cards. So we'll go ahead and close out of current weather and current skeleton, and we'll follow the exact same process. So let's go into daily forecast here. We have all this JSX here that we're going to copy exactly. We're going to go into our daily skeleton, and we'll paste this in here, making sure to import card, and we'll import weather icon. And again, same thing in this component. We don't have access to data because it's a dumb skeleton component. So instead of mapping over data.daily, what we can actually do is we can map over an array of fixed length. The way I typically do that is by saying array.from. You can write object like this and say length, however long you want. We know it's an 8-day forecast, so we'll say length 8. And we're not going to have access to this day here. Obviously, it's going to be of type unknown here, so we can just completely get rid of it. We're not going to need that. And now, essentially everywhere where we use day, we're going to replace with a skeleton loader. So let's go back to our current skeleton real quick. Let's take this skeleton right here. We'll go ahead and just copy it. And let's paste it into the code here. We see that this p tag is already hard-coded to width 9, so we know that's easy to use. We can get the skeleton here, hard-code this one to width 9. And then if we go ahead and go to our dev tools here, and we look at each of these items here to see kind of how tall and wide each of them are, this one is height 32, so divided by 4, that gives us 8, so we can say it's width 9 and height 8. The weather icon is also hard-coded to size 8, so we can replace this with a skeleton as well. Just give this one size 8, rounded full to make it appear to be a complete circle. And then if we look at our remaining 3 p tags down here, let's go here, inspect this, look at it, and these widths are going to vary slightly depending on what we have in here. But it looks like all of them are going to be also 32 pixels. So that's 32 divided by 8, or sorry, 32 divided by 4, which is 8. So these are all going to be skeletons with height 8. So let's actually just replace all these. Height 8, replace this here. And oops. And we will also replace both of these. Again, each of these has a slightly variable width, but it does look like for each of them, the width is around 32 pixels. So we'll say the same thing for each of these. So instead of saying a separate width and height, we'll just hard code size 8 for each one of these things. So we'll do that for each one of these, what were p tags before. And the last thing to fix is we still need a key because we're mapping over something. We don't have day anymore. So let's actually just get the index out of here. So we'll just get the index just like this. And we'll make the key be the index. Normally, I'd advise against using index as keys in React. It's kind of a frowned upon thing. But if you're mapping over an array of fixed length like this, and you don't have any sort of ID to use, then index should be fine. And honestly, that's it. This component was super simple. So now if we go ahead and save this, let's go back to our app, and we can replace the fallback here of current skeleton, which is just a placeholder, with daily skeleton. Now for our daily forecast, while we're loading, we'll be rendering out the daily skeleton instead. What I'll do real quick just to show you how this looks, because it's a bit hard since it's kind of at the bottom here. I'm actually going to move this up a little bit, move it up directly below our map. So if we go in here, click on somewhere, boom, you can see, it loads in pretty quick, so it doesn't last very long. But whenever we click somewhere, it loads, flashes in. It's the exact same size, so there's no weird layout shifting, which is exactly what we want. So now let's go ahead and move this back down below the hourly forecast, and let's move on to the next card. We'll take care of the hourly forecast. So we'll do the exact same process we've been doing. Close out of these. Let's close out of this. Actually, we'll keep it open for now. Let's go into hourly forecast. Take this JSX exactly. Again, same process. Just gotta do it a few more times. Go here, replace it. We will get our card here. And now we'll just go through again, same exact thing. Anywhere that consumes data, we want to replace it with a skeleton loader. We know for this data to hourly, we don't have it. So let's do the same thing we did as the daily skeleton of mapping over an array of fixed length. So we'll say array from, it'll be length. We know this is a 48-hour forecast, so it'll be length 48. And we'll do the same thing here, where we will say, we'll get the index out. And then for each thing, we'll make sure that's the index there. And actually, I'm realizing because of this, this doesn't actually have a key on it, but it should. Don't forget that. This should just be, yeah, we can use this here. Say hour.dt. That's a little bit of an oopsies. Should have had that earlier. Okay, but now that we have this hourly skeleton, let's get this fleshed out. We know the weather icons are always size 8 by default, so let's render out a skeleton here from our UI folder. And just, oops, give this one a class name of size 8. And then we'll replace this p tag and this p tag. If we look at our dev tools here, open up this to get these sizes correct. Looks like they are height 24. The width's going to be a bit variable again. Let's just assume that's 60. So we'll say it's a width 15. And then we'll say the height is 24. So divide that by 4, and that is 6. So we'll say width 15, height 6 for each of these. We'll take this. This will be width 15 and h6. And then for the temperatures down here, looks like it's going to be roughly 32 pixels in width and 24 in height. So that would mean 32 in width, that would be a width of 8. And then what I say for the height there. See, the height is 24, so yeah, that is a height of 6. And now this card is done. As you can see, kind of getting the hang of it, it's not too bad to create these skeleton components. Again, you pretty much just want the exact same JSX as the actual card itself, or the actual element itself that you're mimicking with the fallback, and then just make sure you calculate the sizes correctly. Now that we have this hourly skeleton, let's again go back to app here. We can replace current skeleton with hourly skeleton. Oops. And now we should have just one more card left, the additional info card. So let's get this last one knocked out of the way. If I open up additional info, we're going to take the JSX, exact same thing as before, and we'll make a, actually we already have the component. We'll go here, we'll paste it in, making sure to import. And same thing, we want to map over an array of fixed length. If we look at our additional info card, we have, 6 fields. So we'll say array.from, and this is going to be length 6. We're not mapping over anything, so we can't really destructure anything, but we will get the index out of here just to make React happy. So we'll say he is the index, place this here. And now anywhere where we have some data, we're going to replace it with the skeletons, same as the other 3 cards. Well, we can see this icon here is clearly going to be size 8, and we know it's going to be circular. So let's go ahead and just replace this with a skeleton that is size 8 and also rounded full. If we open up our dev tools to see how big the label is for each one of these, obviously, again, like the other text fields, the width's going to be kind of variable, but the height should remain the same. So it looks like in this case, the height is going to be 32 pixels, which means it is H8 in Tailwind. So we will replace this span here with another skeleton. And we will say class name is going to be H8. And then for each of these, let's just decide on a width that's maybe kind of the average of all of them. It looks like, so this one's like 103. The next one here is going to be shorter, so 64. Let's see, what's this one here? 105. Okay, let's just say, I don't know, let's say it's 80 pixels on average. So for these, it's 80 divided by 4 is 20. So we can say with 20, and that'll be for our label. And then lastly, this format component that we have down here is just for the right side of each of our things here, which again, we'll just say for each of these is also a height 32. So let's replace this, another skeleton. This is going to be height 8, which is already 32 pixels, so we're good. And then for the width here, let's see. The width on these is much shorter. Let's just say this is also 32 pixels. So we'll say size 8 for it, just like this. And now this component should be good. And now that we have this, let's go ahead and close out of our DevTools. Let's go back to app. And now we should have a skeleton card for every single card on our dashboard. We'll replace this with the additional info skeleton. And now they're all unique and all ready to go. 4 separate cards, each with their own unique data and unique skeleton loaders. That should look pretty much identical with some pulsing loader blocks. Let's test it. So we can look at these top 2. We have the current weather and the hourly forecast. If I go click somewhere on our map, you can see that it does exactly what we want it to. If I go somewhere here, it flashes for a second with the pulsating animation, and then cuts to the real data. And this is exactly what we want. Just so we can see the daily forecast and the additional weather info, let's actually move both of these up in the DOM just so we can see it a bit easier. Go ahead and save it, scroll up here, and the same thing applies for these cards. Whenever I click somewhere, they go to their skeleton variant, and then go back to being the actual data once the data is loaded in. Super, super cool. So now we'll go ahead and move these back down to where they were. And I think it's safe to say we did a pretty good job with these skeleton loaders, and it looks like they're all working the way that we want them to. Here in just a bit, we're going to do responsive design, so we'll be able to see all this stuff at once and not, just have this ugly looking single column. But for right now, these appear to be all working exactly the way that we want them to. One final thing to add to these skeleton loaders that I think would make these look super, super clean is if once the suspense finishes, the actual cards just fade in instead of just appearing there. It doesn't look super bad right now, but it's a little harsh whenever we go from the card to the skeleton loader, it kind of just flashes in. But one thing that I think looks really clean, especially with skeleton loaders, is if the information, once it's loaded, kind of just fades in. There's no built-in fade animation in Tailwind to my knowledge, so something I can do super quickly is just create a super basic fade in animation in our index.css file. So if we go over to it here, what we can do is we can just scroll to the very bottom of the file and let's define an animation. We will say at keyframes, normally how you make animations in Tailwind, and we'll say fade in. Simple animation name. All we have to do is just say something like from opacity 0 to opacity 1, and it's really that simple. We're just defining a super simple animation where we go from being opacity 0, so invisible, to opacity 1, which is visible. So we'll go ahead and save this, and now we can add this to each of our cards. So because our skeleton loaders and our actual cards use this shared card component, we can just add it in here. Now, one thing I want to be careful of is I don't want the entire card to fade in. So I don't want this outer div to be the one that fades. I think that would be a bit too over the top if we had, let's say, data on the page, and then we click somewhere to get the skeleton loader, and the data loads in, and then the entire card just fades back in. I think that would look really clunky. So ideally, instead, we have this div be the one that fades in. So the whole card still stays on the page, but just the content of the card fades in slowly. So essentially, I want to add this animate fade in to this class name. The simple way we can do this while still maintaining this children class name in here and not messing that up is to actually just wrap this whole thing here in a CLSX. And that way we can add more stuff to it. So we'll say CLSX, import it from here. We'll say comma after children class name, so we still include it. And then what we can do is we can say animate. This IntelliSense is kind of annoying. We'll say animate, and then we'll do brackets for an arbitrary, and we'll just do this in line. We will say fade dash in, because that's the name of our animation right here, as we defined it in index.css. And then we want to separate these out by underscores, because you can't have spaces in an arbitrary. In CSS, you can have spaces, but in an arbitrary, you can't add spaces like this. So you usually use underscores to separate them out. So we'll say 0.6 seconds, another underscore, ease out forwards. I was testing earlier and I think 1 second's a bit too long, so that's why I'm doing 0.6, and then this will just make it ease out. But essentially this just compiles to this CSS class right here. So it's nothing crazy, it's just inline inside of an arbitrary. Now if we go ahead and save this, and we go to our page to test, click on here, these cards should fade in. Let's refresh the page here. It looks like they're not quite, so we need to fix something. Let's actually test to make sure it's not happening too fast. Let's set this to like 5 seconds, just so it's super obvious. Go here, and yeah, it's definitely not fading in. I think I may have mistyped this on accident. I think this should be an underscore, because these should be two separate things. So we go ease out and then forwards. Let's actually save this now, and there we go. The fade's working in. So as you can see, this is like obviously super slow because we have this 5 seconds. Let's change it back to 0.6 seconds. Go ahead and save this now, refresh this page. And now when we click somewhere, I think this fade in looks a lot cleaner than having the data just kind of flash there. We could draw it out a bit longer. I mean, if we did 1 second, I take it back. I don't think it looks that bad. I think having 1 second actually looks a bit cleaner than having the 0.6 seconds. So let's go ahead and keep this. But yeah, you get the gist here. Essentially with these, if I want to go anywhere on the map, click somewhere, skeleton loaders come in, fade out, fade in, and it looks way less harsh and quite a bit smoother. Before we get to the responsive design part of our app and getting the light mode and dark mode toggle set up, the last major piece of functionality would be adding a side panel here on the right side where we can display some additional information about wherever in the world that we are. The free tier of OpenWeather only comes with so much stuff, and one of the other free APIs we could use without paying anything is the air pollution API. So I thought it would be cool if we could use this API to fill up a side panel for our app. Because we just have this one-page dashboard-like view, I think having a side panel would make the UI look really nice and clean. If we go back to the API for the air pollution and go to the API documentation, you can see that we have a couple of different types of air pollution. So different pollutants that we have, and they each have their own respective value ranges. An easy way to fill out a side panel for our app would be to have a card for each one of these pollutants. So a card for SO2, one for NO2, one for PM10, and you get the idea. And then maybe for each card, we could have some sort of slider in it to show how low or high the value is. And then something saying whether it's in the good range, fair range, moderate range, and so forth. If we're going to use a slider to show how good or bad the pollutant is, we can actually use a slider component from Shadcn. So if we go back to their components here, they do have a slider, I believe it is right here, that just looks something like this, that I think could be a nice little visual indicator of where the pollutant is and how it falls on the spectrum of being, good, moderate, whatever. So without wasting any more time, let's get started on this side panel. The first question is, how do we functionally make a side panel in an app like this? Well, typically at large enough screen sizes, the dashboard and the side panel would both be visible at the same time. But with all side panels, at some point, at small enough screen sizes, we need to make it collapse, and when the user optionally opens it up, it opens over the dashboard content. And that's because if we're on a small screen size, we can't just cram the dashboard and the side panel together because we won't have enough room to work with. For now, let's just start working on the side panel under the assumption that it'll be displaying over the dashboard content, just so it's easy for us to see as we develop it. So if we go to our File Explorer, go back to our components folder that we've been using this whole time, let's make a new file in here. I'm going to call it sidepanel.tsx, tsrfc to make the component, and we'll get this component made. Now let's think about how a side panel should be styled. Side panels are usually pretty similar to headers in that they need to be positioned absolutely. Most of the time, whether it's a header or a side panel, they are positioned either fixed or sticky or something like that. For this particular side panel, we want it to always be in the same spot in the screen no matter what, so let's make it fixed. So let's throw a class name on this div here. We will say fixed top 0 to make it align to the top of the screen, right 0 to make it align to the right side of the screen, and we'll also give it height screen to make sure it takes up 100% of the viewport. And we're going to change this, but for now, let's just set it to with 50 by default. And also to make it stand out a little bit, shadow MD. In terms of how we want the side panel to stand out from the dashboard, we don't want it to be the exact same color. However, one thing you will notice is if we go into our index CSS, one of the variables that Shadcn actually made was this sidebar color right here. So we can actually just use that. So for the background for the side panel, we will just say BG sidebar. Now that we have these few things, let's quickly just save this. And I'm going to go into our app and we'll actually render it out in here. Let's actually wrap everything we have so far. I'll wrap it in a div and then just remove div to make it a fragment. So this way, all this code right here is going to be our dashboard. But then in that same component, so in our uppermost app here, we're just going to render out side panel just like this. Go ahead and save it. You should see this side panel does now pop up and it overlays a lot of our content. Like I said before, for some reason the map we have has a bunch of z-index stuff set in there that's around z1000. So let's actually just go into our side panel here and just hijack that and say z1001. That way it goes over both the legend and the map itself. And instead of doing with 50, let's actually up this to, I don't know, let's say with 80. Now that we have this outer div set up, what should be inside of here? Well, just like the rest of the cards that we have on the dashboard, I actually want to wrap this whole side panel in a suspense because I think it would look good to have skeleton loaders for these little side panel cards that we're going to make as well. So what we'll do in our side panel, if we're following that exact same pattern, we will just have suspense like this, imported from React, and we'll get the side panel content set up inside of here, and we'll set up our fallback once we get there. And the reason I'm putting this suspense in here and not, for example, at this level, with the side panel right here is because I don't want the entire side panel to disappear. I just want the inner content of it to be suspended. So that's why I'm moving it in here and not on the outside like the others are. However, to take advantage of the suspense in here, we'll still need to have our suspense query in a component that's inside of these. So what we'll do here is make another function. We'll just call this air pollution. And this will be kind of the component that actually renders the content of the side panel, which we can just render up here just like this. Now in this component, here comes the query part. We've got the suspense already wrapped around this component, and we want to take advantage of that by calling a useSuspense query inside of air pollution, where we can actually get the air pollution data. However, we don't have a function for that yet, so let's go ahead and set that up. If we take a look back at our api.ts file, we already have a function for the weather data, and we already have a function for the geocoding. Let's make one last function in here to get the information for the air pollution. So what I'll do is just like the rest of them, I'll just copy this to make it a little easier. Write this. Instead of calling this get geocode, we're going to say, get air pollution. And it'll actually take an identical arguments to get weather. We'll want latitude and longitude. And I'll show you that in just a second in terms of why we're doing that. Let's do it like this. And the reason we're letting it take in latitude and longitude, just like get weather, is because if we go back here and we look at the air pollution API, we can scroll down to where it gives us the link, how we can actually fetch this information. And as you can see, just like the weather one, all it takes in is latitude, longitude, and an API key. We already have all the logic on our page to get the latitude and longitude coordinates of wherever we click on the map or select from the dropdown. Since we already have that, this will be super easy. We can just pass it through to this get air pollution function. So what we'll do is, just like the other ones, we'll take this link right here, and instead of calling the weather link in here, we will just call this link instead for air pollution. Much like the others, we'll replace this with API key and this $sign here for the expression. And then, just like the other ones, we'll want to pass through latitude and longitude into this expression. And now this should be good to go. And of course, for the geocoding and for the weather, we have our own unique schemas. So let's now generate one for the air pollution. If we look here, scroll down, it should give us an example of the response object. So it's just these couple of fields here. We have just the coordinates, and then we have a list that has a bunch of the information about the air pollution components. Just like the exact same way I did with the other two, I'm going to plug this response into ChatGPT and ask it to generate me a Zod schema. Let's go ahead and in our schemas folder, we'll make our last and final schema. And we would just call it air pollution schema. We'll make a lowercase, air pollution schema.ts. And we'll go ahead and paste in exactly what ChatGPT generated for me, which is this right here. Making sure, of course, to import Z. Actually, just to make sure, we'll just do the import like this, just so we get it from Zod. And now we have a schema for our air pollution. Said it before and I'll say it again. ChatGPT, or AI in general, is really good at generating schemas like this. So if you want to save time and save a lot of monotonous stuff of just copying stuff over, this is something that I definitely think you could use LLMs for. Now that we have this, all we have to do is go back to our API-TS file. And instead of parsing through any other schema, we'll just parse through air pollution schema. And now everything should be fine and dandy. If we save this file, now we have a perfectly fine query function to call that will get us the air pollution information at any given coordinates. Now that we have this, let's go back to our side panel here and construct our suspense query. So we'll say const data equals use suspense query, just like this. And then for here, we'll need, again, a query key and a query function. For the query key, let's just say pollution for right now. And then for the query function, we're just going to make this a function we just wrote, which is get air pollution, making sure to pass in the latitude and longitude. So we'll say like this, get air pollution. And here we need to pass those coordinates in. And ideally we pass them into both the query key and the query function. Well, luckily we already have the coordinates in the parent of the side panel, which is app here. So the exact same way we're passing it down to our children components, we can pass it down to the side panel. So let's give it the exact same props actually. We'll pass coordinates down just like this. We'll save it and we'll make sure now that side panel actually expects to have coordinates. So we'll get chords out of here. And we will say chords is going to be of type chords. And we'll have to get coordinates from this component down to the air pollution. Now we could just pass down chords like this, and that'll be perfectly fine. However, one thing that I typically like to do is if I'm drilling it down through two layers and I'm not actually using the coordinates in this component, I usually actually don't destructure it. What I will do instead normally is just call props like this, and then I will just spread it down. That way it spreads all the exact same props down. So if we decide to add more in the future, we don't have to be explicit about it. The way you do that is just by curly brackets and you do ... props. And now this air pollution component will have access to all of the same props that side panel does. We'll just have to make sure they share the exact same prop type. So let's make sure this is expecting props. And for this one, we actually will destructure the latitude and longitude out of the coordinates. And actually, my bad, we can't do that. That should be coordinates we're destructuring, not latitude and longitude. And now that we have this in this component, what we can do, we can just say chords, just like this, and then get air pollution is expecting an argument that is just an object of latitude, longitude, which is the exact shape of chords. So we can just pass in chords like this and make sure we import this function. And of course, as always, when using TanStack query with Zod, now if we hover over data, it'll give us the exact type that we need from this air pollution API, which should match the exact type over here. So now we know that TypeScript has context on what we can and can't use. The next question is, how do we actually want to use this data? Well, one of the most important numbers that we get here is this AQI number, which is just the air quality index. And at least from this API, this particular number is the most generic and most applicable number, I guess, for air pollution that we can use in our side panel. So I think it would make sense to put this particular number in some big, bold font. That way it's very easy to see. And then after we do that, what we could do is then map over components. If we look at components here, of course, components is just an object for each one. But essentially what we could do is we could just map over each component like CO, NO, NO2. And for each component, make one of those little cards I was talking about earlier that would just show the information for that particular component. And when I say components in this context, I'm referring to, of course, air pollution components, not React components. So let's go ahead and start setting up that styling. So, of course, it's a React component, so we need to return some JSX. Let's first return this div here. And for this outermost div, I'm going to give it a class name of flex call, gap4, just to give it that vertical layout. And then, like I said, the first thing we'll do is do the AQI, the air quality index. So let's, because it's a header 1 here, let's give it a thing of text 5XL, and we'll say font semi-bold, so this should really stick out quite a bit. And then in here, we want to actually get the AQI number. Again, we can just look at this type here. You can see it's inside list, and then it is inside main, and then there's this AQI. However, this whole thing here, this list, is an array, technically, but like for other things that have returned an array, we're just going to be worried about the first item in the array, not all the other ones. So what we can do to access the AQI here is do essentially list.main.aqi, but the first index of list. So that'll just be data.list at index 0.main.aqi. And now that we have this, underneath this, let's map out each one of our components. And honestly, this is going to look a little bit ugly, but here's how we're going to do this. We are just going to say data, and then let's look back here to make sure we're getting the right thing. We know we need to get list.components and then get over each one of these. So what we'll do is we can say data.list, again at index 0.components, and here's where we can map over each component. So we'll say .map just like this. However, because components right here is actually an object and it's not an array, one thing we can usually do for that is to do object.entries. And we can actually wrap, if I can spell entries right, we can actually wrap this entire thing right here, everything before the map, in object.entries. That way we can basically loop over the object, and for each one, we can get the key and we can get the value. The way we do that inside the map is you just make this brackets array like this, and we can extract the key and the value out of here. And then for each one that we're mapping over, we're going to return a function, mostly because we'll have to put some logic in here. Let's specify a return here. And for now, we'll just make this just return a fragment. And actually, I lied. We're not going to do a fragment. For each one, we're going to render out one of our card components because I want these cards to match how the cards actually look on our dashboard, at least in terms of the color and like the rounding and whatnot. And then because we're doing a map, let's make sure we make React happy and we give each card a key. So for this one, we already have the key that we're getting out of here. That's just the key from the object. So we'll say key equals key. And one thing I'm realizing now is that if we're going to use our card, we're going to be missing the title from the card because right now, TypeScript expects an actual required title here to put in. However, these cards we're about to make are not going to actually have a title on them. So to silence that, we'll just make sure title is optional. It'll still be passed in, of course, for our dashboard cards, but not for our side panel cards. In terms of what to actually put inside these cards, I think the first thing that would make sense would be to be some indicator of what air pollution component that we're talking about. So for example, when we do this key and this value here, the key is going to give us, of course, the actual component name like CO, NO, NO2, and the value is going to be the number. So I think the first thing we should actually do is just display the key and the number separated with justify between. So what we can do is we can just make two spans. We'll have one for the key, and then we'll also have one for the value. So I'll say key in here, and then value in here. And then we'll go ahead and wrap both of these in a div. And we'll give this the class name of flex, justify between, put them on opposite sides of the card. In terms of the key and the value, we want both of them to be readable. Let's go ahead and give the key a class name of, let's say, text LG, font bold. And then for the value here, we'll do a similar thing, but instead of being bold, we'll make it semi-bold, just so it's slightly less apparent. Shouldn't have two bolds there. And then actually for the component name, I'm thinking because these are just lowercase, let's actually throw capitalize on your two to capitalize these. So we'll just throw capitalize like this. And now that we've done quite a bit with this, let's actually save it and see how it looks. It looks like we have a whole lot of nothing because it just crashed out the page. So let's actually refresh this. Maybe click somewhere else and see what happens. And it looks like we're still, I think, about to get an error here. Let's double check this real quick. We're probably going to get a network error. If I had to guess. It looks like we are getting the actual information back. Okay, yeah, so we're getting the information back fine. Let's see what this error is. Might be a Zod error. Oh, it is. Okay, so it's saying the coordinate expected tuple received object. So let's go back to our air pollution schema real quick, see if we can fix this. Go here, air pollution schema, and it's saying for coordinate, so it's expecting it to be of this shape here, this c.tuple of the number and number. I wonder if ChatGPT sold us out on this. Let's double check the network. And it looks like chord is just an object with longitude and latitude. So yeah, this is definitely not quite right. Makes me wonder if ChatGPT was wrong or if the docs are wrong. Looks like it is, oh yeah, it just says coordinates, so we didn't specify. Okay, so let's fix that real quick. What we can do to fix this is just replace this thing here. We'll say it's a z.object, and it's just gonna be lat, that is a z.number, and lon, which is also a z.number. And then we'll go ahead and save it, and that should fix it because this actually matches the format that we want. Let's go ahead and save that here. Refresh the page, and now you can see we actually have the cards showing up on our page. Now that we're seeing it for the first time, let's go back to our side panel real quick and adjust some of the stuff in here. So it has pretty much no padding on it. So let's do PY8 to create some separation between this AQI number and the top of the side panel. Let's also give PX4 just to give some more horizontal spacing. Go ahead and save that. And that makes quite a bit more room. I also want to make it even a bit wider, so instead of doing with 80, let's just go ahead and do with 90. And these two changes alone immediately make it look quite a bit sharper. Right now, there's no context to what this number here is doing. It's kind of just floating there. So let's actually make a label for it. So right above where we're doing this, let's actually copy this. And we're just going to paste in AQI just like this. And actually, let's make it say air pollution. And I want to have a separate label for AQI. In this particular air pollution title should not be quite as big as the AQI is. So let's make it text 2XL, just like this. So we can say air pollution. This is the AQI number of 2. But let's add a label for that. So let's put actually this exact same class name here. We'll take that and we'll put it right underneath AQI and just say AQI here. Now if we go ahead and save this, should have air pollution, the AQI number, followed by AQI. Now we should address the fact that these cards over here in the side panel are gonna be slightly different than the cards that we have on the dashboard. We're obviously wanting to share things like the rounding, the shadow, and the way it looks in general. However, because they're gonna look slightly different, I think what we should do in this case is allow the cards to take in an optional class name so we can pass in some conditional styling. So just like we're passing in this optional children class name, let's also add in class name as one of the props, which will just be an optional string in that same vein. So we'll say this class name here, and now it takes in both an optional children class name and class name. And of course, just like the way we're doing CLSX to get this children class name on here, let's do the exact same thing for the class name. So this whole class name here, let's wrap this whole thing in brackets. And then in here, we can now call CLSX, make sure this is all wrapped in CLSX, and we'll throw on class name, oops, not inside the quotes, throw on class name inside of here. That way, if we want to pass in a custom class name to our card, now it gets passed through to this outermost div. So let's go ahead and save it. And now if we head back to our side panel, now where we're rendering out our cards, we can add some custom styling. Just for the sake of adding a cool little hover effect to these cards, I'm going to give it a class name of hover. I'm going to say scale 105 so they grow slightly. And to make that hover smooth, we'll give it transition. We'll say transform. And then we will also say duration 300 to give an explicit duration. And now if we go ahead and save this, the cards over here on the dashboard don't do anything. But now if we hover over these cards, you can see with each mouse over, they just grow slightly. And it's a nice little smooth animation to make it look pretty clean. However, now we can't just ignore the fact that these cards are pretty much the exact same color as the background of the sidebar. I mean, they're actually really hard to see if you're not looking closely. The only thing that's really differentiating it is the shadow that we have around each card. Unfortunately, for whatever reason, I don't really know the logic behind this. If we go into index.css and look at the variables for whenever we are in dark mode that Shadcn made, we look at card here, it is this 021006 number. And if we actually go to BG sidebar, it's the exact same number. So I'm not sure why sidebar and card are the exact same because it makes it just a little bit awkward. So what we could do is we're passing in the custom class name for side panel. We can pass in our own custom color to make it stand out more. If we go into our card component in here, we're doing that gradient where we're doing from the card color to card color at 60% opacity. So let's do a similar thing in here. We're going to say from, And the question is, what color should we use? Well, there's another variable in here called sidebar accent that I think would be nice to use. It's a little bit different than the actual sidebar itself, so it would stand out way better. So let's say we want it to go from sidebar accent, and we'll do the same exact logic where we'll say to sidebar accent at 60% opacity. And if we go ahead and save this, now our cards appear a lot more visible than they were a second ago. It's nice when they're not the exact same color as their background. So we have a proper color, and now it's probably a bit easier to see that hover effect I was doing earlier. As you can see, just a nice little smooth animation here on some cards that look pretty clean. Okay, so right now these cards are super plain. All we're doing is writing the pollutant name right here and then the pollutant value. Firstly, this just isn't very visually appealing to only have this. But secondly, you really have no context to what this value actually means. Is 126.72 good? Is it bad? Is it all right? Who knows what this actually means? Obviously, we want it to be clear to the user that these numbers actually mean something. So let's now talk about this slider component that we mentioned using from Shadcn. I think this component here would work great. I want to disable being able to actually move this because there's really no point in doing that. But what I was thinking is for the slider, we could have on the left side of it some unit right here for, the low end. On the right side, it'd be a unit for the high end, and the slider would just show how either bad or good the pollutant is. I would imagine in most cases, if the pollutant is good, the slider is probably on the low end, and if the pollutant is really bad, like a really high number, then it's on the high end. Let's go ahead and get the slider added to our project. If we scroll down here, we can take the same command, the same way we've been installing our other components. Go ahead and copy it, open up our terminal, and we'll go ahead and add it to our app. Just like the other ones, it should add it to the components folder inside this UI folder here. So now we have this nice slider component. Now that we have this, underneath this div where we're doing our pollutant name and its value, let's actually just render out a slider. So I'll render out a slider like this, make sure to import it. Let's see what it looks like. It's a bit hard to see, so let's go ahead and go to this card here. Let's throw a children class name on it. Let's give it a vertical layout, so flex call. And we will make gap 3 on each of these just to create some separation between the div and the slider. I mentioned not wanting to allow the user to go and just readjust the slider like this because in the context of our app, it doesn't really make sense for the user to be able to change this. So what we can do is on our slider here, we can just throw disabled, which is a prop that should, if we save it, now disable it from actually doing anything. Also, it's kind of easy to see the actual slider when it's taking up color here. But the actual track behind the slider is, again, kind of just blending in with the background of the card. So let's go actually to that slider component real quick. And you can see that by default, we're going to have this BG muted on here for the track. Let's actually replace this with BG sidebar. And now if we save it, I think the track will look a bit nicer, being the same color as the sidebar. So it's still dark, it's not popping out, but it's also not the same color as the cards, which makes it easier to see. And I'm noticing too on these cards, we have this awkward little gap at the top that we shouldn't be having. And that most likely stems from the fact that even though the title prop is optional, we still in the class name here have a gap of 4 for the outer thing. So we're still creating a gap between the title and the children, even if there is no title. So what I'll actually do to get rid of this gap 4 here on only these particular side panel cards is we can go back to side panel and we can actually throw a gap 0 on here. And if we save it, it won't quite get rid of it because in this case, the gap 4 is going to win out over the gap 0. However, if I throw an important on it like this, it should actually, move it to the end, Tailwind v4 thing. Now, if I do that, it should get rid of that awkward space at the top. Okay, so now that we've fixed a few things, let's get back to our slider. Right now, it's cool having the slider, but the slider has no context to the actual value itself. Like this slider doesn't have anything to do with 126.72. It's only like that because I changed it before I disabled it. So if I really just refreshed, all these are starting at 0. So how do I actually pass this value into the slider? Well, the thing is, this slider, in order to work properly and look correct, needs a min prop and a max prop. The reason being is, let's say on a slider, I passed in 126.72, and let's say that's all I pass it into the slider, just that number. How does the slider have any context of knowing where on the slider that is, right? Should 162 be at the beginning here? Should it be kind of in the middle? Should it be at the end? Who knows? The only way it knows how to actually position itself is if we have a min and a max. So if the min is 0 and the max is 200, we know that 126 is somewhere kind of in the middle. But without a min and a max, it has no context to that. So for all of our pollutants here, if we look at these, there should be this chart here kind of telling us what each one is. And for all of these, 0 is actually the minimum. You can see it here in this good chart. So we can assume that for the slider, we can pass in min, and min is always going to be 0. Now, however, in terms of max, how do we know what the max one for each pollutant is? And I think if you've been watching long enough, you can probably guess exactly what I'm about to say. We need to use this chart here, but actually transcribing this chart into a data structure by hand is going to be a little bit tedious if we're being honest. So like many other things, I'm going to ask ChatGPT to generate me an object that represents this entire chart here. And here is what it actually generated. I'll just go ahead and paste this whole thing in. So it actually looks like quite a lot. And because it's a lot, I'm not just going to blindly trust it. Let's look through it for a second and make sure this all looks legit. I don't just want to be a certified vibe coder here. So it looks like it generated a few types here at the top. So we have the air quality level, which we can see from OpenWeather is good, fair, moderate, poor, and very poor. So this type looks to be good. Range, we'll just have a min and a max for each. Yep. And then we just have a pollutant type for each different pollutant on here. Seems legit. And then we have air quality ranges, which is just a record of records, which is this massive thing right here. All this object is essentially doing is mapping each pollutant to whatever ranges each keyword is. So like good, we know is this range, fair, we know is this range, and you get the picture. So this object actually looks quite a bit more complicated than it really is. It's not actually super crazy. If I want to know, for example, what is the moderate range for PM10, I would come to PM10, see moderate, and I'd say that it is between 50 and 100. If I want to know the very poor range for O3, I know that it is 180, and the max can be anything, just uncapped. So I think this AI generated data structure is actually going to do just fine. I know if I was doing this by hand, this would have taken me at least probably 10 minutes to make. So going back to our slider up here, we know that we need to set both a max and also a value. If we go ahead and hover value here, we can see that it expects an array of numbers. However, in our case, we only have one number, and that's just going to be the value from right here. We will just say value equals, and we'll make it an array of just one item, and that'll be value. Now the real tough question is, what do we do for our max? So for example, if we're looking at O3, how do we know what the max value is? Because knowing 78 is nice, but I don't know if 78's near the top or near the bottom or what that even means. So to figure out what the max is to get our ranges set up, all we have to do is go down here and look at each one of these objects. Luckily, all of these start from the lowest number meaning, I guess, the best air quality. And the higher the number is, the worse it gets. So because these are sorted by that, it makes our job a little bit easier. That would mean that the max value for each of these would essentially be the max value in all of these very poor categories. However, if we look, all of these have a max of null. And that is because technically, if we look at the OpenWeather documentation here, it actually mentions that these values are any number greater than these, meaning technically it could be infinitely high. That's why it's uncapped and it's just set to null like this. Because the max for these very poor categories are uncapped, what we'll actually use for the max is the min value of the worst quality. So essentially, the highest value could possibly go for any one of these given pollutants is the minimum value of very poor. So the maximum value for PM10 would be 200. The maximum value for PM2_5 would be 75, and you get the picture. So what we can do to actually get that, we can go back up to our JSX here, where we're getting the pollutant information. But before we return, let's go up here and we'll say const pollutant equals, we're going to access this object, air quality ranges, which is just this big thing down here. And we're going to say air quality ranges at key. What this will do is if we have a key that is, SO2, and we try and get air quality ranges at SO2, it will return this object. So that is what this will do. And I'm pretty sure that the keys we have right here are going to be lowercase, not uppercase. So let's actually do key dot to uppercase, just like this. And now TypeScript is going to get mad saying that this has any type because technically key can be any string, but this object here is specific strings. So if you're ever in a case where you know for a fact that these keys are going to be of the correct type, what you can do is you can just typecast it and you can say as key of type of air quality ranges like this, and that will silence the type error. It's safe to assume in this case that the pollutants that are actually being returned from OpenWeather are always going to match the exact same pollutants that it gives to us in the type here, because this air quality ranges was based off that response in the first place, so they should always match 1-to-1, which is why it's fine to typecast this like this. And then to get the max value for each pollutant, like I said, we're going to use the min value for the very poor category. So what we can do is we can say const max equals pollutant, and pollutant is of course going to be of the record that we saw. So we'll say pollutant at the very poor category dot min. So for example, if this pollutant gets set to, let's say, this NO2 object, and then we want to get the max here, we're just saying pollutant at very poor dot min. So we would get very poor dot min, which is 200. So we assume the max for NO2 is going to be 200. And that's just what this logic is doing right here. However, we have to acknowledge that there can be cases where the quality is very poor, and the value that we actually end up getting will be higher than the max. Because if, for example, we say the max is 200, what if our value is, 370 or something for NO2? Then technically max is not correct, because then the max is going to be under what it actually should be. So what we can do to actually fix this is where we're setting the max here, we'll assume this is still the default value. But what we can do is we can say math.max here. And we're going to take the maximum value between this value and the actual value itself. So if the value is 370, but the max is 200, then the real max technically is 370. That's what this line here will do. Now that we have this, we can plug it into our slider. So we'll just say max equals max. Now if we go back to our app here, go ahead and save it. And boom, now we have sliders that actually correspond to the real value in the correct ranges. This is for Tokyo. Let's go select, I don't know, London. And you can see now we have new sliders. If I go to Madrid, same thing, sliders are a bit different. And basically everywhere in the world that I go, they will all look a bit different, which is exactly what we want. I think right below these sliders, we should put in actual legends so we know what the real min and max are, just for the user to see. So below our slider here, let's make another div to make some sort of scale. And we'll go ahead and give this div a class name of flex justify between. And we'll make the text XS. And inside of here, we'll just put two p tags. We'll put the min and the max here. So the min's always going to be 0, and the max we'll just say is the max. So go ahead and save it. And now we have at least some sort of scale for each one. And now one thing I think we might run into in a second, because we're going to be adding more stuff to these side panel cards, is this side panel might need to scroll. We're already getting close to touching the bottom of the side panel. Let's go up to our outermost side panel div here. And let's just throw overflow y scroll on it, just in case. That way, if we do get to overflow, we can actually start scrolling it. The very last thing now that I want to add to each of these side panel cards is some sort of visual indicator of what range each value falls under. For example, right now on this card, 03 is 123.42. Is that good? Is that fair? Moderate? Very poor? We don't have that actual information yet. What we do, we're just not actually displaying it. So 123.42, if we look at the docs here, for 03 would fall in the moderate range. So in this example, we should display to the user that we're in the moderate range. Not just have the slider, because having the slider itself is cool, but I think having the actual string of saying what condition we're in would be even better as well on top of it. So underneath this slider, plus the labels that we have for the min and the max, let's just add some tags for each different range. And the one that is active will be highlighted. For example, we'll have all 5 ranges under each slider, from good, moderate, very poor, whatever. But if 03, for example, falls under moderate, only the moderate tag would be highlighted. Right under this div here, let's make one last one. We'll make a div here. We'll give it a class name of flex justify between to separate out each of these tags. And then in here, we want to map out each of the different range strings. What I mean by that is for each pollutant that we have the different ranges here. We have good, fair, moderate, poor, and very poor. So they are the keys of this pollutant object. To get that, we can access exactly that. We can say object.keys, and we're going to get the keys of the pollutant, which will give us the actual range names. And then for each one, we're going to map each quality to a span. And for the span here, we'll throw a couple of things on the class name. First, we'll say px2, py1. I want these to be kind of small, so they're not going to be taking a lot of space. We want to have a bit more horizontal spacing than we do vertical. We'll also throw rounded MD, text SS, and font medium. I'm doing most of these just to make sure these tags are pretty small so they can all 5 fit on the card. And then for each one of these spans here, what we want to display is just the quality. So if we save it now you'll see under each one, we have the 5 different qualities. Having this rounded medium on here doesn't really do anything when there's no sort of background color or borders, because we can't really, obviously, see any rounding or anything. So what I'll do around this whole span actually is, like our other things, I'll wrap it in a CLSX. And like I said before, I essentially want the tag that is active to be highlighted a color. The other ones are just going to be like a, a dullish gray color. So we'll say CLSX here. And then in here, we're going to say if the quality is equal to whatever the current level is, then we're just going to give it, I don't know, let's say BG yellow 500 just to see it being active. Otherwise, if it's not that, let's make it BG muted. So it's kind of like a disabled color. And then we'll also do text muted foreground just like this. So essentially, if our quality is the active one, just make each of these tags yellow. If it's not the active one, just make it this kind of gray dullish color and make the text muted foreground, which would be kind of a white color. But what is current level? I'm using this check right here, but this current level doesn't actually exist yet. We haven't written any logic to actually get the current range that we're in, so let's do that real quick. The way that we can do this isn't too complicated. Essentially in here, what we can do is we can just say, and actually, sorry, it wouldn't be in here, it'd be up higher. Let's go up here and let's say const current level. And the way that we're going to do this is we're going to write an immediately invoked function. So a nameless function here. We're just going to do parentheses, just like this. And then we're going to call it immediately. In here, all we really want to do is just loop through the different ranges and see if our value falls in them. So for example, let's say we're looking at NO2, for example, and our value is, I don't know, 110. What we're going to do to figure out what range we're actually in is we're just going to loop through each one. We're going to say, okay, good, 0 to 40. Does the, whatever number I just said, like 110, does 110 fall between 0 and 40? Nope, so let's go to the next. Is it 40 and 70? Nope, let's go to the next. Is it between 70 and 150? Yes, so we know we're in moderate. That's what we're going to do to get our current level here. So let's write a for loop in here. I'm just going to say for const level and range of object.entries pollutant. And for this, we're going to do something. All we're going to do is check to make sure we're within the bounds of that particular level. So we're going to say if the value that we have for this pollutant is greater than or equal to the minimum, and it's also less than or equal to the maximum, then we can just return, oops, not null, then we can return the level. So what this is doing is for NO2 example, the level would be NO2, and the range is going to be the 0 to 40 example for the first category. And all we're doing is checking, is our computed value actually within that range? If it is, we know we're in that range, so return that, because you want current level to be that level. It looks kind of complicated, but if you think about it for a second, it's nothing too crazy. It is the exact logic that I just explained to you step by step. However, we're going to get this type error on here saying that max is possibly null, which is true because if we look at our types here, max can be number or null because some of these are uncapped. So what we'll do in here, in this check where we're seeing if it is less than or equal to the max, we will just explicitly add a check in here and say is range.max equal to null for this, and that should silence that error. However, what this means is that if we hover over current level now, it'll say it can be string or undefined, and we don't want that. So let's say if for whatever reason we can't compute it, we're just going to default to very poor. So we're just going to do this. That way current level is always going to be a string. So we'll go ahead and save this. And now this should be our current level logic. What's cool is if you just notice, because we already hard coded the current level in here before we even had it, now if the quality is equal to current level, then it will highlight it. So CO is in good. So now this good tag is highlighted. O3 is in moderate. So moderate's highlighted, which is really cool because that's exactly what we want. However, this yellow is more of a placeholder color. I don't actually want each highlighted thing to be yellow because yellow for everything looks a little bit ugly and doesn't really, make a lot of sense. I think what would make more sense is if moderate was always yellow, but good could be green, and then very poor could be red. So real quick up here, let's make one last variable in addition to current level. Let's make some space here actually so we can have this format a little bit nicer. And then let's go up here. We will say const quality color, and we're going to do the exact same thing we actually did up here, where we use an immediately invoked function to write out some logic. So let's say const quality color equals this parentheses, make it a function, and then immediately invoke it. And then all we're going to do inside of here is we're just going to make a switch statement. We're going to say switch, and we're going to switch off whatever the current level is. So whether we're very poor, poor, moderate, whatever. And then inside of here, we'll just make some cases for each one to actually get the color. So we'll say case, if it is equal to good, then what we'll do, oops, to not be the syntax, case good, colon here. And then for good, let's just say, I don't know, BG green 500, which we will return that. So in that case, if we're on good, quality color can be BG green 500. And we'll do this actually for each one. So we'll actually going to copy this, paste it a couple of times here. This next one is going to be fair. This one will be moderate. This one will be poor. This one will be very poor. And then let's just make a default return case. So if we don't have any, for whatever reason, any current level, which, we should, but let's just say we don't, then we are going to return BG just gray 500, just something neutral. And actually, instead of that, we'll do zinc 500. And then in here, we'll go ahead and save this just to get some formatting. And let's change these colors around a little bit. We'll assume that if we are fair, we'll use yellow. If we are moderate, we'll, I don't know, we'll use orange because that's a bit more severe. We'll say poor is actually red. And then very poor is going to be purple, just like this. And now we have a color for each different level of quality. So what we can do is go down here, and instead of just hard coding in this BG yellow 500, what we can do is just instead just make it quality color like this. Now if we go ahead and save it, boom, they're all going to switch to their appropriate colors. So now the goods are green, moderates are oranges, and very poors are purple. And we of course have fair and poor. But now this at least gives some color association with each level. Let's click around this map a little bit just to experiment. So right now we are near, I think, Dubai here, which usually has some kind of rougher air pollution, at least for some of these numbers. If we go to, I don't know, somewhere in Romania, we can see here's the air pollution information there. I don't know, let's go Ireland. This looks like, let's do, I don't know, New York, set up here. Yeah, we can see for each different place we go to, we have some of our own unique information. That's whether it's a custom one, or, whether we go to unknown city, it will always have its own unique weather information. And the fact that we're able to get it like this is honestly pretty cool. This air pollution information isn't super essential, but it's some extra information just to take up on our dashboard. And honestly, I think it looks pretty clean having these little cards. Awesome. Now there's just a few finishing touches I want to put on this side panel before we're fully done with it. First, I think it would be great to add a tooltip next to each of these different pollutants describing what each of them actually means. For example, I have no idea what SO2 means or what the heck PM2_5 is. So having a tooltip next to these with a little descriptive field might be nice. Just like we've been doing for our other components, we can use Shadcn to help us get a tooltip. So if we go and look at the Shadcn components and we head to the tooltip component, you can see it just looks something like this. You have a little button or something and you hover over it and this tooltip appears. And I think this would work perfectly in our example. So let's go ahead and add this to our app. I'll go down here with the install command. And I think this might actually be the last Shadcn component we install. Cannot copy that. Let's get that in here. Go ahead and add it into our terminal. For some reason, copying weird still. So let's get rid of this. Go ahead and run it. And now we should have the Shadcn tooltip. And what we'll do is we'll take the exact code in this example here. We'll just take everything in this JSX and we'll go ahead and copy it. And then what we'll do is going back to our app here, let's add a tooltip first next to the AQI right here. Because if I didn't have any context to OpenWeather or I didn't know that it was already air quality index, I'd have no idea what this number actually means. So where we find our AQI here, which should be up here, let's scroll up a little bit. We have the AQI. Let's put the AQI and the tooltip in the same row. So let's actually wrap this here with a div, just like this. We're going to say class name is flex, item center, gap2. And here, right next to our AQI, we're going to add the tooltip. So we'll just go ahead and paste in the exact code that we copied from Shadcn. And let's go ahead and import each of these things. So we'll import the tooltip here. This should be from UI. Same with the tooltip trigger and also the tooltip content. Instead of this tooltip just saying add to library, obviously you want to have it say our own thing. So let's actually go down here and look at where it describes the AQI or the air quality index. It has this pretty simple description here saying what it is. So let's actually just take this verbatim here. Go ahead and copy it, and let's paste this into our code so it says that instead of the add to library. And then lastly, we need a valid trigger for our tooltip. In this example with the button, what it's using is a pre-built button component. And the trigger for the tooltip is essentially whatever you hover that actually activates the tooltip. So in this example, it is actually just a Shadcn button, but in our case, we're not going to need that. What I think would be cool in our app, which is what a lot of apps do for a tooltip, is to have a little information icon that you can hover over that will have the tooltip. I went on SVG repo real quick and just found this cool little information icon, so let's use this for our trigger. What we'll do is go into another one of our components where we import these SVGs as components. Like for example, let's do hourly forecast here. Actually, no, this is not a good example. Let's go to additional info. Let's take this import here. Same thing, we're just using svgr. So let's get this. Now we can go back into our side panel and let's import this at the top. We will say import, we'll call it information. And the SVG was just called information.svg. We're going to go ahead and use that. And now we can use this instead of this button for the trigger. So right here, we will just render out this information SVG and make it something pretty small. We'll just say class name is size 4. And now if we go ahead and save this, let's see what it looks like. Save it here. And also just so you can see it a little easier, I'll add invert to make sure it is white. Go ahead and save it again. And here you can see our tooltip. And if I hover over it, looks like nothing actually happens. So let's remove this as child here. I don't think we actually need this. Go ahead and save that. And still looks like it's not quite working correctly. If I had to guess, it's because our side panel has a z-index and this has no z-index, so it's probably just showing up behind it. So let's actually go on to our tooltip content here, and let's give it a high z-index. Tooltips should generally show over everything on the page, and we have a lot of content around the 1000 z-index area, so I don't like doing this all the time, but let's just throw like a z2000 on this, and now it should be guaranteed to show over everything. So now if I hover it, you can see this is what the tooltip looks like, just some white text. And I don't like that it's like super long here. I'd rather have it just wrap. So what we can actually do here is on our p tag, let's just throw something like a max width XS. We hover this, that's just setting the max width to 300 pixels. That way it'll wrap. So if I go ahead and save it now and hover over it, that looks a little bit better. Also, I don't know how this random slash got here. Let's remove that. And now it should be looking good. This tooltip is exactly what we want. Just a little descriptive field saying exactly what AQI actually is, and it gives context to what this number actually means. Let's now get this exact same tooltip with just different text inside of it on each one of these cards to explain what each one of these pollutants actually means. So what we'll actually do is take this tooltip exactly. Let's go ahead and copy it. Let's go down to where we're rendering out our cards down here. We're going to find the div where we have the key because that's the actual pollutant name. So this right here. And just like we did with the AQI, let's wrap this in a div, and we'll give it the exact same thing. We'll say it's going to be a class name of, I think it was just flex, item center, and gap2. Make some space for this here, and then paste in our tooltip. And if we go ahead and save it, now we should have a tooltip on each one of the cards. If I hover it, however, we're still going to see the exact same tooltip content as the AQI, which is not what we want. We want to have each one be unique to what it actually means. I'm not familiar with what each one of these things is, so I went to ChatGPT and I asked it to basically just generate the names of each of these from the abbreviation. So for example, for CO, we have carbon monoxide. For O3, we have ozone, and you get the picture. So what we can do now is we can actually use this mapping to display something in our tooltip. If I scroll up to where our tooltip is, it's right here. Let's go ahead and get rid of this AQI text right here because we don't obviously need that. And let's just say concentration of, and then here's where we'll enter in whatever the name is that this mapping gives us right here. So what we can say, it's called pollutant name mapping. So in here, we can say pollutant name mapping key, just like this. And now if we go ahead and save it, each of these tooltips should say exactly what they are. CO says concentration of nothing. That's not quite right. Probably again because the key is lowercase and these down here are actually uppercase. So let's go ahead and change that. Let's just say to uppercase for this key here, if I can spell it correctly. And then now if we save it and hover, these should say the exact thing. So this says concentration of carbon monoxide, concentration of nitrogen monoxide, concentration of nitrogen dioxide, and so forth. We know the key that we're getting here is technically just a string, but it's always going to map this pollutant type right here. So what we can do is because we're already typecasting it to uppercase, we know it's always going to be that. So let's just say as pollutant, and that should silence our type error. And now this side panel should be good to go. We have quite a bit of information here. We have the air pollution, we have the AQI number, we have these cards that have a nice little hover effect with sliders on them that change depending on where in the world that we go. And we have tooltips to explain what each one of these things mean. The actual content of the side panel is done, but the very last thing I want to do is add the ability for it to open and close. That way it can just flow better with the rest of our page. Because right now it's just sitting over the dashboard, but that might change depending on the screen size that we're on. So let's take care of that really quickly. It's not going to be too difficult. Let's close out of all these tabs here so we can kind of start fresh. And in our app component, let's actually make one last piece of state that just tells us whether or not our side panel is open. So we'll say const is side panel open. Set is side panel open equals use state, and we're going to default it to true. And then what we'll do is we'll pass both these pieces of state to our side panel. So we'll go down here and we'll say is side panel open equals that exact state. And then we'll do the same for the setter function. So set is side panel open and also pass that in as well. And once we do that, we'll have to update our props to make sure it expects those exact props. So we'll say is side panel open is going to be a Boolean, and then set is side panel open will just be a dispatch of set state action. That's also going to be a Boolean, and we will import dispatch. And the reason that I'm defining the state up here in app and then passing it down to side panel is because we're about to tackle the responsive design aspect of our app, and the rest of our dashboard, meaning all this stuff, is going to have to know whether or not our side panel is open to position itself properly. So that's why I had this state up here, and then I'm just passing it down to the side panel. So what we'll do now is we'll go ahead and save this, go back to our side panel. We'll go ahead and destructure these things from our props, but still keeping this props thing here so we can still spread it down. And we will just say const is side panel open, set is side panel open equals props so we can get them out of here. What we'll do for our class name here is we will wrap this all in a CLSX because I want to add a condition to it. So we'll say CLSX here. Obviously it goes to the very end. And what we're going to add here is we're going to say if the side panel is open, then what I want to do is I want to translate X0, meaning it should stay exactly where it is. Otherwise, if it's not, I want to translate X full. That way it shifts it off the entire screen. And then what we'll do is at the very top of our panel here, let's actually make a button that will just call the set is side panel open and set it to true or false, depending on whether we are opening or closing it. So what we'll do is we'll just say button. And then in the on click here, we will just say set is side panel open, and we will just set it to false. And it makes sense to only set it to false because if the side panel isn't open at all, then, well, this button won't even be clickable in the first place. So the only way this button can actually be here is if it's already open, meaning if we click the button again, it should set it to false now to close it. Now I could just make this a super simple button that just, says something like hide in here, but I don't want to do that. That's not very clean from a UI perspective. Ideally, it's something like a chevron or visual indicator that we're going to be closing the side panel. I found this simple chevron left.svg on svg repo that I think we can use at the top of our side panel. That would be a good little indicator that we're going to be closing it. Let's go ahead and import this chevron left as a component. We'll go up to our side panel here. In the same way that we're doing our information, we will just say, I don't know, we'll just call this component chevron. And it was, I believe, chevron left.svg. So now instead of saying hide, let's just render out chevron, like an actual component. And we will say class name. I don't know, let's try size 8. If we go ahead and save it here, now we should have the chevron up here. It still is black, so I'll go ahead and invert it to make it white so we can see it. And now this chevron should be our button. It looks like this SVG has a little bit of extra space on it because it's not quite left aligned with our A here. So if we actually go into it, I think we can verify that. Let's make a bit more room here. I believe, yeah, so it looks like there's some awkward space there on the left side. So let's actually go into here. I don't like doing this because it's a little bit hacky, but I'm going to add -2 for the left margin here. That way it just scoots it over a little bit. And now if we go ahead and click it, you can see our panel completely closes. We don't actually have a way to get it back yet, so we'll have to refresh, but I can show you again. We have our panel here. I click the chevron, and now it closes it. Let's add a super simple animation so it doesn't just immediately disappear, but actually slides out. All we have to do is we have to go up here to our uppermost class name, which is this one right here. And we'll just add transition, transform, and we will say duration 300. And now if we go ahead and save it, and now close, now it slides out as opposed to just flashing out. So this looks really smooth. And this is what most side panels, at least on most modern apps, are going to do. They're going to slide in and out like this because it just looks cleaner than it just teleporting. The very last thing we'll need to do with this is make a button to actually reopen the panel. That way we can go between open and close. Just like I found the chevron SVG to close it, I found this hamburger SVG that's a pretty common sign in most apps that we're going to open up some sort of menu like a side panel. But I think this icon would work well for our open button. So what we'll actually do here is copy this exact same button, and let's head over to our app component, and let's put it in the same div that has these two dropdowns right here. So they're all in a row together. If I go to the div down here, you can see we have this div that is flex call gap 8, which I think is not the right one. It should actually be this one here. This flex gap 8 is going to hold both of our dropdowns. So let's here, after the map type dropdown, go ahead and just paste in this button. I'll take this negative left margin off and instead just do ML auto. That way it aligns itself against the far right side. And of course, we'll have to replace this chevron with the hamburger. So let's go ahead and take this image import. We'll just copy it verbatim up here. And just change this to say hamburger instead. And imports, I think it's capital H hamburger. No, lowercase. Okay. So it's just hamburger.svg just like this. And now we'll replace our chevron with hamburger, still being size 8 though with the invert. Go ahead and save it now. And now we should have this hamburger at the very top that if we click it, won't do anything because it's setting it to false still. So let's set it to true whenever we click the hamburger here. Let's go ahead and save it. Side panel starts open. We have our chevron to close it, and we have our hamburger to open it back up. So now we can safely alternate between the two states, open and close. This is super smooth now. We might come back in a minute and customize how these buttons look, but the functionality is completely there, and I think we're in a great spot. So we now have a fully functioning side panel that displays a bunch of information that is useful for us to see with a bunch of cool logic that we can just open and close however we want. However, one thing I don't want to forget about before we move on from the side panel is the skeleton loaders. We already have the skeleton loaders for the rest of our cards whenever we're fetching new data. However, we don't have any for the side panel. If I click somewhere, the entire panel just blanks out before it reappears. Because the cards fade in, it actually doesn't look horrible that way, but I think to keep things consistent, we should make skeleton loaders for each of these cards as well. Making skeleton loaders now is super easy because we've done it a couple of times. Let's go ahead and go to our file explorer. Let's go to our skeletons folder, and we'll make another skeleton card in here. We will just say side card skeleton.tsx, just like this. We'll do tsrfc to create the component. And what I'll do is the exact same thing we did for our other cards. I will go to the JSX for the card itself, take all of this exactly, go ahead and copy it, and we'll paste it in here, being sure to import the card, and we'll remove a couple of things from here. First of all, we don't need the key. Next, this tooltip is not needed on any of this, so we'll go ahead and just remove that. And if you recall with our other skeleton cards, I'll go to the current skeleton, for example. Everywhere that we were consuming some sort of API data or anything on the actual component, we just replaced it with this skeleton component from Shadcn. So let's do the exact same thing here. We'll go ahead and copy one of these, over back to our side card skeleton, and we'll start replacing them. If we first look at this right here, this text with the tooltip, we can see that with the tooltip plus the text itself, it's about 50 in width. So it's, 46 here, we'll just say 50 to round up. And then 28 in height. So we'll actually replace this whole thing here, this div that has the key. We will say it's a skeleton that has, what I say it was, 28 in height. So divided by 4, that is height 7. So that's already good. And then the width is 50. So divided by 4, that's about 12. So we'll just say 12 here. And of course, we'll make sure to import this skeleton here. Now for this next one, for the actual value, this can also be a bit variable, but we'll say this is going to be the exact same height and actually pretty much the same width too. So we'll give it the exact same stats for this one. It will say width 12 and height 7. Next, if we go to look at our slider here, we can see that this slider is just hard-coded to be 6 pixels tall, which makes our job super easy. We'll make a skeleton here to replace the slider. We will make sure it is width full to take up the entire space of the card. And 6 pixels divided by 4 is going to be a height of 1.5. That should be our sliders taken care of. Now if we just look at these two numbers down here that represent our scale, we can see that 0 is always going to be, 16 pixels and about, let's just say 8 wide. So we'll replace this with 8 divided by 4 is with 2. And then 16 tall divided by 4 should be height 4. So we'll replace both of these with that. And now we're almost done. We don't need to map over the actual pollutants here. We already know that there's only 5 possible qualities. That's good, fair, moderate, poor, and very poor. So instead of mapping over this, all we have to do instead is do an array of fixed length, because after all, it's a skeleton, so we don't need the actual data. And we will just say length is 5. We don't need this quality here, but we will go ahead and get the index out of here just to throw it on this. And what we'll do is we'll just put a skeleton here. Let's throw a key of index. And then for each of these little tags we have down here, it looks like they're going to be, so 24 in height, so divided by 4 will be a height of 6. And then the widths are going to vary a little bit. Let's just say, for the sake of these, let's see, we have 40, 70, let's just say 60. So 60 divided by 4 will be a width of 15. Now if we go ahead and save it, this skeleton should be fully done. It should just mimic our sidecars exactly. So let's go ahead and close our side panel here. And now if we actually head back to the side panel, we can finally make use of the suspense that we wrote at the very beginning when we started this. Up here, we have a suspense that is wrapping around air pollution. But hold on a second. We just made a skeleton component for each of the cards, but this suspense wraps the entire air pollution component. Meaning essentially this entire air pollution component also needs to be a skeleton. At least the component that we use in the fallback of the suspense. So what we can do will actually be super simple. We'll make one final component here in our skeletons folder that we're going to call, let's say side panel skeleton.tsx, just like this, tsrfc to make the component. And what we're going to do is we're going to go into side panel, take all the JSX here that we have for the air pollution. So literally all of this. This should be the opening and closing div. Yep. We're going to take all of it and we're going to go ahead and paste it in here. But we can obviously remove almost all of this. First of all, this tooltip, we don't need it. So let's go ahead and delete this. And because we're doing with the skeleton, we don't need any of this logic in here. So let's completely purge all of this logic out. We only have the return. And we just finished working on our skeleton cards for the side panel. So instead of mapping over the regular cards here, let's map over those. So we'll just say side card skeleton, just like this. And of course, we won't have actual data to map over. Let's just map over an array of fixed length. We know there's always going to be, it looks like 4, 5, 6, 7, 8 pollutants. So we'll say an array of length 8. So array.from going to be length 8 like this. And we obviously won't have any key and value to map over, so we don't need to worry about that. But let's still go ahead and get the index out just to continue good practice here. And we don't actually need this curly brace or this return anymore. So we can go ahead and get rid of this and just map this directly. So let's go down here, get rid of, I think, all of these, except not quite all of them, just these two. Actually, let's get rid of this too. I need to fix this formatting in a second. I don't think it's quite right. Make sure we have an opening parentheses here to get this correct. For the key, we'll just pass in the index. And this sidecar skeleton can actually be self-closing because we literally don't need any of this content down here. So what I can do is just pretty much close all of this. Let's literally delete all of this. Don't need it. And we can simplify this code down way more. We don't need either of these class names, so we'll go ahead and remove them. And then let's just fix this styling here. Looks like this div is the closing for here. But I think we're just missing a curly bracket. So let's go ahead and add this. And this parentheses should not be needed. Actually, that's a lie. It should. That's our return. Let's track these real quick. So that's the opening and closing there. We have this. Maybe we're missing this. Looks like we're missing a parentheses here. So yeah, now that we have that, this should be good. We'll make sure to import the sidecar skeleton so we have the right reference. And now, minus these few fields up here, this is all that our actual side panel skeleton is going to be. We're going to replace these with skeletons in just a second, but all it is just a mapping of our sidecar skeletons to make it look one-to-one how our actual panel is. Now, the very last thing is just this number right here. This data.list.aqi is obviously not going to be in our skeleton, so let's go ahead and inspect the actual number just to see kind of how big it's going to be. Looks like it's always going to be height 48, so 48 divided by 12. We can just get one more of our skeletons here. 48 divided by 12 should be 4, so let's replace this a skeleton of height 4. And then the width, this is going to be the width of the whole entire thing, but the skeleton shouldn't be that whole width. So we'll just say, but for the actual number itself, let's also do a width of 48. So 48, oops, this should be not 4, it should be 12. And since they'll both be 12, we can just say size 12. And we'll go ahead and import skeleton. And now we should have a fully functional skeleton for the entire side panel. So I can finally show you what this looks like. Let's close out of here. And let's go ahead and go back to our side panel. And now, after all that work, we can finally plug in our fallback component for this suspense, which you will just say is side panel skeleton, just like this. Now, if we go ahead and save it, this should be a fully functional suspense. If I go over to our map and I click somewhere, you can see all these cards go into suspense mode, into their skeletons, and they come back with the data on them. One thing, however, that's immediately obvious is that we can't really see our skeletons inside of each card because they're the exact same color as the card itself. So what we can do is we can go into the side card skeleton here. And what I'll do is just add BG sidebar on each of these. So we make our color a little bit different than the actual card itself. I'll throw that on each one of our skeletons here. And we'll go ahead and refresh this page. I'm not sure why it crashed there. Looks like we forgot the BG sidebar on the slider here, so let's add it to this one. And now if we save it and we go somewhere else, you can see our skeletons look pretty nice. It's still a pretty subtle dark. It's not really super noticeable. However, I don't think that's a big deal. I think if it was too dark, I think it would look a little bit out of place. And now everything appears to be working like clockwork. I click, we suspend the whole panel, show the skeleton cards, and as soon as the data is ready, it comes in and it looks great. Now pretty much everything in our app, including the side panel and also all of our cards down here, are all gonna have skeleton loaders, so it looks super crisp whenever we load any new data in. Alright, so what's the next step for this app? Well, we're getting very close to the end here. For almost this whole video, we've kind of just sat these cards in this super ugly looking column. I mean, we just have a single column on the page here, and let's be honest, it looks kind of bad. Because we've essentially just been ignoring this container formatting here the entire video to make the actual content, but now I think we're at a great point in the video to finally address it. Especially because we just added the side panel, and now if we hover over this, or we open it up, now it just looks even more awkward because it looks like we're trying to just cram a ton of stuff in one page, and it doesn't really look super professional. So with that being said, let's finally address the issue of styling these cards and this dashboard in general to look good and work in conjunction with this side panel here, along with responsive design. As part of that, we'll make sure the dashboard and the side panel both look great together on all screen sizes, and just make sure that they can look good on any possible device. The dashboard structuring plus responsive design isn't going to be super challenging. We'll just have to be careful and pay extra attention to the layout of all the divs and whatnot that we have. So without wasting any more time talking, let's get started on this. Now we're going to go ahead and shrink the VS Code window down to make more room for us on this page. This entire video that we've done so far, we've had the entire website over here just kind of in that little narrow view, but now let's make it actually wide so we can see what it really looks like. And it's obvious that right away with this bigger view, it looks pretty bad. So what we can do, and how I normally do responsive design, is if you open up the DevTools here, you can actually, let's shrink this down a little bit. You can open this button right here in the Chrome DevTools that puts it into responsive mode, and that looks absolutely horrendous, but we'll ignore that for a second. Essentially, I use this responsive mode most of the time, where you can kind of just take the width, and you can resize it, and you can see exactly how it looks at every possible screen size. Now, in terms of the side panel here, every single app that we have is going to be slightly different in terms of when and where we actually show the side panel. But generally, if you're using Tailwind breakpoints, the sidebar should collapse around the MD or LG breakpoint. So LG is 1024 and MD is 768. So usually around that part, if you're shrinking down from, big to small, around those numbers and width is generally where you would close the sidebar to make more room for the actual content since it's getting skinnier and skinnier. For our use case, since we have a decent amount of stuff to show on this dashboard, let's err on the side of caution and say that if we are below the large breakpoint, the side panel will be automatically collapsed with the option of opening it and closing it like we already have. And then if it's above LG, it will always be on the screen and it won't be collapsible, meaning the side panel and the dashboard will be showing at the exact same time. And again, like I said, the large breakpoint or LG is 1024 pixels in width. So if you look at our DevTools here, when I'm in this responsive mode, it actually gives me the width in this number up here. So right now we're at 1241. And if I just start shrinking it down, you can see that number adjust. So 1024 is going to be at roughly this width here. And at this width is where we're going to change how the side panel behaves. Because the way that we originally coded the side panel, how it already behaves is that it opens up over the dashboard. So we already have the case where it's under 1024 pixels taken care of. But now we need to fix whenever it's over 1024 and we want to show both at the same time. So usually what this means, the way I go about doing this, is having some sort of CSS variable that controls the width of the actual side panel And then when we're calculating the width of the dashboard, we just subtract the width of the side panel from it. That way they can fit on the screen together. I'll show you what I mean by that. So let's actually close out of all these files here. I'm going to zoom out a little bit. I know it might be a bit harder to see, but since we have a smaller window here, I think it'll definitely be helpful to not be super zoomed in. And let's go to our index.css file here. And let's go to the very top here, to the root. And let's go above all these CSS variables, and let's add one for the sidebar width. So we'll do dash dash sidebar dash width, and we will say it is 23 rem wide. And now what we'll do with that is we will save it. Let's go to our side panel, and instead of having it hard coded to be width 90, we will just hard code it to instead be width of sidebar width, just like this. And now if we save it, it should be 23 rem. We go ahead and go into the inspect here, and we look at it. It looks like that's not quite right, I think, because this should be square brackets and not parentheses. So let's change that. Square brackets here. I think that should be good. As we have, let's see. Okay, my bad. I keep forgetting this new Tailwind v4 syntax. So we're going to just do it like this. And now there we go. If we save it, this should be 23 rem right here. Now that we have a defined width for the side panel that is based on a CSS variable that is global, let's now go back to app here. And right now, if we scroll to the outermost div of this dashboard, it should be this div right here. So we have essentially this div wrapping the whole entire dashboard and then the side panel. So this div right now is going to be width full. Technically it's width auto, but it has no constrained parent. So by default, it's always going to be the width of the entire screen. So what we can do on here, just to be explicit, is we'll say width full by default, because on small screens, we still want it to be width full. But once we're above the LG breakpoint, so we can do it like this, we want our width to actually be a calc of, let's say 100 dVW, which is basically the screen. It's 100% of the device width. We do that minus the sidebar width. And now if we do it like this, we're saying on small screen sizes, we're still width full. But as soon as we get above 1024 pixels, then we want to have the entire dashboard be 100% of the screen minus however wide the sidebar is. And now if I go ahead and save it, you can see that everything shifts over. It looks a little busted because we don't have any padding yet for this entire dashboard, so everything's kind of just crammed together. So let's go in here, and we already have gap 8 for these individual items, but let's throw a P8 on here. Now if we go ahead and save it, it should look quite a bit cleaner. This map right here is still going to be weird because we have the hard-coded width value for the map. So let's actually go into our map component. And right now we have just width hard-coded to 1000 pixels and height as 500 pixels. However, for now, let's keep the height on here hard-coded how it is. And we will just say the width, instead of being 1000 pixels, will just be 100%. And now if we go ahead and save it and refresh this, the map should now also be constrained to this same dashboard div. And now we can clearly see that everything fits on this page. None of it is going underneath or over the side panel. Each section has its own space, which is exactly what we want for larger screens. However, once we go smaller, like we keep getting smaller and smaller until we eventually drop below the 1024 breakpoint, now we can close our side panel and this width can still be the full width of the screen, which is how almost all modern web apps are going to behave to some capacity. And ideally what should happen is whenever we're on larger screens like this, the side panel should open by default, and then once we get below the point of a large screen, so below 1024, then this side panel should also close automatically. So let's add that real quick. How we can do that is we can go back to our side panel here, and on this very top outermost class name, let's throw one more thing on it. Let's say when we're on large screens, so we're at 1024 pixels or above, then we're going to translate x0. Meaning no matter what, if we are above LG, translate the side panel onto the screen. And we'll likely need to throw an important on here so that our side panel open state that we have right here doesn't try and override that. If we're on large screens, we don't care about this state literally at all. We're always going to have it on the screen, so we make sure it's important. And now if we go ahead and save this, let's start on a small screen size. And if we close the side panel and now we start expanding, we're eventually going to go over 1024. And now the side panel will just automatically open back up. And then what we can notice here is if I refresh it here, we're on a big screen, we start shrinking down. Notice how it's not going to close automatically. The way that we can get that to happen is we can actually just go to our app here. And right now we're defaulting this is side panel open to true. Let's just change it to false and see what happens. If I start it as false, do this, Now I go make our screen big, refresh just to make sure we're starting completely fresh. And now I start shrinking down. Side panel's open, side panel's open. And as soon as I hit 1024, boom, it closes and the dashboard expands. If I go back out, it does the same thing. And now I can go back and forth between them, and it works exactly the way that we want it to ensure responsive design. Now, one thing to keep in mind is that if we're on big screens here, we shouldn't be able to click this chevron at all. And in fact, if I try to, nothing's going to happen. And that's again because when we're on large or bigger screen sizes, we're always showing the side panel. So it doesn't make sense to have this chevron here when we're on large screens, because obviously we don't want to show it if the user can't even click it. The super easy fix for that is to just go to where our chevron is here, which is right here. And all we have to do is add LG hidden. So by default, it won't be hidden, but as soon as we're at 1024 pixels or wider, it's going to be gone. So now save it, and now we have no more chevron. In that same vein, it doesn't make sense to show this hamburger icon either. Normally, this should only really show if we have the ability to open the sidebar. But again, on this screen size, we're big enough where it's always going to be open, so this hamburger icon doesn't do anything. So we'll just go to app, and we'll add the same exact thing to the hamburger icon. We'll go here, and right after ML Auto, let's just throw LG hidden, save it, and now when we're on this screen size, they'll be hidden. So now the chevron and the hamburger are both gone on this screen size. Because we can't open or close the side panel, it's just stuck right here. And now if we go small enough and we fall below 1024, now the hamburger is going to reappear. Our styling's messed up, so it's actually behind the side panel, which we'll fix in a second. However, I can close out of this here, and boom, you can see the hamburger is right here. So once we're a small enough screen size, we can still open and close this at will. But once we get big enough, those disappear, and we're just stuck with the side panel. Now that we have this, let's actually figure out what we're trying to do for the dashboard. After all, it's the most important part of our app, and we pretty much haven't styled it at all. I mean, the cards themselves and the data is styled, but the formatting of the cards and how they're positioned is just hard-coded to a single column. Which, you know, is completely fine if we're on like a mobile screen like this, because obviously we can't really have much more room to have more than a single column. However, when we have like more regular size, larger computer screens, having everything just be the width of the entire page just does not look very professional. And this is going to stem purely from the fact that if we look at this outermost div here, it's just set up to be a flex call. Instead of hard coding this to be flex call, I think we should do what most dashboards do to ensure they're responsive at all sizes, and that's using a grid. With a grid, we'll be able to change how many rows or columns each item takes up at different screen sizes and get way more flexibility and options instead of just being pigeonholed into a single column. So let's go ahead and get this div set up. First, we don't want this div that holds all of our dropdowns and our hamburger icon to actually be included in this grid, because they're kind of off on their own thing. So I think that div is this div right here, but essentially everything from the map all the way down, so from here, not including this, but essentially here to here, all of this should be inside the grid. So essentially just the map and all these different cards that we have down here. So what I'll actually do is go back over here, Control-Shift-P, wrap, and we're going to wrap this all in a div, and we're going to give it a class name of grid. The next question to ask when setting up a grid is how many columns should this grid actually be? Well, when you're working with Tailwind responsiveness, sometimes it's easier to start with the small screen sizes and work your way up from there, because technically that's the way that Tailwind is built. The default styles that you want at the smallest screen sizes, you don't put any breakpoint on them, but as soon as you want to start getting bigger, that's when you specify the SM, MD, LG, and so forth. So let's actually do that, and we'll start from the smallest screen size. Let's set it to around, I don't know, 600 or 700 in terms of width here. Let's just say, I don't know, 650. At this screen size, we don't really have any more room to allow more than one column in this grid. I mean, essentially, we're going to have each card take up the max width because we don't have a whole lot of width real estate to work with. So on this grid here, we'll say by default, this will be grid calls 1. If we go ahead and save the file like this, we are still in our column layout, although we lost all of our gap. So let's go ahead and just add gap 4 back on here to ensure we have proper spacing between our grid items. And this grid now looks perfectly fine for this screen size because it's super basic, just being a single column. So now let's start widening our window a little bit. Once we start to widen, and we get closer to the, I don't know, 900 or 1000 width, starts to be the point where I think realistically we can fit more than just one column. We can keep the map as being the whole width because the map is kind of the focal point of the app. Plus we have some cards that are still pretty wide, but what I'm willing to bet is that the daily forecast here and also the current weather can most likely fit in the same row at this point instead of each having their own row. especially this current weather card, because right now there's so much empty kind of like white space here on the card since it's all centered. And I think it looks a bit bad at this screen size. So I think what we can do here is just make the current weather fit on the left side of the column and the daily forecast fit on the right side of the column. And then aside from those two cards, everything else will still stay at the full width. And the way that we can specify how much space we want each grid item to take up is by specifying call span and row span on each of the items. And unfortunately, I can't just go in here and throw a class name on each of these suspense items and do like call span 4 on here, because suspenses don't take class names. So what I'll do here actually for each of these divs, for each of these sections, is I will actually wrap them in a div. So I'll wrap each one of these suspenses in a div here. That way we can get more specific with the styling, because we can give each one of these their own class name. So we'll do this one wrapped in a div, and we will wrap this last one in a div right here. And this div here for each one is essentially just going to represent the actual grid item for that card. So this is the grid item for our current weather, this is the grid item for hourly forecast, and so forth. Now what we can do is we can say, by default, every single one of these is going to be call span 1. Now, technically, you don't need a class name to specify that, but to be explicit and to show you what I'm trying to do here, I'm going to write this on every single one. So we'll just add this call span 1 on all of these, so that by default, with no other conditions, every single one of these will take up one whole column. And that'll also be added to our map, so we'll add it to this div right here. Oops. We'll just add call span 1, throw it onto this already existing class name, and now we're just being explicit that each grid item is always going to be one column. However, I just mentioned that once we're around this point of being, 900 or so pixels in width, we're starting to have a bit more room. And I know that the medium breakpoint for Tailwind is 768 pixels in width, so I actually want to try that one first just to see how it looks. So what we'll do is on our grid here, we'll go up and we will say at medium or higher screen sizes, we want it to be grid calls 2. That way our entire grid is going to be 2 columns wide. Now if we go ahead and save this, everything is going to get super out of whack. And that's happening because all these grid items are still only spanning one column. So essentially what we need to do here is for all of these, we need to say when we're on medium or bigger screen sizes and we have 2 columns, we still want some of these to span the entire width. So we'll say call span 2 for the map, for example. And now if we do that, the map still goes the entire width. Let's take this and we'll add it to the map. We'll also add it to the hourly card, and we'll also add it to the additional info card. So these 3 will still take up the full width. Now, the only ones that aren't taking up the full width are going to be the current weather and the daily forecast. Because this hourly forecast card is now sitting between the current and the daily forecast, that means that these aren't ever going to connect. So to fix that for right now, let's take this daily forecast div and let's actually move it up to be directly below the current weather. And now, if we save it, we're getting somewhere. If I go ahead and shrink to around 800 width, where this breakpoint starts, right around here-ish, I think this still looks pretty good. Everything has plenty of breathing room. If I go to 900, still looks great. Nothing is stretched too crazy. So I actually think this format would work quite well, keeping everything mostly in one row, minus the current weather and the daily forecast. The only thing that's a little bit awkward right now is that this current weather card and the daily forecast are clearly not the same height. One way to fix this would be doing kind of a band-aid fix, but we could just go into the current weather card here, and we can add some extra spacing at the bottom. That way they're not off on the height. Meaning we could go on this card, we could add a class name on this, and we could add something like PB8, PB8 like this, and it should create some extra spacing on the bottom. It looks like that isn't quite enough, so let's actually change this to, PB12, too much, 11 maybe? Yeah, let's do PB11, and that looks to be good. However, one thing is we want to make sure we don't mess it up on the other screen sizes because we already got it looking good on the small screens. So let's add MD to this, and we're saying only on medium and above screens do we want this extra padding to be there. So it's kind of a band-aid fix. I don't really love doing this, but this problem I think is only going to be happening on this particular screen size, so I don't think it's that huge of a problem. And now I think we're actually in the clear with this screen size. Let's go to the starting point again. Our starting point is 768, so once we're below that, we're going to have this single column layout. As soon as we get to 768, boom, mostly the same thing, minus the fact that now the current card and the daily forecast are side by side. And if we keep scaling up, 800 looks great, 900 looks great, 1000 looks great, and everything is still looking good. And just to double check, let's just make sure it's all smooth here. it looks like there's no points where it gets really weird or looks super ugly. In fact, I think it looks super nice all the way throughout all these transitions. It's just growing and shifting, and everything seems to be moving the way we want it to. Now that we know it looks good at this screen size, I'm going to shrink my VS Code to be even smaller, and I'm actually going to take these dev tools here, and I'm going to pop them out. So I'm going to go, oops, that is not the right thing there. What I'll do is I'll go here and just pop the dev tools out. That way it's not actually taking up space. And now if we expand this, we should be able to get as big as almost 1700 pixels. I think I went a bit overboard with shrinking VS Code down, so now I just hard coded this to 1600 pixels, and we'll have a lot more real estate to work with. So going back to the size that we had, we were just working around the roughly the 800 to 1000 pixel range. And now let's keep working our way up. I think that once we cross the 1024 pixel point, I think it's definitely still smart to have current weather and daily forecast side by side and the other ones still in their own column. Because at this point, because the side panel just came back in, it doesn't make sense to switch it up. Because now we're again forced into a smaller size for our dashboard. So as soon as we get over 1024, we're actually losing quite a bit of real estate for our dashboard, at least in terms of the width that we have to work with. So this screen size should be good as is. Now if we keep scaling up here, we can notice we're obviously getting more and more real estate. And once we're at the, 1200 to 1300 mark here, I still don't really think there's a ton more we could do. Again, having the side panel here essentially collapses the dashboard real estate to be almost what it was before 1024. And actually, yeah, this size looks to be a little bit bigger than the size that we have here, because this side panel is now taking up actual space. But I would say once we keep stretching and we get to the point where we're at about, probably at this point here, so around the 1500 pixel point in width, now we're starting to have quite a bit more real estate to work with and might be able to fit more things into our grid rather than just a mostly single column layout. And funny enough, 1536 is the last built-in Tailwind breakpoint, and that's 2XL. So I think 2XL would actually be a great breakpoint for us to use for full-size computer screens. And let's be honest, nobody's really using 1280 by 720 screens anymore. Pretty much every computer device is going to be at least 1920 by 1080, meaning the width on all genuine computer screens will be at least 1920 pixels, so it will be included in this 2XL breakpoint. In other words, the view that we already have here is what most mobile devices are going to see, or tablets. The view that we're about to make at this 2XL breakpoint, once we get above 1536, is what most computers are going to see. So how should we now design this dashboard to look on computer screens? If we go back to the drawing board here, here's kind of what I was thinking. We'll assume this white space here is pretty much just our dashboard. I was thinking we would still have the map essentially take up the entire width of the dashboard. Again, I think that's fine because the map is kind of the focal point of our entire app. And then what I think we can do is we can have the current and daily weather cards go below it, but on opposite ends of the dashboard. So we'll have, let's say, the current weather card here, and then we will have the daily weather card right here, just like this. And then the last two cards that we have are the hourly forecast and the additional info. And we could put these two here kind of more long ways. We could say the hourly forecast is this one, and then the additional info could be this one, just like this. I don't think this will get super complicated, but we'll have to watch super carefully to make sure that we're setting up our grid properly. So looking at our sketch here, I think this can logically be broken down into 4 separate columns. Essentially, I'll draw red lines here for each of the columns. These aren't actually proportional, really. Actually, got a bit of a brighter color, so a brighter red here. So our first column is going to be kind of this line right here. These middle cards here are going to be 2 in width, so we'll say these are each 2 columns. And then we'll have kind of this layout. We're going to have essentially section 1, section 2, section 3, and section 4. With that being said, let's make this a reality. So it's 4 columns. So on our grid here, we're going to go, let's see, where's it at? Oh, wrong component. Let's go back to our app here. We have the grid. Grid calls 1 by default. On medium or higher, where grid calls 2. And I just said on 2XL, so 1536 or higher, we want it to be 4 columns. And if I save it, it's of course going to screw up our layout pretty bad because we haven't told each of the grid items how many columns each of them should span. And also, because of the way that I drew out the sketch, we're not only going to want to control the horizontal spacing, so the calls, I also want to control the vertical spacing as well. So we're going to also throw 2XL grid rows for. That way we can think about this grid like a 4x4. And that's going to make things easier if we have an actual defined height and width for each one. Let's start with the map. I mentioned in our sketch that the map should really still just be the whole width of the entire dashboard. So let's first throw a 2XL. We're going to say it should be call span 4 to take up the whole width of the grid. Go ahead and save it, and we've already achieved that. I also think not only should the map take up the entire width of the dashboard, I think it would make sense to take up half the height as well. That way the first half of the dashboard height is just the map, and the second half is the rest of our cards. So with that being said, we know that our grid is going to be 4 rows tall. So we'll say this at 2XL is going to be a row span of 2, because 2 is half of 4, so we'll take up 50% of the height. Go ahead and save it. Now everything is going to look a bit whack. Part of the reason for that is because our grid doesn't have a defined height, so it doesn't really know what to base it off of. However, it's logical to assume that this dashboard is going to take up the entire height of the screen at this size. So let's go to the outermost dashboard div here, which is this div, and let's just throw a h-full on it. That way it's the height of the screen. And actually, sorry, not h-full, it should be h-screen. And it should only be confined to the height of the screen on 2XL or higher, so we'll say 2XL height screen, just like this. We also need to fix the fact that if we go back to our map here, this height is still hard-coded to 500 pixels. So now that we have a defined height for the grid, let's set this to 100% as well. That way we shouldn't have to worry about a hard-coded size messing things up. Go ahead and save it, and let's refresh this. And now our map is going to look a bit weird still, but we're getting better. The reason it's so big right now is because these cards aren't spaced properly. So right now this map is technically half the height of the rest of this height, but all this is overflowing still, so it looks really bad. So now let's fix the rest of these cards. Remember in the design, I said that the map should be half the height of the entire dashboard, meaning the rest of these 4 cards here have essentially 2 columns more of height to work with for all 4 of them. So let's now look at our current weather card. Right now it's only spanning 1 column, which actually works out because that's exactly what we want on the screen size. However, we want it to take up half the height of the grid, so we'll also, just like the map, say this should be 2XL, row span 2, just like this. And for a second, real quick, I'm going to skip daily forecast. If we look at hourly forecast, I mentioned that both the hourly and the additional info should both span 2 columns to make room for the other cards on the side. So each of these is actually going to take a 2XL, call, span 2, so they each take up 2 columns of horizontal width. We'll take it on this one, and we'll also throw it on the additional info one like this to make sure they are spaced properly in terms of their width. But actually, funny enough, I just realized we already have that for the MD. This actually is not needed at all because it'll still apply to the 2XL breakpoint, so we're actually perfectly fine as is. However, looking back at our design, we want both the hourly forecast and the additional info to look pretty short, so that when you add the height of the hourly forecast and the additional info card together, you get the height of the current weather card. Current weather card is 2, which should mean that each of these little smaller cards, the hourly forecast and additional info, should be a height of 1. So what we'll do for that is we'll say on 2XL, we're going to say it should be a row span of 1 to give us some more vertical height. We'll throw it on here, and we'll also throw it on here, both the hourly and the additional info. Go ahead and save it, and that should adjust the height of those cards. However, it's still going to look really bad for one particular reason. These cards are now super out of order. In our layout, everything just reads from left to right. Meaning if we look back to our sketch, the actual ordering of the elements should be the map first, then the current weather card, and then the hourly forecast, then the daily forecast, and then the additional info at the very end. What that essentially means is that our hourly forecast right here and our daily forecast would have to swap positions in the JSX. However, if we simply do that, we're going to mess it up how it looks at these smaller screen sizes because we already made the ordering work for this. So lucky for us, grids have a pretty convenient way to handle the ordering of things, especially at different screen sizes. Tailwind has a property called order that you can use that specifies the actual order of things. So let's smack order on each of these in the default order that they're in, so matching the JSX. For the map up here, which is this div, we will just give this an order of 1. We'll take this essentially for each one. We'll say map is 1. This one is going to be 2, the current weather card. Daily forecast is going to be order 3. Hourly is going to be 4. And additional info is going to be 5. Now, this is self-explanatory, and this by itself doesn't actually do anything because they're already in this exact order. However, on 2XL, we need the order to switch slightly. So what we can do to make sure the daily and the hourly swap positions, we can say normally this is order 3, but once we're on 2XL screen size, we're going to make this order 4. And we'll do the exact opposite for the hourly forecast. So we'll say normally it's order 4, but on 2XL or higher screen sizes, we'll make it order 3. And now if we go ahead and save it, our dashboard is almost going to look normal. Not quite, but it's getting there. Go ahead and refresh just to make sure. And yeah, so we clearly have some spacing issues still, but the overall kind of grid layout is actually how we want it. However, we might have an actual problem now. So we made our map essentially be height auto because we did the height and width of 100%. However, this is going to cause problems if we're on a really small screen size, because now there's no actual defined width or height. The map has no idea essentially how it needs to size itself. So what we'll do is we'll go to the grid item that's actually holding the map here, which should be this right here, this div. What we're going to do is we're going to say, let's give it height 120 when we're on small screen sizes, and then only at 2XL or higher. Then we'll do height auto. That way, once we're on this screen size, it still looks fine. However, once we go bigger, now it can do the auto sizing. So let's keep expanding and get to our bigger screen size here. And again, we still have a really weird spacing issue because this stuff down here is way too tall and out of place, so it's making our map also look super tall. I think part of the reason this is happening is because this additional weather info card is a bit too tall, so it's causing some weird spacing issues. So let's actually go into that component real quick. Those are other components, and we will go into additional info. Right now, this additional info card is just hard-coded to be a flex call, so everything is very vertical. In our design, we have this additional weather info card being quite a bit wider than it is tall, so I think in that case, we should make it not a singular column, but maybe like a 3x2. So we'll have, for example, the cloudiness, UV index, and wind direction in one column, and then the pressure, sunrise, and sunset in the next column. The easiest way that we can do that is by still maintaining this on smaller screen sizes by just making this a grid, but just giving it grid calls 1. So by default, it is still a singular column, but on, let's say, medium screens or higher, then it's going to be grid calls 2. And the reason I'm doing MD and not 2XL is because I think there would still be plenty of space on medium as well. So if I go ahead and save it, I think it looks decent here, being 2 columns instead of 1. And if I for a second shrink down to a smaller size, I also think this still looks completely fine, being 2 columns and not just 1. If we go smaller though, below 768, now it'll go into the vertical layout. Let's go back to our super big screen size for a second. And even though now it's 2 columns, we still have this really weird spacing issue going on. The thing that's immediately obvious to me is that our grid is overflowing the page. As you can see here where the background of the page cuts off, is right roughly in the middle of this hourly forecast card. And that's where the grid should actually cut off as well. But the grid content is just way overflowing it. We need to make sure our grid takes up all of the space in this dashboard that is given, so basically the entire dashboard and no more. The way that we can actually do that is we can go to our app here, we can go to the div that has our grid on it, and we can actually throw a flex1 on it. The grid's immediate parent is already flex call, so by throwing flex1 on this div, the grid, we're giving this grid permission to grow to fill the rest of the space that it has. If we save it, however, it's still going to be messed up, nothing changed. But I want to show you some magic here. If for whatever reason in a flex call layout, flex1 by itself is not working, go on the div that has flex1 and throw a min h0 on it, and that will actually fix your spacing issues. I'm going to be honest with you, I don't know why min height 0 works for flex1 like this, but I've used this trick a bunch of times and it's saved my life quite a bit. In the same vein, if you have a flex row, you can also use min width 0 to achieve the same effect. Sometimes having that min height or that min width actually saves the flex1 and makes it behave properly. Having this flex1 and min h0 here shouldn't affect the styles and other screen sizes, but just to be sure, let's make sure they only apply when we're on 2XL or higher. So we'll add 2XL to both of these. Because we've already got the smaller screen sizes looking good, I wouldn't want to regress and mess these ones up. And now this is going to fix our grid sizing problem. It looks like our grid now is the actual height that it should be. However, we still have this kind of awkward gap between the hourly forecast and the additional weather info. For some reason, there's just this spacing here that makes it look really awkward. I think what the issue is, we're noticing we have that gap between those, and also if you look below the current weather and the daily forecast cards, we also have some gap where the cards aren't even getting close to touching the bottom of the screens. And I suspect the reason for that is if we go into our shared card component, these cards don't actually have a fixed height, so they're only going to be as tall as their content is. However, on this screen size, I want these cards to take up the entire height of each of their grid cells. So what I can do is throw one more class name on here on these cards and say at 2XL, I want them to be height full. Now if I go ahead and save it, they'll take up the entire height that they're supposed to. It looks like that fixed them, except for the fact that the daily forecast card is now only 1 tall. So actually, let's close this, look back at our daily forecast here. And we forgot to throw a row span on here, so let's go ahead and do that. We'll say 2XL, row span 2, the same styles that are on our current weather column. Go ahead and save it, and now it should be looking good. The only issue that adding hfull inadvertently caused is that now on some of our cards, we have some awkward space at the bottom that just looks a bit out of place. Like for example, this current weather card here has way too much spacing at the bottom. That doesn't quite look right. One thing that we could do is we could go again, actually back to our card components here. Let's go to card.tsx, and we have this children class name. Let's go ahead and add one more utility on here. Let's say that on 2XL screen size, so on this screen size, we're going to give these flex 1, meaning that at 1536 or above, the children of the card need to fill the rest of the space that they're given. So we can go ahead and save this, and now what we could do is go to each of our individual cards, like for example, let's say the daily forecast. We can go onto the children class name here, and we can say something like 2XL, justify between, and now these will evenly space out and fill the remaining content of the card in terms of the height. And we can do the exact same thing for current weather. So let's go to current weather. On the children class name here, we will throw 2XL, justify between like this, and it again spaces them out. And this works because these cards are both flex call. So if we do justify between, it'll space them out to fill all the remaining height. And then the very last thing would just be to fix some of the awkward spacing on the hourly forecast card, because there's just this empty space kind of chilling at the bottom, which I don't think looks very good. What we could do is we could close both these files here. We could go into our hourly forecast and go to the div that's mapped out for each hour, and we could throw a 2XL, justify between, which would stretch the items to actually match the height. However, now since we added some more space between each of the items, let's scale everything up slightly in size. So what we'll do is we'll go to both these p tags right here, and we're just going to throw a 2XL, scale 110. Again, I want to reiterate the fact that I'm using 2XL here a lot, just to be sure that I don't mess it up as smaller screen sizes. I only want these changes to apply on this big screen size, hence why I'm using the breakpoints. So we'll do 2XL, scale 110 right here. We'll also add the exact same thing on this p tag down here. So we'll add that. And now if we go ahead and save it, now the text is scaled up to look slightly more appropriate. And lastly, we'll just scale up our weather icon. We know the weather icon takes in a custom class name if we want to control the size. So what we could do is just give it a class name here, and we will say at 2XL, instead of being size 8 by default, we want it to be, I don't know, size 10. Now if we save it, the icons are going to get a bit bigger. And now with these changes, our dashboard actually looks great. Before we call it good on the responsive design, let's test every breakpoint and make sure we're looking good at every single screen size. On this computer screen size that we've been at for a while, our side panel looks great. If we try and scroll down, we can't because this all fits on the dashboard. Let's start now scaling down. The second we drop below 1536, so obviously here's 1537, so we're at 2XL. The second we drop below it, now we go to this format where current weather card and daily forecast are side by side, but the rest is still width full. Now if we keep going down, let's keep shrinking, and let's see how this adjusts. Still everything's looking great. And eventually if we keep going to 1024, the sidebar is going to drop out, and now we have plenty of real estate left for our dashboard, and we can open and close the sidebar at will. If we keep getting smaller, so eventually we'll hit below 768, eventually we go to just a single column layout for everything, which is standard for most small screens. And we're going to notice actually, if we start to get too small, it starts to look really horrendous. Phone screen sizes are going to be about, I think, 400-ish pixels. So if I go on like an iPhone right now and look at this, this looks completely unusable. This looks horrible. Go back to our responsive mode here and go slightly. It looks like around the, I don't know, 700-ish mark, it starts to get to this point where the actual sizing of the dashboard starts to disconnect from the rest of the screen. And what I think is happening is we haven't really touched the styling of the header at all. This header has kind of just been chilling here. And my guess is that the CSS is trying to make the page account for the header width, so we get this horrible looking space start to just scale between our cards and the side of the screen. Let's go ahead and fix this real quick. Let's head back over to our dashboard component, and let's just go ahead and collapse this entire grid here, just so it's easier to see what's going on with just the header alone. So we'll go ahead and reopen that, and we'll focus on these couple of divs right here. First of all, this has been bothering me for a little bit. I actually want to change this hamburger to size 6 instead of size 8, just to make it a bit smaller. One of the issues we're having with this header that you can see already right here is this map type is wrapping. and it's not something we want. Ideally, it always just stays like this where it's in one row and it doesn't just wrap down like this because then it starts to get a bit awkward. So let's go ahead and go to the H1 that has map type, and we will just throw a white space no wrap on it. That way, that is never going to be a problem. Now, no matter how much we go big or small, it always just stays in one line. Now, the recurring trend you're going to notice is whenever things get small on a screen, generally we go to a single column layout. So having both these drop downs in a row together gets a little bit weird when we want to get really small. Because if I get to, I don't know, say 500 pixels, both the location and the map type drop downs are just super cramped. And to me, it doesn't make sense to actually have them like this. I think that once we're at a small enough screen size, these drop downs should go to a flex call format so they're lined up vertically instead of being in a row. If we go ahead and start bigger, let's see at what point these start to become bad. It looks like it's mostly okay right here. And then roughly around this point, around the 768 breakpoint here, is when it starts to kind of all fall apart. We lose the hamburger and the sizing starts getting weird. What we can do in this case is go to this div right here that has flex gap 8 that holds both the drop downs and the labels. What we can do is we can say by default, we want it to be flex call. However, once we're on medium screens or higher, then we want it to be flex row. And because we'll be vertical on smaller screens, let's take away this gap 8. Let's actually make it gap 2 when we're vertical. And then once we are horizontal, so we're on MD, let's say it is just gap 4. And now if we save it, it's still fine on this screen. However, once we get small enough, then it goes to the column layout instead of being rows. So it gives us way more room to work with and we don't have to worry about it getting super cramped. Obviously, you can see the hamburger is now completely busted because it's just kind of sitting off screen here on the right. Let's address that in a second, and for now, keep scaling down. If we go farther and farther down, this header is still going to be overflowing. It looks like only once we get to the point of, I don't know, I mean, it's about like 500-ish. You can see the hamburger starts to kind of come back into the screen here. So like, I don't know, right here-ish. But before then, the header is still overflowing because this hamburger, you can see it's getting cut off. However, the problem is right now, with the size that we're working at, there's no breakpoint below 640. 640 is actually SM. So essentially, if we're working below 640, we can't make any more breakpoints under here. However, I lied because we can actually use our own custom breakpoints and we can define them ourselves. So how we can do that, for example, is by going into our index.css and finding the block here should be at the bottom. That is just this right here. That is just at theme. We can add our own custom breakpoint by going into here and saying dash dash breakpoint dash, we'll call it XS for extra small, and set it to 500 pixels. Just like we add colors by specifying the color, like for these, or for radius, we can do the exact same thing with breakpoints. And we're just setting this particular breakpoint to 500 pixels, and we can now use it like any other breakpoint. So if we go ahead and close this and head back to our app now, what we'll actually do is for this div we have right here that we added our stuff to, let's actually take this and let's apply this only on the inner divs. So on this one and on this one. And I'll show you what we're doing here in just a second. So let's take this, throw it on these two. And now that we made that custom breakpoint being XS, let's actually use XS on this div. We will go ahead and keep it flex call. But we're going to say once we're at XS or higher, then it should go flex row. We'll also say we can maintain the gap 8 that we already had once we're at that big enough screen size. If we go ahead and save it, we can see this is the change that it just made. It's still in a row because we're above 500, but if we get below it now here, now it drops down to a column. And we lost the gap here between these two things. Let's make sure to keep a, I don't know, gap 4 right here, just to create that spacing. So it goes to the columns here. But once we're here, it's still in the row format. And I think this way right here might be one of the better ways to go about it. So as you can see already, our screen isn't shrinking nearly as soon as it was before. We're not getting that weird thing where the size is actually disconnecting from the rest of the page. There's still some problems obviously, but we have that main problem fixed now. Just to make sure it looks fine on bigger screens, if I go out here, it still looks the way that we want it. Now it just shrinks down once we run out of space, and then shrinks down again. Let's fix these last couple of things. First of all, when we're at this small of a screen size, it doesn't make sense for these dropdowns to take up just a little bit of the width. I think when we're at this small a screen, we need to make these dropdowns right here take up the entire width of the screen. So what we can do, for example, is go to location dropdown, And right now, it's just hard-coded to be 180 pixels. So what we can do for that is we can say we still want to maintain that exact size if we're at or above 500 pixels. However, if we're below that, then let's just make it width full. And now, this will be the full width of the screen. And we'll do the exact same thing for the other dropdown, which is the map type dropdown. So go in here, 500 or above, it's width 180 pixels. Otherwise, we want it to be width full. Go ahead and save it. And now they're both the full width of the screen. And now the last obvious problem that we have to fix is this hamburger right here just looks awful sitting here. It's just kind of chilling in a super bad spot. And that's because this overall div layout right here is still flex call. And also the hamburger is ML auto, which means it's going to go in the third column below the other two and be right aligned. So it just looks horrible. What really needs to happen at this point, which most apps actually should do, is once we're small enough, we should probably have a separate header component and not try to make everything just fit. Because at a certain screen size in most apps, trying to cram header stuff into the body gets really weird. So for example, this hamburger button is normally something that would be on the header. When we're at big enough screen sizes, it's just here kind of sitting at the top. But once we get smaller and we start getting more specific with how we're wrapping this stuff, having the hamburger there just doesn't make any sense at all. Because right here, it's just super out of place. So what I can actually do is go to this button that has the hamburger. I'm going to give it a class name of hidden by default. So for us small enough screens, it won't even be there. But at excess, so once we're at 500 pixels or higher, then we will make it block. That way it's going to appear visible. If we go ahead and save it, that already makes our page look a lot better with that hamburger not being there. Now that we have this, let's make a completely separate mobile header component where we can put the hamburger in. So I'll go to our file explorer over here. Go to our components and make a new one that I will just call mobileheader.tsx. Go ahead and close this. TSRC to make the component. And let's make some basic styles here. Let's set up this div. We're going to say class name is going to be width full to take up the full screen space. And let's just hard code it to something like H16. E4 to give it some nice padding. And we'll also give it BG background. Normally I wouldn't want the background of my header to be the exact same as my dashboard, but in this case, I think it may actually look better this way. And lastly, we'll just throw sticky top 0 on this. That way it'll always be stuck to the top of the page. The reason why I'm using sticky and not fixed is that sticky will make this header take up space in the DOM, so I don't have to worry about shifting everything else down. If I were to do fixed, for example, I'd have to shift stuff around to make it look good. Sticky is just easier in this case. Now let's go ahead and put some content in here instead of just having mobile header. So what we'll do is we'll go into here and we will actually copy and paste our hamburger button into this mobile header. We don't have access to hamburger in here, so let's go into app. Let's find the import for hamburger. It should be right here. Go ahead and copy it and paste it. That way we have the hamburger. And it's important to remember that the reason that we made this whole component was to only show it on small screens. So essentially, if we're over 500 pixels in size, we actually don't want to show it at all. So let's just do excess hidden, just like this. So anything above 500 pixels, we'll be hiding this component entirely. I also now just don't have the set is side panel open. So let's go ahead and comment out this on click for just a second. Now let's go ahead and save this. Let's go to our app here and let's render out mobile header up here and just see what it looks like. Save it like this. And here's what we have. Just so we can see it, let's actually go in here. Let's make sure we'll remove BG background for a second. Make sure it is BG red 500. So we can see it up here. It looks like, oh yeah, we don't care about these other styles now, like hidden and XS block. So let's go ahead and just get rid of this. And we can also get rid of this LG hidden. And let's change this back to BG background. Go ahead and save it. And here's what this actually looks like now. You can see that as we scroll, this should stay at the top of our screen. Looks like it's not. Actually, yeah, it looks like it's not there. It stays fixed for a little bit. Actually, before we do that, let's fix a few other things. First of all, this hamburger should be on the far right of the header, not the very beginning. Instead of relying on ML auto to do that, we could actually remove that. We can just say flex justify end, and that should make it align to the right side. And just to make sure this header goes over our map, let's give it a z-index of 1001. However, if we start scrolling, we'll still notice the header is not quite staying fixed the way that we want it to, or sorry, staying sticky. And we've seen it for a little while now, but we have this weird little side scrolling issue where it seems like the width of the page is just more than what we actually have. We go ahead and refresh this just to make sure. Looks like, yeah, it's still there. So let's try and fix that. I think the issue may be that in our app here, we have this W full. Let's go ahead and just get rid of that. And I think this actually might fix the problem. Not 100% confident. No, it did not fix it. Okay, well, I closed and reopened the responsive DevTools, and now it's working perfectly fine. So I guess that's a non-issue. I'm not really sure why it was doing that. Let's fix the sticky thing real quick. Actually, that one also appears to be fixed. Might have just been the responsive DevTools. Sometimes these DevTools, when you're in responsive mode, stuff just kind of bugs out and doesn't quite work properly. But now, whether we go up or down, the header appears to be sticky because it's not moving at all. It's always staying at the very top of the screen because you can see the hamburger staying fixed, which is exactly what we want. Okay, so now the last thing that we should actually need in here is to make this hamburger button actually functional. We just commented out the onClick. Let's actually uncomment this. And we know this is a piece of state that is in the parent of this component, so let's just pass it down as props. We'll say that it is expecting type. I don't know if I typing that out. We're going to say this, which we know is just going to be a dispatch of set state action. And that's going to be a Boolean. Dispatch is, of course, imported from React. And then we will extract this out of here. Now save this. It should be good to go. But we'll go ahead and pass it down now. Set is side panel open to set is side panel open. And now, if we go ahead and save it, go back here, this hamburger should work the exact way we expect it to. We can now open and close the side panel at this small screen size. So now, what's really cool with this mobile header is that once we're on big enough screen sizes, it doesn't even show up. So now we're at 550, so we're above the excess breakpoint. So this entire component is just hidden. We still have the hamburger right here. That works the exact way that we want it to. But now, when we go below small enough sizes, we actually render out a separate header component that has the hamburger in it that works in the exact same way. Pretty cool. One thing we should quickly fix is there's a bit too much spacing, I think, here between the bottom of the header and where this first map type dropdown is. It looks like there's just some awkward kind of space there. Because if we go to our app and look at this, it is using P8 all the way around. Now, I think that's normally fine, except when we're on this screen size, it just looks like it's too much. So let's actually change this. Let's say the others can be P8, so the left, right, and bottom, but the top should actually be, we'll say PT4, but then on big screen sizes, we'll still be fine with PT8. So XS, PT8, just like this. And if we go ahead and save it, I think that looks a bit better, not having so much padding at the top. So essentially, PT, right here, padding top, is more specific than just padding. So PT4 is going to override P8 normally. However, once we get to XS, we default back to PT8. Let's now go through a couple of different small sizes just to see how everything works, especially on mobile. So right now we're on responsive. Let's go to iPhone SE. It looks like right here, everything looks almost great, except for the fact that, especially this map legend right here, is just completely out of place. It's just way too big. So what we'll do actually is go to that map component, which should be the map legend. Right now it's hard-coded at width 96. Let's say only do that if we are on XS or higher. Otherwise, let's just do it as half that width, so we'll do width 48. Now go ahead and save it, and that looks quite a bit more manageable. If we get back to testing this, we know that scrolling this still works perfectly fine. If I go click on this, it opens the side panel just the way that we want it to. And it looks like all this is working beautifully. Just out of curiosity, let's go to landscape. And here we can see it also looks good. I can scroll down here, see all of our cars that are width full, and everything appears to be in order. I'm not a graphic designer, so I'm sure there's ways to make this look even better. And maybe there's certain cases or things that I'm not thinking about, but that's something that could be added if you wanted to make improvements to this app. If we just go back to portrait mode, let's go ahead and change this to, I don't know, pixel 7. Should be a bit bigger, but same kind of idea. Our dropdowns still work perfectly. Our side panel opens the way that we expect it to. Our map works. We can click on it, load some data in, go over here. Let's say I want to know somewhere near Vietnam, go here. All that works perfectly. Then we have our cars down here, same thing, and they all look great. This still scrolls horizontally, so it appears to be working right, and everything else just looks super tidy. Now let's put this back in responsive mode and go through these breakpoints one last time. So we're small here, we know what this looks like, we've just been messing with this. Mobile header, all this works very smoothly. If we start expanding it, we get over 500, mobile header goes away, and now the hamburger plus the dropdowns are all in the same div. And everything looks good, all in a single column layout. We eventually hit 768 here. We're now still single column for the most part, but these go to double column. keep going, and it looks to be good. Side panel reappears, we hit the large breakpoint, and everything is just as we intended to be. Now there's just one final thing I want to do in terms of responsive design. That's going to be for our desktop view. If we go back to having this desktop view, the view still looks great. However, one thing that we're going to notice is if we start collapsing the height, this view is going to start looking kind of bad pretty quick. As you can see already right here, the stuff is already overflowing out of the grid. So it's getting like this, stuff's getting cramped together, and suddenly it starts looking real bad. The reason why the other screen sizes are fine and don't have this same problem is because this screen size at 2XL is the only one that has an actual defined height. It's supposed to be the height of the screen. So on other screen sizes, it's expecting it to overflow. That's fine, but on here it's not, and that's why it's causing this weird visual shift. Now, it's worth noting that this is probably not going to be a very common occurrence. I mean, this aspect ratio is pretty out of whack. It's quite a bit wider than it is tall. But certain laptop screens I've noticed especially can kind of have these weird dimensions where the aspect ratio is like a 21:9 or something that actually does get quite a bit wider than it is tall. So you end up having this really weird layout shifting stuff that happens because you're at an aspect ratio that you're not probably testing all that often. Because, like I said, this situation is likely an edge case, I don't think we need to start reordering grid items and making this more complex than we have to. It looks like at about roughly, if we keep going down, roughly 1080 pixels in height here, it starts to get a little bad. Actually, not even that. It's more like, I would say like 1120 pixels starts to look kind of rough. What we can do as a quick band-aid to that is we can go to our app here. We can go to the div that has this 2XL height screen. And on here, we're just going to add a min height. We're going to say 2XL. It's going to be min height 1100 pixels. Actually, we'll do 1120 just like that. Now we go ahead and save it. And this will be the min height, so that if we go below this, we'll just have to overflow. No more trying to cram everything all together in the screen height. If it gets too small for whatever reason, we can just start scrolling. The big thing with responsive design is the width. That's why all the breakpoints are width based. You know, SM, MD, LG, they're all based on the width of the viewport, not the height. When you start worrying about the height, things get a little bit weirder. You can use height breakpoints, or you can just do something like this, where things scroll if the width to height ratio gets out of whack. And that, ladies and gentlemen, should wrap it up for responsive design. Now that we've tested practically every screen size, it is safe to say our app is pretty responsive. Maybe not 110% perfect, maybe not completely flawless, but it does look great on each screen size, and we've verified we have no major issues with it. Again, I'm sure there's improvements to be made here and there if you'd like to on your own time, but now that we have this looking great, let's move on. Before we move on to the very last thing, we made some changes to our cards like daily forecast and current weather, but we didn't update our skeleton cards with those changes. If we don't make these components match one-to-one in terms of how their size and how they look, we can get some weird mismatch problems. So let's add those real quick. Let's open both the current weather card and the current weather skeleton. So we'll open this here and the current skeleton. And you'll notice because we added stuff to the children class name of current weather, it's going to be different from this children class name. So let's actually take this whole thing and just copy it over to make sure it still matches up perfectly one-to-one. We wouldn't want that to get out of whack. We'll do the exact same thing for the daily forecast. So we'll close these here, go to daily skeleton, and we will also go to daily forecast. You can see this class name's obviously been changed. So let's take this, copy it, and then just copy it over to the children class name here to make sure they are perfect one-to-one. We'll also do the exact same thing for hourly forecast and hourly skeleton, except we shouldn't have to change the children class name. We open this here, and we also open this. The only things that we actually added was, first of all, this 2XL justify between. So let's take this and add it to this div right here. And then we also just need to take the scales that we changed. So we made this 2XL scale 110 on both the P tags. So we'll make sure to throw that on these two. And then this skeleton went from size 8 to being size 10 for 2XL. So we'll take this and we will go ahead and throw that just on here. And now these should also match up one-to-one. And it seems like I might have forgot, but while we're here, let's make sure this is rounded full because it should be circular since it's an icon. And lastly, let's look at the additional info card. So we'll go into this and we will also go into the additional info skeleton. Looks like all we changed in here was this children class name. So let's take this, copy it, and we'll go ahead and paste it over. And now, taking into account our responsive changes, our skeleton loaders should match with their actual components one-to-one. No matter what screen size we're on, whether it's SM, MD, LG, 2XL, the skeleton loaders and their actual cards are going to match up perfectly. Alright, so we've come a super long way, and we have one final thing I want to do on this app before we call it done. And that's going to be making a toggle for light and dark mode. This is something that is becoming more and more common in modern apps, so I want to show you how it's done using Tailwind plus Shadcn. We're going to have some help from Shadcn on this one, especially with the styles that it gave us in the index.css file. But I'll explain exactly how this works, and I will show you every single step. First things first, let's get a switcher component set up that will actually toggle us between light mode and dark mode. If we head over to Shadcn, they have a really nice switch component that I think we could use. It basically just works like this. You just toggle it back and forth, and in our case, because it's binary, we can just go between light mode maybe on the left and then dark mode on the right, or vice versa. Doesn't really matter. We'll go ahead, and this should be the last actual Shadcn component we install. We'll take this command, go ahead and open our terminal here, make a new one, and we will add this switch, and now we have the switch in our app. So now that we have this, let's actually make the final component that we're going to make in this video. What we'll do is we'll open up our file explorer, go to components, and we will make one called light dark toggle.tsx. ES RFC to create the component, and in the JSX here, let's just render out the switch component just like this. That comes from UI. On SVG repo, I found two good SVGs that we can use. I have this sun.svg that we can use for light mode, and then I have this moon.svg that we can use for dark mode. Just to get the sun and the moon imported into this component here, I'll go to where we have our app. Let's take this hamburger, for example. I don't feel like retyping this all because I'm kind of lazy. Get this in here. We'll call this sun, call this one moon, and we'll make sure we name them accordingly. I think it was just sun.svg and moon.svg. Yep. So sun.svg and moon.svg right here. What we can then do is wrap this switch right here in its own div. And now around it on either side of it, what we're going to do is render the sun on one side, and we will render the moon on the other. And to make this switcher look like a switch with two SVGs on each side in a row format, what we'll do is on this div, just give it a class name of flex. We'll say item center and gap 2. And then for each of these SVGs, let's give them the class name. We'll just say, I don't know, we'll try size 5. It shouldn't be too big, but just big enough to see. So let's go ahead and add that. Now that we have this, let's go ahead and save it, and let's render it out in our app. Let's go back here. Let's go to app here. And if we go to where we have our dropdowns at, we have this div right here that has the hamburgers. Let's actually render it right here between the hamburger and the last dropdown. We will just say light dark toggle, just like this, making sure to import it. And if we go ahead and save it, here it is on our page. Oh, and I forgot, because we're on dark mode now, let's actually add invert to both of these right here. That way they turn white. Now if we go ahead and save it, here is our actual light mode, dark mode toggle. So we have a sun on the left and a moon on the right, and now we can just toggle between them. I want to make sure that whenever this hamburger is actually on the screen, that this light and dark mode toggle is still aligned to the far right side. Right now it happens to look like it because the spacing is just perfect. However, let's make sure that by wrapping both the hamburger button and the light dark toggle in a div here, just go ahead and give this div a class name of ML auto, so it's spaced to the far right side, and we'll say flex gap for item center just like this. And because we have ML auto here, we won't need it on this hamburger. Let's go ahead and just get rid of that here. And now that should make sure that styling looks good on all screen sizes. Again, still looks the exact same here, but that'll just ensure it stays good when we get bigger. Okay, so that's cool and all. We have the switcher that actually looks functional, but it does literally nothing right now. So let's actually do what we came here to do. And that's making the switcher toggle between light mode and dark mode. How we can do this is kind of up to us, because ultimately there are a few ways we could approach this. Typically, the way I like to handle light mode and dark mode is to wrap my entire app in a provider, which I usually call a theme provider. This provider will have the theme, which is only two options, light or dark, and also a function we can use that will toggle these between each other. The reason why I do it in a provider normally is because sometimes, especially on bigger apps, you might need to know in really deeply nested components whether we're on dark mode or not. Styling in dark mode can get a bit tedious, so I like to make sure every component in my app has the ability to know whether we're in dark mode or not. So I actually lied a second ago when I said we're making the last component, but now we're actually making the very last component, which I will just go ahead and call theme provider. I'll go up here, components, theme provider .tsx. Go ahead and close out of this. tsrfc to make the component. And at the very top of this file, let's to be explicit here, make a type that I'm going to say is theme. That is either just light or dark. Dark as a string. In terms of the context this provider is actually going to pass down, let's type it right here as type theme context type equals this. And like I said, it'll have two things. Theme, which is of type theme, and then it'll also have toggle theme, which we can just assume is a function that returns void. Now that we have these types, we can just say const theme context equals create context, and we'll make sure this is of theme context type or undefined, and it will default to undefined, making sure to import create context from React. This is the standard way of defining a context always outside of a component. Now that we have this, like all providers, we need to wrap the JSX with the context. So I'll remove this div here. We need to wrap it with theme context.provider like this, and we can put the children inside of here. Children, like in all providers, are just a prop, so we can add to our props here. We can add children, which is always just of type React node. Then we can get children out of here. Again, children's a reserved keyword, of course, and render out children just like this. This theme context provider is going to wrap the entire app, which means that children is literally the entire app. So the entire app is going to have context to whether we're on light mode or dark mode because of this. How we pass that down is actually by giving this a value prop. Right now it's going to say it's missing because we don't have it. But we basically need to give it a prop just like this. Now for this particular value, how I normally do it in a provider and how you normally should do it is just to make a state for it. So we'll say const theme, and this will be set theme. Use state is going to be of type theme, and we're going to default it actually to dark mode to start. And then we'll make an easy function to toggle between the themes. We'll just say const toggle theme. It's going to be a function, and it's going to be super simple. We're just going to call set theme. We're going to get the previous value out of here, and we're going to say if previous equals dark, then when we toggle it, we're going to go to light. Otherwise, we're going to dark. And now that we have this, we have both our theme and our toggle theme, which is exactly what this type expects. So all we have to do is pass in an object for our value and just give it theme and toggle theme like that. And now this provider is all good to go. Again, just to reiterate, this theme provider is going to wrap the entire app, and all it's doing, it looks kind of complicated, but all it's doing really is giving our entire app context to whether we're on light mode or dark mode because of this theme here. And then we give every component technically the ability to change whether we're on light or dark mode with this toggle theme. Now that we have this, we just have to go to main.tsx, which is the entry point for our app. And all we need to do here is just wrap this in a theme provider just like this. And now our entire app has context to whether we're in light mode or dark mode, depending on what this state is. What we should do now is make a hook to consume the value of this context. Technically, because I'm doing this as just a one-off, I don't have to do this, but I think this is a good pattern to get into. Basically, in whatever file I made my provider, I'll usually export a hook. So in our case, I'll say export const use theme, just like this. It will be a function, like all hooks. And all it's going to do is say const context equals use context, and it's going to use the theme context. Use context should be imported from React. And then we'll completely eliminate the possibility of undefined by just saying if, for whatever reason, context doesn't exist, then we're going to throw a new error saying use theme must be used within a theme provider. And then all we're going to do is return context just like this, and voila, we're good to go. This is actually a pattern that I was taught that I think makes using context really safe and exposes them in a convenient hook. If you try and call use theme now and somewhere where you shouldn't, it'll throw an error. Otherwise, you know you're good. This provider wraps the entire app so everywhere should be safe, but in general, I think it's a good thing to do. It just makes it so that in every component where I want to use a theme, I don't have to call use context. I can just call this hook and it's already there for me. So basically, wherever I call this now, wherever I call use theme, I can get the theme and the toggle theme out of this context. Now that we have this set up, let's take this and let's actually head back to the light dark toggle. because we wrote that convenient hook, all we have to do to get these out of here is say const theme, toggle theme just like this, equals use theme, and now we have access to the light mode or dark mode, and we also have the ability to change it between light and dark. This switch right here is going to take in two primary props, checked and onCheck change. For checked, we'll just say it's going to be checked if the theme is equal to dark, because the moon icon is on the right side of the switch. And for onCheck change, meaning whenever we actually click the switcher, all we're going to do is just give it toggle theme. And it's actually really that simple. And now technically, this switch is fully functional. Whenever I'm switching it to the light mode here, we're actually setting this theme in our provider to be light. Whenever it goes to the moon, this is going to switch to being dark. So we have our light and dark mode working correctly in our actual React state. But what good does this actually do? Well, let me show you the magic now and the reason why we did this. If we open up our DevTools here, you can see that from the beginning of the video, we've had this class equals dark on the main body of our HTML. This is what's making our app dark mode right now. If I just completely get rid of this, so I go here, get rid of it, now our app goes into light mode. Pretty cool, right? What this means is that what we need to do is listen for our theme changing. If it changes to dark, we need to add class dark to the root div. If it goes light, we need to remove dark from the root div. So again, if this theme becomes dark, we want it to look like this. The second that it becomes light, then it should go light and remove it. So we just alternate between these two states. And this is actually very easy to do. Let me show you how. We go to our theme provider here. All we have to do in here is just make a use effect, just like this, importing from React, that has theme as a dependency. So we're listening for theme changing. What we'll do is get the root div of our app by just saying const root equals document.document element, just like this. And all we're going to do here is we're going to say if the theme is equal to dark, then what do? Then we just want to say root.classList.add dark, else root.classList.remove dark. And it's really that simple. And just so it's not hard-coded anymore, let's go to index.html. Let's remove this class dark. Completely get rid of it here. Start like this. Now it defaults to light mode here. Let's go ahead and save this div now. We're on dark mode. Click this. Now we go to light mode. Boom. Magic. Every time this toggle is clicked, we're alternating between light mode and dark mode. Now you're most likely wondering how this even works, because I haven't added a single style in this entire app that is dark mode specific. I didn't spend any time using Tailwind, going into components and doing something like the dark selector, where I can go and do dark like this. Because you actually can use this if you're on dark mode. It works perfectly fine in Tailwind, but I didn't do that anywhere. So how is this working perfectly? How does my app know to just change every single color on the page based on what the dark class is? Well, let's go to index.css. Go to index.css here, and I can actually show you. If we look in here, something that happened a long time ago is we initialized Shadcn in our project, and it asked what color palette we wanted to use. After I told it zinc, what it did, and what it always does, is defines a ton of CSS variables that we've seen time and time again. And these are all the CSS variables that we've been using. So we've got a color for background, foreground, card foreground, you get the idea. What you might not have noticed is that under all these CSS variables, but in this same file, we also have at the bottom this dark selector right here. And this is the key. This dark selector right here is a class selector, meaning any element that has dark on it will define all of these CSS variables. If you look right now over here, we're on dark mode. And because of that, we're going to use these CSS variables. And these variables right here are literally all the variables, all the same exact ones that are defined here up top. So essentially, these are going to be the default variables that are used on light mode. However, once we have the dark selector, we use these variables instead. And these are all ones, again, that Shadcn set up. So for example, on our cards, when we're on light mode, our cards look like this. That is because the card is using this CSS variable. However, as soon as we go into dark mode like this, because dark is a class selector that is more specific, this card is going to overwrite the other card, so now we're using this color instead. And that is how literally all these other CSS variables work as well. So basically, in summary, we're in light mode, so we default to just using this root here, So all these CSS variables are relative to light mode. Now, when I click dark mode, we now have the dark selector on, so this class is triggered, and now our CSS variables are redefined. And that is what causes all these color changes when I go between light mode and dark mode. Because after all, our card, for example, our card component is using background card. And of course, like I just showed you, background card changes between light mode and dark mode, hence why the cards change color. I am going to 100% recommend this pattern over spamming the dark selector in Tailwind. This pattern here, where you have variables defined up here that just get overridden by a dark selector, is so much cleaner than going in every single component and saying, oh, I want it to look like this on dark mode, and saying dark, BG red 500, like this. It's actually kind of a cool gradient right there, but no, you shouldn't be just spamming dark mode like this. It's fine to use it in some spots if you need to, but if you want to handle the majority of the dark mode styling, do it with CSS variables. Now that we have this understanding, let's clean up a few things between this light mode and dark mode, because clearly not everything is quite perfect yet. So let's go ahead and head over to light mode. So go here. And now if we look, our SVGs aren't really visible. For example, let's look at our additional weather info down here. If we go to where that card actually is, so additional info, and we look at it, remember we have this invert on here that just inverts the colors. If I go in here and I add the dark invert, so we're only inverting when we're on dark mode, then they appear perfectly fine. However, then I have to go and do this in every single SVG that's in dark mode, and I don't want to do this. So what I'll instead do is I'm actually going to remove every single reference in our app to this invert here. So I'm going to search up invert. Let's just see where all it's used. I'm going to get rid of it here, save this file, and basically everywhere it is, we're going to get rid of it because we're going to solve it all with one style instead of spamming it everywhere. This will make things quite a bit simpler. Remove these here, take this, get rid of this one. Got a couple in here. Let's see. Be right here, and right here. Get rid of all those. Don't need them. And we'll get rid of this one. And now, instead of going individually in every single component and just putting invert wherever we can, what I can instead do is just do it one time. I go to index.css, close all these extra tabs here. And all I have to do is just go down here somewhere, and I can actually write a style for this. I'm going to say .dark SVG. So any SVGs that we see that are in dark mode, all we have to do is say filter invert 1. And now that's going to do the exact same thing. So if you notice, these icons still look good on light mode because they're black. If I go to dark mode here, they now look good because they're white. So it's the same thing we were just doing, but I'm doing it in one spot instead of doing it in like 10 different files. Honestly, with where it is right now, I think dark mode looks great. Everything looks crisp, the cards look great with their slight gradient, and everything seems to just kind of pop well. However, light mode is a bit of a different beast. It doesn't look horrible, but there are some improvements to be made. First of all, these cards that are on the dashboard and the background color are clashing big time. The cards aren't distinguished from the background pretty much at all, so it almost just looks like one just massive white mesh. And I'll show you exactly why this is. For some reason, I don't know the logic behind this. If you go up here to the top, you can see we have a problem here. Card is 100, so pure white. However, background is also 100, so pure white. So the card and the background are quite literally the exact same color. They're different on dark mode, as you can see here. Card is this 021006, and then background is 0141. So clearly here they're different on dark mode, but on light mode they're the same, which I think looks pretty bad. Generally, when we're in light mode, we want the cards to be slightly darker than the background. This is the opposite of dark mode, where you want the cards to be slightly lighter than the background. So instead of changing the background, let's look at card here. Instead of this being 1, let's make it slightly darker. Let's do, 0.97. So it just very slightly offsets the white. Save it, and now that's a little bit better. It doesn't completely change it, but it makes it at least offset enough to somewhat tell a difference. One more thing that we should add to make it help even more is throwing a border class on this, especially if we're on light mode. So let's go into our card here, and we have no border on it right now. So let's just throw a border like this, go ahead and save it. And now that makes it look even better, just more distinguishable from the background. Having the border helps create some separation between each of the cards so you can see where each one kind of begins and ends. I think it's fair to assume that we don't need this border when we're on dark mode. I think it's a little bit overkill. I mean, it does look kind of okay. but I think we liked it before. So let's just say border like this. And we're on dark mode. We'll just say border none to go without it. There's really no reason to have it on dark mode because there's plenty of separation. It's just more needed on light mode to create that more shadowy effect. If we go ahead and open up our side panel, we're going to notice a couple of problems. Actually, only one main problem really. That being that the slider, not the actual slider itself, but the track for the slider is pretty much invisible. I mean, it's super white against that pretty white background, so it's hard to see. If we head over to the side panel component and we look to see where our slider is, should be actually down here. Our slider's right here. Let's go ahead and control click into it. And if we view it, you'll notice that we have this BG sidebar right here. However, clearly that BG sidebar does not look very good in light mode. So let's keep this BG sidebar if we're in dark mode. Let's make it something different when we're on light mode. We'll instead try BG foreground. So when we're in light mode, use BG foreground. When we're in dark mode, use BG sidebar. Now if we go ahead and save it, the track is actually visible now. However, I can tell right away this looks way out of place and looks way too strong against the background. So let's make this, I don't know, 25% opacity there. And now I think that is much better. And one thing I want to take a look at right now, especially, is our skeleton loaders. If you just notice right here, our skeleton loaders literally aren't showing up like at all against the white. That's because the color of the skeleton loaders is pretty much white, just like the cards in the background. So it looks really off. That's not a big problem at all though. If we go to our skeleton component here, we can see that normally it is BG accent. Because it looks great on dark mode still, we don't want to change it. Let's say it's still BG accent on dark mode, but on light mode, we're going to do the same thing as our sliders. We're going to say BG foreground /25%. And now if we go ahead and save it, and we go and test our skeleton loaders, now they should all be visible. At least the ones that are on the dashboard. So let's look at these real quick. Go here. Looks like all these skeleton loaders are showing up exactly the way that they should. It also looks like real quick this current weather card at this particular screen size is not quite the same size for the skeleton loader. Real quick, let me open those. Must have been something we missed. Go to the current skeleton. I believe, oh yeah, it's coming from this MD-PB11 here, so we need that in here. Go ahead and copy this, paste it over, just fix that real quick, and now they should be the same size. So now these skeleton loaders look and work great. However, if we go back to the side panel here, it looks like they are not quite visible on this card. And I believe that is because if we go to our side card skeleton, we're actually hard coding this background on here. But we only want to do that if we're on dark mode. So let's take dark, the selector here, and let's add it on all of these skeletons, just so only like that on dark mode. But on light mode, we use the regular color. So here, and boom, now the skeleton loaders are great on light mode. And if we go to dark mode, like this, boom, 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 they also look great. And the very last thing I want to do to make sure this all is perfect is go into responsive mode real quick, shrink down super tiny, and we'll notice right here, we now have this problem of the same thing we had with the hamburger. So let's actually do the same thing we did with the hamburger. Head to our app here, and this light dark toggle. And what I'll do here is I'll actually wrap this light dark toggle in a div. And I'm just going to say, same as the hamburger, it's going to be hidden. But above XS, we can make sure it is block. Now, if I go ahead and save this, it's not going to show up right there. And we'll go into our mobile header component. We will take the light dark toggle, just like this. And let's just go ahead and copy and paste it into here just like this. Import it, save it. And now we have our light mode dark toggle up here when we're on mobile. Just to create a bit more separation, let's just do a gap 8 here. Now they're separated. We have light mode and dark mode on mobile, plus the hamburger on mobile. We go bigger. And of course, it looks the way we want them to. Get out of responsive mode on a big screen, and there they are, still working perfectly. And that, my friends, is going to wrap up this video. It took a long time, but here we are. We started completely from scratch with literally an empty VS Code terminal, and we built an entire app from nothing. An app that interacts with an API, uses modern tech stacks like Tailwind and TanStack query, and has just about every major thing you need to consider when developing front-end React apps. Of course, it's not 100% without flaw. Like I said, I'm not a graphic designer, so there are certainly improvements that can be made to this. If we wanted to spend 40 hours together on this video, we could have hyper optimized everything and made it 100% flawless, but I think we've got everything we need to consider this app a done deal. I'll leave it in your hands now if you want to mess around with this code on your own time and make any improvements or changes you want. This entire code base is going to be linked in the description to GitHub, so please feel free to mess around with it or revisit the code if there's parts of it you don't fully understand. This video took me a fat second to make, so I really appreciate all the support for it, and it would mean the world to me if you would consider liking the video and subscribing, as it really helps my channel engagement and helps me grow my audience by helping me out in the YouTube algorithm. Well, with that being said, it's been a fun ride. I hope you guys all found the video helpful. If there's any questions, concerns, criticisms, or anything else that you have, please feel free to leave them in the comments, and I'd be more than happy to respond. Take care, everyone, and I'll see you in the next one.